Okay, well, good morning, everybody. We're here early, very early. The Nats is actually early as well, so.
Discovery, go at throttle up.
Hey, Bird Dog, Tier 2 4713 sub. I hope somebody brought some bagel. I don't know. I got the. I got the coffee. Just, just, just give me a second. It's early. Just give me a second. Just give me a second, okay? Just give. Yeah. Yeah. And look, oh, that led me right to my coffee machine. All right. I hope it's a large cup of coffee. That's the only type of coffee that I drink. Got that in a liter of cola. Liter of cola. Do we make liter of cola? All right. Okay, so the Artemis 1 tanking test. They're going to test to see if that hydrogen valve on the hydrogen tail surface mast umbilical is working correctly. So let's bring the stream up. Does that look like spit to you? Yeah. Screw it. All right, there we go. So there we go. There's a live look at the rocket on the pad, and we will wait for an update here. It should be starting the tanking test here in about a minute. Okay. I just burnt my tongue. Yeah. All right. All right. So 7:15 now. Let's see what happens. Hey, Pain-Free, what's good, man? How you doing? Pain-Free, you see that they're unveiling the B-21? Oh. Hey Nora. Bossy, what's up? Morning. Yeah, it ain't morning for you guys, but thank you. Yeah. Good morning. This is early. Well, it's early, but it's not too early for me. I usually wake up like in about 45 minutes. But I did have a nasty case of, you guessed it, insomnia. I had a nasty case of insomnia last night. Actually, it wasn't insomnia. It was more I was working on another project. No, you can't hear about it. It's classified. I'm not at liberty to say. It's above your pay grade. It's false. It's fiction. We made it up. It's false. Fiction. Nope, not this time. Anyway. I had a breakthrough on another project last night, so I decided to work on that. Oh, a B-21, huh? Don't panic. Yeah. It seems pretty neat. Here, let's peep over at NSF. Let's see what they're up to.
Up a lot more slowly in the liquid
Oh, they got the feed, man. Look at the feed.
hydrogen down the cross-country propellant lines called the transfer lines. And there's also the main fill and drain valve that it will get to. And under that lower pressure, it will basically allow more time for the systems to cool down properly, to be at their proper pressures, to be at their proper temperatures. And then the lower pressure is basically less stress overall.
Oh. Hey, photobomb. It's not, no, this is a tanking test, Riv. Tanking test. It's a tanking test. It's not launching today, the 27th. No, tanking test. But also, I don't hate what I'm seeing right here. 27th. Sebi, I've been hired by a team to shoot the GT Masters German GT4 season finale at the Hockenheim Wing. In October, I'm officially working in motorsports. This is fine. Congratulations, buddy. What is the link for that channel? This channel? This is NASA Spaceflight. There you go. Hey, logo. That's cool, Sebi.
SLS hug emoji into chat.
About to say, we have an emoji for that.
Yeah, right? It's perfect.
Yeah. And Philip in our back channel is also giving one more piece of the puzzle there, Jack, to your question about the lower pressure. Philip is saying it's sounding to him like they used a more gradual pressure profile when they were testing the liquid hydrogen tail service mast umbilicals over at a facility called the Launch Equipment Test Facility.
Discovery,
and it looks like they are now going back to something that's closer to that profile that they have actually tested. And if that's true, no reason to believe it's not from Philip there, but I just want to add that that sort of means that basically the entire way that SLS's components here got tested were then not the way that the launch team decided to utilize them. If they tested all the ground systems at lower pressures and then used higher pressures, not surprising, we're seeing problems that weren't caught in ground testing.
No excuse.
Same thing for the core stage when they changed the procedures at Stennis, but then and it worked, and then they got to Kennedy and they said, well, we're not going to use the same procedures that worked at Stennis. We're going to use our own. And then all of those procedures didn't work, so they had to go back to the Stennis procedures. Seems to me like a potential big lesson here is actually try to operate it the way you've tested all of your systems. And maybe the systems will work the way they were tested.
Yeah, that kind of seems like a no-brainer.
Yeah. Yeah.
Enhance.
Cool deal. Well, let's see here. We do have a bunch of good questions coming in. Thank you, everybody, for asking the questions.
Here. Let's go back over here and see what's going on. Oh, no. The audio is still unmuted on that one. So, Daryl comes back in. He'll talk about what's good. Firebird. 20 months, man. Serious. It's too early. Just I got my Starlink rig. I could live stream it from literally anywhere in the world. Yeah. What's up? I'm a little behind on the Outer Rim news. Are we going to see a possible launch today? No. No. What they're going to do... I don't care about your time zones. They're going to test the tail service mast umbilical. Not to really parrot what Chris G just said, but he's pretty much spot on. They have reverted to fueling. Okay, all right, let me back it up a little bit. You know what? It's probably better that I get this stuff prepared right now. One moment. Ah, okay. We gotta find it. We gotta find it. Let's see if I can get a picture of it. Here. Maybe it's in here. Actually, that's the TSMU, or not the TSMU, that's the ICPSU. That's not exactly, that's the upper stage fueling umbilical. Oh, there's the launch umbilical test facility. That's that facility that I was showing you on Google Earth, right there. There it is. It's basically a bunch of small mobile launcher parts, and they test the umbilicals with them. Right there. They test the flow rates and whatnot.
Is that, like you're saying, Jack, like how beautiful the vehicle is? Like you can see the texture of the foam.
It's not
right,
exactly
and you can sort of get the sense of like how some of it is like rough
working
to
on
the
the caffeine.
texture and to the
no,
touch,
it did
and
not
other
roll
parts are
back.
more smooth. But what I love about this too, because I love the science behind this too, Alicia, where it's like the darker color foam is the older foam, and the lighter one is the younger foam because it tans in the sunlight just like your skin does.
Yeah, I always love to point out, I mean, just even first of all, the fact that that orange stuff is not paint. That's actually foam insulation. It's the same stuff that they used on the space shuttle tank. And yeah, it oxidizes. So when it first goes in, it's that lighter color. You can see where the plug holes are. But then as it oxidizes with the sun or just being exposed just out to the elements, it gets darker. So the darker areas are older bits of foam. And yeah, it gets tan lines actually from where it's in the sun.
Yeah.
That's a fun little fact. It's so hilarious to me. Speaking of the texture of it, I wish I could touch it. I want to know what that feels like. Is it sandpapery? Does it feel like a basketball? Is it more coarse? Is it more fine?
I imagine it feels kind of like concrete, maybe. I don't know. Correct me if you know better, Chris.
If it's the same exact mixture that they used on the shuttle tanks, like it's the kind of foam that when you reach out and touch it, it does like that chalkboard squeaking thing, like nails on a chalkboard type consistency.
Rest, it's too early for that.
As you drag it, it's really weird. Like it's not what you would necessarily expect when you pick it up. It's very light, but it's not.
Yeah, Dead Crew. I don't recognize her either.
Yeah.
I have to figure that one out. Is it brittle? Like if you were to poke it, would your finger like go straight into it, or is it more of a resilient material?
With enough force, it's not like what you would shoot in between like a window. It's not like that delicate or anything like that. But I mean, yeah, I mean you can break it with your hands if you set out to do it. Yeah. And depending on the thickness in certain areas, yeah. I mean, you could do it, yeah.
All right. Well, nobody out there.
Don't smack the core stage.
Yeah. Yes. Nobody out there hurt the core stage.
We have to be kinder and gentler.
Yes.
Smack my core stage.
Speaking of being kind, Cat Herder Cam, thank you so much. They gifted 20 Red Team memberships. That is so cool. Thank you so much, Cat Herder Cam. The membership program is a super huge way to support what we do, and it is absolutely critical to keeping all the cameras happy and keeping them all fed with electricity and internet signal and everything. And I don't know, giving 20 people a chance to experience the membership program. That's awesome.
Picture of what they're trying to fix.
It's a nice little thing that we can do now. The whole gifting scheme, and let people who might not otherwise.
What are the dots?
Check out the membership program. Check it out. So if you just got gifted
DFI
sensors, maybe say thanks to Cat Herder Cam.
Basically, this is the first time they're going to launch this rocket, so they want extra instrumentation on it.
Including members only
emoji.
That's
what all that stuff is.
Here's even more SLS hug.
If I'm thinking about that right, those sensors are actually plugged. There's nothing there. That's where sensors were, believe it or not. So saying that they're just sensors implies that they're still there. I think these are left over from the core stage, green run. This is where the wire harness was for all the sensors, but it ain't there no more. They're actually launching it today. Nope. It's just a tanking test. They're going to make sure that they can fill the thing up with hydrogen. And I'm trying to get you guys pictures of what they're messing with, but... Give me 1 second. I'm trying to find you guys a good picture of it. It's around. It's out there. You just gotta find it. Does this picture work? No. Oh, Daryl's mic is queued.
Update now at 7:30 a.m. Eastern Time. We just received a go from the launch director, Charlie Blackwell Thompson, to begin the cryo-loading operation for today's demonstration test. Again, launch director giving a go for cryo-load at 7:30 a.m. Eastern Time. We're a little off the timeline due to an issue that came up at the pad that was resolved. And then getting the blast danger area cleared. There was a little confusion about an individual who was just outside the blast danger area of security going out there and making contact with this individual. The launch team wants that person cleared out before they begin, of course.
I thought I saw somebody back there.
The BDA, the blast danger area, is an area that is marked off.
It was behind me on the webcam.
Launch pad, several miles, that allows the launch team to keep personnel safe. Once a
you don't want to be near
loading
this thing when it's
operation
fueling.
begins, they take into account if something were to happen, if there were explosion on the pad. This is an area outside of which they would not expect any debris to fall. And
That's
so
the
that
BDA.
individual is being removed, and we are now on our way. Launch team conducting their polls. We'll start marking off milestones here shortly. This is Artemis Launch Control.
I'm still looking to see if I can get a good picture of this thing. Give me 1 second. Basically, there's a seal around a tapered quick disconnect line. And that disconnect, the seal, it wasn't seating right during the last launch attempt. And it was leaking too much hydrogen. Now, don't get me wrong. Anytime you flow hydrogen through a flange or a sealed ring or whatever, it's going to evaporate in some way, shape, or form, and it's always going to leak. That's just part and parcel. That's physics. You can't. It's really difficult to beat. So they always do leak some fuel. That does happen. But they're not. They leak too much because the seal didn't seat correctly. And what do I mean seat correctly? What does that mean? So when they're flowing the hydrogen, right? Once again, you have the fuel line, and the fuel line goes through a taper. So the end of the line has like it tapers in. It's like a cone with a hole punched in the top. That's how the quick disconnect seats inside of the tail service mast umbilical. And then there's, on the other side, on the umbilical plate side of things, you have an inverse taper, right? So they plug into each other, right? So one is kind of, I don't know, it's curved. One is like curved like this, and the other one is outside of that, and they seat in on each other. It's a quick disconnect, like a quick disconnect air hose. Same idea, but in between that taper, there's a seal. Okay, so when it's plugged in, just at ambient, it seals just fine. Here's a problem with flowing cryogenic propellants, especially fully cryogenic propellants. So liquid methane, liquid hydrogen, you get real problems, because when you start to flow through that seal and you start to flow through the taper. Now, Florida is warm. It's warm in Florida right now. Probably like, I don't know, 75, 70 degrees, somewhere in there. That's like 20 Celsius. So problem is, when you flow through a line like that, you're going from 70 Fahrenheit, 20 C to minus 400 Fahrenheit or minus 270 C. Yeah, stuff contracts. It'll tense up because it gets really, really cold. It'll contract, and then when stuff heats up, it expands. You're flowing extremely cold propellant through that line. And when you flow the propellant through that line, the hydrogen will evaporate. It'll evaporate because it'll cool the pipe down. And when it cools the pipe down, some of that hydrogen, which is liquid, will heat up a little bit and it'll turn to gas. And that contraction, if the seal contracts and it doesn't contract around the taper correctly, when it seats, like it'll start contracting and it'll seal it. If it doesn't contract correctly, right, and you go to flow the propellants, it'll leak too much. Now, don't get me wrong, it's always going to leak. Why is it going to leak? Hydrogen's tiny, especially gaseous hydrogen. Gaseous hydrogen is really, 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 really small. It's a really small molecule. It'll leak out of anything. Heck, they can't even store hydrogen at high pressure. You store hydrogen at high pressure, it'll literally just seep through everything. Unless you can find a way to completely seal the tank, it'll just seep through everything. Do they cool down the tanks before filling? They do a slow fill port. Did you get something? Yeah, doing what security does. That's right. Yeah, no, there's the grayed out one, but yeah. I used to have the shuttle version of this picture. I can't find it. Yeah, no, I have a picture of it floating around, but I found one on NTRS when we were talking about the launch attempt, and now I can't find it. The key is to search for Ares stuff. You got to look for constellation stuff, because that's what you got to. Yeah, that's what I'm trying to find. I used to build gaseous hydrogen for a compressed gas company. I can confirm it's extremely difficult to store and not leak. Yeah. I mean, that's what, Darius, that's bingo. That's one of the reasons why that hydrogen tank is so freaking big, dude. You can't store it at the same pressure that you can store liquid oxygen. You store it at a high pressure, it'll be like squeezing a sponge. It'll just leak everywhere. I do not leak. You leak. No, you will not be able to, you can't store it like that. It doesn't work that way. And the other thing about hydrogen, is that it's a very efficient reaction. So what
the launch team here at the Kennedy Space Center is moving.
What does leak will blow up. It'll find, if you don't give it a place to combust, it'll find a place to combust.
Of the core stage.
Hold on. Hey, Barkwell.
With its propellants.
It's a 4% fill rate is too, 4% leak rate is too much, Mike.
And they've configured the liquid oxygen and liquid hydrogen valves.
No, Darius, but that's still cool. Oh.
The ground launch sequencer.
There's Charlie.
Has been activated. That is the computer that tracks.
Okay, GLS's go for tanking.
That could pop up.
Ground launch sequencer.
There you see a shot of inside firing room 1.
Daryl actually should be like right over there.
Seated to the left in the upper deck is launch Director Charlie Blackwell Thompson.
And then there's the
to her
ALD.
right, to her left rather, right on the screen is the Assistant Launch Director Jeremy Graber. And you're looking into firing room 2, which has support personnel for today's tanking operation.
Have you ever been in the fire room? No, Mike, I've never been in the
4
FRR.
firing rooms here at the Launch Control Center.
I wish, dude.
So as they prepare the valves and get ready to pre-chill the system.
Found a really nice PDF on Ares 1, but it's not what I'm looking for.
The tanks that they'll be filling on the core stage there, you see it there, nice shot.
It's that
core
thing down there. See those gray lobes that are coming out of the bottom of the pad? That's what they're looking for. That's the oxygen one. That's the hydrogen
stage
one.
With its rusty orangish color. That's from the thermal protection system.
Rusty?
It's a foam that's sprayed on to the center stage there to insulate it. That helps keep the cryos cold. And at minus 423 degrees Fahrenheit for liquid hydrogen and minus 297 degrees Fahrenheit for liquid oxygen, that thermal protection really helps. Though once the fuel starts going in, it immediately starts to boil. Those gases will be vented off until it's filled.
These numbers.
That center tank there, as you're looking at the bottom of it.
No, Nikki, it's just a tanking test.
That's the largest tank.
They'll scavenge the
just
hydrogen.
Inside of the butterscotch-colored thermal protection system. That's 537,000 gallons of liquid hydrogen that can be held in that portion of the rocket. Just above that is the liquid oxygen at 196,000 gallons. Liquid oxygen far denser than liquid hydrogen, and so it takes longer to fill it up. That's going to be the long pole in the operation today. Right around the order of 3 hours or so. All in all, that core stage booster is 212 feet
There's the thing.
tall,
That's the thing right
about
there.
27.5 feet
see that
in
sucker?
diameter. That diameter, the same as the space shuttle external tank.
The 27th is most likely what we're looking at here, dudes. 27th for launch, so next Tuesday. Yeah, that's what we're looking at. I'm still trying to find the right PDF. Give me one moment. I'll get it.
The hydrogen cryosphere.
Gotta know what to type in.
Which holds 900,000 gallons. Close to 900,000 gallons of liquid oxygen. I should say the liquid oxygen cryosphere holds 900,000 gallons, and the liquid hydrogen cryosphere holds 850,000 gallons. Very close in terms of capacity.
Stop making up numbers, Daryl.
There is a new liquid hydrogen tank being built right now so that it can have a greater capacity.
It's literally behind his head, behind the water tower from this camera.
Almost a 50% increase in capacity.
So I can actually show you that here. So that's the LETF right there. That's where they test the umbilicals at Kennedy. And then if we go up Kennedy Parkway here, there's the VAB in the firing room. That's where Daryl is right there. That's where the launch team is at. They're in firing room 4, I think. I think FR4 is this one right here. Or no, firing room 4 is SpaceX. They gotta be somewhere. What have you got, you now? What's up, man? So if we go down here, the hydrogen fill tanks that Daryl is talking about are over here. So that one is left over from the Apollo program, believe it or not. It was used for tanking S2 and the S4B. And then they ended up using it to tank the shuttle external tank. There's the filling area right there. That's the main hydrogen. Actually, that might not be the filling area. The filling area might be over here. That looks like a... yeah, no, that's the filling area. See, there's parking spaces for it. See the fuel lines right there? That's where they fill it up. And then I'm not sure what that line's doing, but there is the Bunsen burner right there. See the shadow from that right there? So remember how I said hydrogen, if you don't give it a place to explode, it'll find a place to explode. You'll Hindenburg the entire rocket. You do not want to do that. I don't think I need to tell you why that would be bad. Egon, you said crossing the streams was bad. So they basically have a gigantic Bunsen burner right here. That's literally what it is. It's just, it is a hydrogen purge line, and they have holes in the very top, and hydrogen gas flows up this, and the holes right there, just like it's exactly what it does in a Bunsen burner. The gas comes up, combines with the atmosphere, and then there's a little flame at the top, and it's a Bunsen burner. That's what they do to purge the hydrogen gas. That's where all that leaked gas that I was talking about, that's where it ends up. Now, the second cryo tank is over here. They're building another one. So they have double the capacity. Now, do they need both of these to fill SLS once? No. No, they don't. No. What they're using this for is the reason why they built a second tank. And the second tank right here is where the RP1 loading facility was for the Saturn V. This is where they put all the fuel for loading RP1 in the first stage of a Saturn V. It was abandoned after the Apollo program, at least this part. The reason why they're building a second one there is because of turnaround. It's really, really important. That's part of the reason why this whole thing happened. They didn't, and why they have that hydrogen leak rate in the first place. It's mostly because if they had flowed the hydrogen at a higher leak rate, they wouldn't have had enough propellant in the small white tank, or the smaller white tank right there. They wouldn't have had enough commodities to be able to recycle the rocket. So basically, one and done fueling attempt. That's not a good way to test. So long story short, the hydrogen tank, to make sure that does not happen, is not finished yet. So they had interesting constraints there for Artemis 1 when they went to launch it 3 weeks ago. So that's part of the reason why the launch attempt on Monday, with the engine bleed and everything, the first launch attempt that was on a Monday, that was the 23rd or something. They did. It was a Monday. Give me 1 second. This one, they tried to launch there, or no, they tried to launch here, and then they tried to launch there, the 20th and the 23rd. The first launch attempt, I think it was on the 20th. I don't know. First launch attempt, they couldn't verify a DFI sensor was outputting the right signal on the engine bleed. So because they couldn't verify it, they thought they may have been leaking too much hydrogen, so they stopped the launch attempt and tried to launch another day. And then when they went to launch another day, the seal didn't seat, which is no good. I'm assuming it takes a while for them to get more H2. You know what, Orion? It takes a while, but it's not for the reasons that you think. It's not like there's a shortage of liquid hydrogen around. The real problem is, well, honestly, there's more hydrogen down here. You go down to Slick 37B. That's the only other hydrogen tank on the Cape, right there. And yes, they were storing extra hydrogen for SLS in Slick 37's tank. 37B's hydrogen tank. They were storing extra hydrogen there. Funny story. So it's not that they don't have extra hydrogen, right? It's that if they wanted to recycle, they would have to send a bunch of trucks down here, get the hydrogen, and then bring it back up to 39B, and then fill it up over here. True story. I just heard that hydrogen isn't moved with pumps, but via pressure. Is that the case? Yeah, slipped. Yeah, of course. They don't necessarily use fuel pumps. It really depends. It really depends on what you're doing. Most of the time, you know what they do? They just have an electric coil going through the fuel tank, and it heats up the propellants in the fuel tank, and the propellants expand, and that creates pressure. That gives... Okay, all right. Don't laugh. It's called pipe head. That gives you a good head in the pipes. Yes, that's the way to say it, damn it. It's too early. Please spare me. Ugh. Sorry, every time I have to talk about that, I'm just like, no. So, they do heat up the tanks. They just heat them up with an electric coil. The big fuel tanks that I was just showing you. And then they go through these fuel lines right here. And that's how they create pressure inside of the pipe. I got it, but still had a giggle. It's too early, man. Pipehead is also the name of my metal band. Yep. 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 Today I learned that getting good head is necessary for fueling your for space. Just gonna dig this. I'll just dig this hole. All right, I'll just be over here. The diagram on page 3 of this PDF, is that what you're looking for? Yep, there it is. You found it. Here. So, actually, yeah, Creeper, this was one of the ones that I found, or actually Forge found it for me a little while back. But here, check this out. It's not talked about in inches, it's in feet. Just shut up and eat your cheese sandwich. All right. So, now, keep in mind, this is for Ares 1, which is not the same rocket at all. That is kind of what we're talking about. This right here is a ground umbilical carrier plate. That's the GUP. That is not it. So NASA, with the space shuttle, they standardized all the umbilical connections. There's a standardization there on the ground umbilical carrier plates. It's just they all, i.e. they all look very similar, but they all do different things. So that's a GUP. That's not a ground umbilical carrier plate. SLS has one of those. It's right. It actually has two. There's one right there, and there's one right there. Those are designed to get hazardous gases away from the vehicle. So at the top of the hydrogen tank, you have a vent line, and the vent line is connected to the hydrogen ground umbilical carrier plate, the GUP for short. That's SLS probably has something up there that looks like that, probably. Now, keep in mind, see how this has this blue insert on it? That is modular. You can take that off and you can change it. Now, see, it's on a collet right there. Solenoid actuated collet quick disconnect. Yep. Yeah, it's pretty much the same. And Creeper, thank you for finding this, dude. You're helping me out big time. But this is just the ground umbilical carrier plate. That isn't the fueling line. Dude. There's not more to it, but also Ares 1, my love. Oh, I wish. Yeah, you could say it was a death trap. I don't care. Yeah, you're wrong. How's it feel, chat? How's it feel to be wrong?
Okay, we have a milestone here that we just passed. The core stage liquid oxygen transfer line chill down has begun. This is roughly a 15-minute
stuff bar.
operation.
Come
This
on,
will
man.
chill down the lines that run from the cryosphere. But you can just see at the bottom right-hand corner of your screen.
You see these lines right here? I'm pointing at the wrong thing.
And
I'm
it
gonna
will
weatherman
run the
for you.
propellant, pre-chill the propellant. They'll run a
we
little
will
bit of
weatherman
propellant
this.
inside the lines. They'll back it
Okay.
off, but the
See these
gas
lines
that
right
will then
here?
flash
These
off
white
from that
lines that
propellant
go up the
then
pad
helps to
go
cool,
over there, and then they
chill
go
the
up and in.
lines down
That's what he's talking about.
as they prepare it.
They're
for
chilling down the
super
lines
chill
because the
liquid
hydrogen
oxygen
is
to come through
evaporating.
there. This is all for thermal conditioning, reducing the
See?
shock to the system
Mhm.
as they get ready to flow end to end from the cryosphere
These are
into the rocket.
These guys right here. These ones. That's the hydrogen lines. On the opposite side of the pad, so over this hill right here, right? The oxygen lines are over there. Now, if they moved this camera, if this camera went that way just a little bit, right, you'd see the Bunsen burner. The Bunsen burner's over there. Jeez. Now I know why weather people kind of move around a lot, because you're always kind of in the way. So right here, you have a couple of different lines going up there like this. So one of them is the line, the main hydrogen line that goes to the fuel tank. It actually goes. I'm gonna have to. Give me 1 second. I'm gonna have to make a new scene if we really want to weatherman this thing. This might work. Here. Let me go back over here. Our big rocket. Yes, that looks awesome. Standing tall next to big orang rocket. No. All right. So the fuel lines right here. See that? They go up here, and then they go up, and they attach to the mobile launcher. Then they go this way, and then they go up and into this lobe-shaped thing right here. That is the tail service mast. Attached to the tail service mast, size. Attached to the tail service mast is that thing. See this little guy right here? It's not little for what it's worth. That ground umbilical carrier plate and that umbilical design that I'm telling you guys about is not small. They're about this big. Probably like 1.5 meters. It's probably an imperial unit. I think it's like, I don't know, 4x6 or something. It's big. Those umbilicals are huge. And right there, where it connects to the main propulsion system, this part of SLS right here, that is where they have the leak problems. Right where the TSM attaches to the TSMU, which is attached to the TSM ground umbilical carrier plate, and the ground umbilical carrier plate attaches to the main propulsion system. It's right where the test thing is going on. Who gave giant food to EJ? Ha, 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 ha. Yeah. You know what? I'm going to make myself a little bit smaller for this scene, huh? Yeah. Yeah. There we go. I've shrunk a little bit. But yeah, the lines right here that they're pre-chilling, which is, get out of here. You're ruining my shot. Damn chair. Okay. Those guys down there. You have your fuel lines, and then there's the vent lines that go back to the purge line, which is over there. Once again, the purge line is out of shot. It's a big Bunsen burner. It's a Bunsen burner that's like 3 stories tall. Now hug the rocket? I can't. There's a header in the way. Can't you just throw it to the moon? Moving knowledge. It's funny you mention that. There's a company that's actually trying to do stuff like that called Spin Launch. But yeah. Now we're looking at the opposite side here. And if they take this header off here, the Artemis 1 tanking test thing, if they take that off, you'd be able to see the LOX lines. The LOX lines, nope, wrong way. The liquid oxygen lines are basically a mirror of those hydrogen lines. Let me see, can you see them? Yeah, they're over there, far left. if you look at the tower that's on the left side, that big lightning tower over there, and I can't go over there because there's a wall in the way. But they're over there, and they run up the side of the pad. There's a lot of concrete, so look under the A where it says Artemis right there. Look straight down from that, and the line goes up. And they basically mirror the hydrogen line. It's because the LOX tank is over there. That makes sense? And then the LOX lines go up. They go into the mobile launcher. And then they go back to they go around to the front. And then they go into that lobe right here. That is the liquid oxygen tail surface mast umbilical. So you have the T1 and the T0 carrier umbilical. Okay? Or T1 and T0 tail surface mast. T1. Oh, I was wondering what that noise was. Time to wake up. So the T0 is fuel and T1 is liquid oxygen. That's the T1 tail surface mast. It's LOX. Fuel is 0. Liquid oxygen is 1 in NASA's naming nomenclature. It's probably 0 and 1. That's probably the numerical designation for their commodities. If I had to guess, that's a guess. I don't know.
And good morning and welcome to the Kennedy Space Center in Florida. It's 8 a.m. Eastern Time here at the Space Coast, at the center of your screen. The Artemis 1 rocket, the Space Launch System and Orion spacecraft on the pad at 39B.
Got a couple of cumulus clouds
Currently,
up here.
we are at the very beginning.
Cumulus clouds to cloud
the Artemis 1 cryogenic demonstration
to 10,000
test.
here.
This is a test to
Scouted
validate
skies, got pretty good visibility.
the fueling operations for super chilled propellants that go into the lower stage, the core stage, and the upper stage. This rocket, of course, we're looking forward to the launch of this rocket that will be the flight test of NASA's Deep Space Exploration System, the Orion spacecraft,
right here. All this
Space
stuff,
Launch
yeah,
System
no, it's
rocket, as well as the supporting ground systems here at the Kennedy Space Center in Florida.
Yeah, I know, Canuck. I like doing the weatherman thing. The weatherman thing is more fun, though.
The tanking test, currently we are in transfer line chill down. These are the lines that run from the cryospheres that hold close to 900,000 gallons of propellant. They are pre-chilling the lines that run from there to the rocket. We're going to begin with the core stage.
Right,
this is the lower part of the rocket. Going to tank the
rockets do be like that.
And the liquid oxygen. We start with liquid oxygen and then move to liquid hydrogen. If you've been following the operation, there have been some challenges with liquid hydrogen.
Have both legs.
Leak.
They're
right
during
the last launch attempt. That's been
I can actually stand up and do that now because new office.
And now the team is
pretty sweet. I actually like doing this.
As well as a new loading procedure that's different from the first attempts. More similar to the ground run at Stennis.
The sound is actually going to go over
the launch team
because it's going to go into the flame trench and it'll bounce off
and fire the engines.
It'll go like this way off the pad.
The Kennedy team modeling it more after that procedure. In order to
dude, Milan, I totally see it.
Prevent
if I'm like
thermal stress
like this,
on
it
the
looks
system.
like dude, I totally see that.
It would be really easy to put liquid hydrogen in today
find out.
With this new procedure.
Discovery,
of course, we're keeping track of all the milestones.
Look behind you.
In your shot, you can see that it's an overcast day to start here on the east coast of Florida. We are green for weather, but the launch weather officer is keeping a close eye on some storm cells off in the distance.
Uh-oh. Well.
And you can see some of them.
You got it?
Right there at
Found
the
it, Creeper?
horizon in this shot.
Yeah, there you go. That'll get the point across, I suppose.
The concern would be any storm cell that contained lightning. It's not a problem if it comes over top and rains on us. No issue there today. We're not, we don't have an appointment to go to the moon today. But if that cell has lightning in it, then it is a concern for tanking. So again, watching closely, there's currently a cell that's directly east of us.
That's right, Llama Shark. Yeah, you got it, buddy. Hey, Element, what's up, dude?
More than 20 miles away.
Offshore. There's the hydrogen ground umbilical carrier plate.
Officer keeping a close eye on that.
Loaded.
We got started today at 7:30 a.m. with the launch director giving the go for a cryo load. We're a little off the timeline, but there is no launch window today, so
that's just
shouldn't be an impact at all to the procedures. And we're marking off our milestones. The shot you're looking at right here is one of the boosters on the side and the core stage in the center.
So, fellas, I don't mean to interrupt Daryl, but if you have questions about what this stuff does, I know what most of it does. Most of it. Could get some of it wrong. Not an expert. Don't work for NASA. Not an engineer. I get the bits and pieces. I get the scraps that they tell us about. And I like to pay attention to that stuff. So I know what most of this stuff does, but not all of it. if we want to put it that way. What's happening? Tanking test, Geeson. They're going to see if they can seat that damn hydrogen. What's the date for SLS? Paul, if everything really... Okay.
This is the rocket that's sending us back to the moon for the benefit of all humanity.
Scientific
discovery, economic benefits, and inspiration, all for a new generation of explorers, the Artemis generation. If you'd like to know more about...
Would you like to know more?
One mission, go to our website. Our website is nasa.gov/Artemis. Again, nasa.gov/Artemis to learn more.
Ooh, Twitch ate that link, W.
Control.
I'm doing my part. SpaceX's Starship has a fuel gauge built in. You can see the tanking level because of the frost. Yeah, you don't have that problem. Don't have that problem? You don't have that with SLS because, well, there's a couple of reasons why, Hal. So, okay, SpaceX is going like bone dry, man. It's just the stainless steel. Because they're using a stainless steel construction, now the stainless steel is a little bit more dense. A little bit different material, what's called material properties, all right? This is an aluminum tank. That's, if I remember right, could be wrong. It's 7000 series aircraft grade aluminum. I think like 7120 something or other. There's different like kind of alloys of aluminum, I guess. That's aircraft. I think it is. It's 7000 aircraft grade. I think I could be wrong. Oh yeah, we got to call it aluminum just to piss everybody off. Aluminum. Yep. Anyway, so because this is aluminum, right? I mean, don't get me wrong. There still will be frost on it, but there's not as much because, well, no. There will still be frost on it, but SpaceX is just going bare on that stainless steel, right? And you do get the frost lines that occur. Now, don't get me wrong. It doesn't matter if it's stainless or aluminum. You're still going to get frost lines. It doesn't really matter. But with this, they have the spray-on foam insulation. It's called Sophie. That's literally the orange, the big orange stuff right there. That they originally designed the insulator, which is basically, you know, those like those slip-in things that you can put around like a soda can that keep the drink cool, like the koozie thing. That's literally what it is. It's that for the rocket, but it doesn't leave. It doesn't separate. It's sprayed on. Similar to like spray-on insulation on your house. It's not the same as that, but it's the same idea, right? Yeah, it's literally a koozie for the rocket. It keeps the propellants cold, so you don't get ice. Yeah, now don't get me wrong. They still get a little bit of it because hydrogen is really cold. Not like Canada cold or Russia cold, but close. No, it's minus 423 Fahrenheit or 271 C. Yeah, minus 271 C. It's really, really, really freaking cold. So you're still gonna get ice in some way, shape, or form. So, but with that insulation, it makes it so that ice doesn't fall off. Now the reason why they did that is because if you look at the God tier launch vehicle that is the space shuttle, my favorite, they put that foam on the external tank so ice wouldn't come off and hit the tiles on the shuttle's thermal protection system. Yes, I know, irony, I get it, not cool. Unfortunately, they had problems with the foam coming off instead of the ice, and that didn't end well. We know that. Rip. Anyway, so what they did was they put this foam on there to make sure that ice didn't come off and hit the tiles on the side of the shuttle. More importantly, they made sure that they didn't hit these gray areas on the leading edge of the wing and that gray area on the nose cone of the space shuttle. That's reinforced carbon-carbon. RCC is what it's called. That's the industry kind of way of describing it. RCC can resist like 5,000 degrees Fahrenheit straight up. They use it on the tips of nuclear warheads to make sure they punch right through the atmosphere. Everybody does that. Everybody that has nukes. I say that like, you know, you can go shop around for the nuclear material of your needs. Oh, I'm sure in 1985, plutonium's available at every corner drugstore. But in 1955, it's a little hard to come by. Buddy, I'm afraid you're stuck here. Anyway. All right. That's how you know I'm awake. By the way, just to let you know. If you don't know me, that's how you know I'm awake. Same link as the last, but I used the URL shortener. Lightning maps. Yeah, I got it. Thank you. So they put that foam on there to make sure that it doesn't hit the shuttle's tiles, right? Now with SLS, I don't know if you guys noticed, there's no space shuttle here. They kind of took that part off. Trade-off for going to the moon.
Discovery, throttle up.
Doesn't necessarily have to be, but hey, Private Cannon Fodder, thanks for the sub, man. So sorry, I derailed a little bit. Okay, so this is the second thing. So a lot of engineering applications in rocket science have two uses, because if you can make one thing solve two problems, well, you're good. The reason why they kept the foam here, and part of the other reason why the shuttle had it, right, is because they get better performance out of the propellants, because the propellants don't boil off as much. Because if you can keep hydrogen at a nice stable temperature of minus 423 Fahrenheit, not too much, not too less, right in the center, it will not be. Oh, here come the movie quotes again. That's how you know I'm either really awake or really tired. I'm thinking it's really tired this time around, but doesn't matter. So if hydrogen can only really exist as a liquid in like maybe a 5-degree delta, so it'll either turn to gas or it'll solidify. And if it solidifies, then you got big problems. Yeah, you don't want if it solidifies, you're getting near 0 Kelvin. So like absolute zero. And when you get near absolute zero, physics starts doing weird things. So you don't want that. That would be bad. The rocket is a liquid hydrogen rocket, not a gaseous hydrogen rocket or a solid hydrogen rocket. That's not in the name, so you probably don't want that. So they got to keep hydrogen at a really stable temperature. If it moves too far in one direction or another, and by too far I mean like 4 or 5 degrees in either direction, it'll either solidify or it'll turn to gas. What most likely happens is it turns to gas. You don't want gas going into the engines. If you have gas ingestion in a liquid fuel rocket engine, well, it's simple. This kills the rocket engine, amongst other things. NASA was actually worried about spinning a bearing in one of the pumps because they couldn't get the hydrogen chilled to chill the engines correctly. That was on the first launch attempt. But anyway, I digress. The foam is there because it's for performance on SLS. They kept it because they get better performance out of the hydrogen. True story. Yeah, great shot though. Florida sunrise, Florida sunsets are beautiful. Yeah, I don't care what anybody says. A solid H2 SRB is a terrifying thought. Yeah. Blue, you know, like, if you showed, like, Leonardo da Vinci the space shuttle, he'd be very confused. Like, if you could just do that, you could pull a Bill and Ted, just show, you know, like, Socrates the space shuttle. He'd be like, okay. But like, if Da Vinci was a smart dude, he'd be able to. If you show, like, explain what everything did, he'd be like, all right, cool, yeah, I get it. You know, that's solid hydrogen with us. You know, like, I'm sure it's possible, and maybe in the future, like, if somebody comes through with a DeLorean, yeah, 2 Back to the Future references. If somebody pops through with a DeLorean and it's like, oh yeah, we use solid hydrogen we use hydrogen SRBs now, I'd be like, I don't know how you did it, but all right, cool, good for you. You know, thanks for the info. That's what I do, Hal. This is why I'm here on Twitch. This is what I do. I explain what the heck that thing does. Okay? What does that thing do? Well, it expends an insane amount of energy in a really short time to be able to basically launch us back to the moon. Yep, that's the right way to say it. THF, what's up, man? When is the next Artemis launch attempt scheduled? Well, it depends on this test, guys. I keep trying to find a good picture of it, but long story short, the fill and drain line where it connects to the rocket down there, you always fuel from the bottom with rockets, you vent out the top. Pretty straightforward stuff. The fuel lines that are down there weren't working correctly during the last launch attempt. They were leaking hydrogen. And this is what I mean about hydrogen when you go too far in one direction, too far in another direction. Hydrogen only exists as a liquid for like maybe 5 to 10 degrees, a 5 to 10 degree gap. And if you go too far out, you go too far this way, it'll boil off. You go too far this way, you get this solidify, and then that's not likely to happen, I will say. Like, solid hydrogen hydrogen will exist as a solid for like maybe 2 to 3 Kelvin, and that's it. Like, and then you hit absolute zero and bad stuff happens. Physics class. Anyway, what most likely is going to happen with this thing is that you'll get hydrogen gas to either boil off or evaporate. Now, it'll evaporate. Now, don't get me wrong. When you boil a liquid, like if you boil water at 1 bar, it'll boil off, it will evaporate. But the hydrogen will evaporate inside of the line from boiling. Basically, if you try to put it through the fuel line, it'll boil into gaseous hydrogen. Just like if you take water, right, and you boil it on the stove, it'll turn to steam. Same idea, but temperature is shifted a little bit towards the cold side. Right? So what's happening with this thing is that what happened during the launch test is that they tried to flow hydrogen through that thing. See this thing right here? Those are the fuel lines down there. There's 2 of them kind of next to each other, and we're looking at it from the side. Actually, I should go that way. There's 2 of them. There's a hydrogen fuel line and there's a oxygen fuel line, right? They got to bring the oxygen with them. There's no oxygen up there to combust anything. It's not like a car where you can just have an intake sucking in air. Doesn't work that way. No air up there. So they got to bring liquid oxygen with them. And oxygen is easier to manage in liquid form when you're on a rocket. Yeah, I know. Weird, right? Actually, it's easier to store in liquid form if you really want to know. So those things down there, these lines right there, the hydrogen one it gave them a problem. They were leaking hydrogen out of it because the hydrogen boils. It evaporates. Now, don't get me wrong. You know, you say there's a leak and people go, what? Why is there a leak? Whoa, 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 whoa. Is it supposed to do that? Well, the answer is yes. Yes, it's supposed to do that. Hydrogen will always leak. It's always going to leak. The reason why, hydrogen is very small, very, 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 very tiny molecule. It'll go right past the O-rings. The O-ring will be like, stop, hydrogen, and just be like, nope. And just keep going. Now, don't get me wrong. NASA took that into account. This is a similar fueling system that they had during the space shuttle. Very similar. And they have a catch can over the fuel line. That picture right here that Creeper found, that's the fueling line right there. That's actually the fueling line on the vehicle. This is when it was still being built. So this is the tail service mass carrier umbilical receiver on the main propulsion system. Basically, it's the gas tank. It's the gas tank fill lines. Now, you have 2 fill lines because you have 2 commodities. Once again, they got to bring the liquid oxygen with them. Liquid oxygen is right there. Okay? Gaseous oxygen comes out right there. Liquid hydrogen is right there. Gaseous hydrogen comes out there. Liquid oxygen does have that same problem, but liquid oxygen is a little bit of a bigger molecule. It's a little bit easier to use. So gaseous oxygen, or GOX. Yeah, I just like saying GOX, right? GOX. It comes out of there, and then the gaseous hydrogen comes out that 4-inch vent line. The hydrogen flows in here, and there is a carrier umbilical plate, tail service mass ground carrier umbilical plate that mates up to this, and it bolts. Not really bolts. It's just a taper a taper with an electronic solenoid collet. Basically, it's just an electric solenoid that'll just detach when you need to. It's a quick disconnect. So there's basically an electric motor that pulls out a collet and the thing flies off because the umbilicals are counterweighted, think like an elevator. So if the collets snap off, weight will go down and it'll pull the mast away from the rocket, because presumably if the mast has disconnected, that means the rocket is launching and the mast should be somewhere else. Yeah, it's going to get really hot in that area. You want to get it away. So inside of the ground umbilical carrier plate right here, the fuel line links up to the plate that bolts in this area here, right? And it's a tapered line, and the line tapers through the plate and into the vehicle right there. See this? See how there's kind of that recessed hole right there? That's what I'm talking about. There's a double O-ring in there, right? And those O-rings were the seal. It's not an O-ring, it's a seal. O-rings are a little different than seals, but they do the same thing. This is a seal, so it's more of like a gasket almost. And that gasket wasn't seating correctly. It was leaking. It was leaking too much. But NASA has a catch can right there that's connected into the 4-inch vent line right there. And it was leaking. And don't get me wrong, it's always going to leak. You can't beat physics. It's always going to leak. I got to sneeze. It's turbo. It's always going to sneeze. It's always going to leak a little bit. That happens. That's why the vent line is there. Hydrogen will always do that. It doesn't matter what rocket it is. It doesn't matter at all. I'm leaking. So it was leaking gaseous hydrogen out at a rate that was too much. Don't get me wrong. The catch can and the vent line was getting all of it. It wasn't leaking anywhere that they didn't want it to leak. But if it leaks too much, then you might have a little bit of a problem. Namely, the problem that NASA was running into was that they were using too much hydrogen. If you use too much hydrogen, they didn't have enough in the launch pad fuel tanks to be able to recycle. That was the big problem. They could have just filled it with the leak rate, but I mean, it's like if you took, like, if you put gasoline in like a water gun, like a super soaker, and you tried to shoot it into the gas tank of your car, some of the gas would probably get in there, right? Please don't ever do that. Don't ever do that. Bad idea. Don't pressurize stuff that explodes. Bad idea. But like, you shoot it at it, some of the gas might go in the car, but most of it will leak all over the ground. The car will still work. But you don't want to send it like that with rockets. Not a good idea. Just like you don't want to do that with a super soaker. Yeah. Don't pressurize stuff that explodes unless you're NASA. That's what I'm trying to tell you. Yeah, exactly, Riv. That's right. Yeah, good, you're right. Yeah. Honey, just said use the super soaker. Don't put it out with your boots, Ted. Oh, don't tell me my business, devil woman. Call the fire department. This one's out of control. And that's why NASA won't hire me as a PAO. Because of what just happened right there. But that's okay. That's why we're here.
Good luck to you.
Thanks, Daryl. I appreciate it.
All right. You heard the update there from West Mosedale, and we continue to track milestones as
it's okay, guys. I got coffee.
Demonstration test continues. This is Artemis Launch Control.
And I missed what they were talking about. Anyway, great sunrise down in Florida. So use it Zoolander style. Not every astronaut can afford to have a freaky gasoline fight. Seriously, don't do that. Bad idea. I have a really confusing assignment to design a cardan joint that can support 90 degrees of turning. I need some advice, Master. Please send reinforcements. A cardan joint? Oh, U-joint. Okay. You want to try to make a U-joint go 90 degrees? No, don't do that. No, it'll bind. Screw that, Riv. Use a gear. Did you see James Webb's newest image? I have not, AFD. Just got back from university induction. Has the thing happened? They are starting, they're chilling down the lines right now, Bith. That's your assignment. Rick, why would you use a U-joint for 90 degrees? Screw that. That's not the... I was about to say that's not the right application, but the reality about engineering is that I don't know that for sure. What's your expectations, Riv? What are you trying to do? You could put 2 U-joints in a row at 45 degrees, drummer, but you'd need a carrier bearing to do something like that. You'd need a carrier bearing. Long story short, you have 2 at 45 degrees like this, it'll bind. It'll want to... You ever take, drummer, you ever take one of those, like little model balsa wood airplanes and spin the propeller up? What happens to the rubber band? It'll start to twist, and then it'll start to bind up and make knots. That, but with U-joints. Yeah, you don't... 245s like that, you're going to need something to hold them in place. You need a carrier bearing, or else it's not going to... It'll bind. It will bind. Physics. Yeah, a wobble yoke? I don't know, man. That's a good question. Does it have to be a U-joint, Riv? If it has to be a U-joint, you're going to need a carrier bearing. I don't really... See, this is the problem with engineering questions. They try to make you second guess yourself, but oftentimes with engineering, the simplest solution, it's Occam's razor with engineering. Best part is no part, just like what Elon says, right? I would just use a bevel gear. Screw the U-joint. Why would you do that? You ever watch Gundam? Besides the inherent... I know what Gundam is, Squiddy, yeah. Besides the inherent goofiness of giant human-shaped robots, it has a lot of interesting stuff going on with space colonies and their tactical uses. Somebody's been watching too much Aliens. Am I right? No, I understand what you mean. Yeah. For an example, the weird dichotomy of a battleship cannot exit the atmosphere without a booster stage, but a practically unshielded Gundam can re-enter without the pilot boiling. Oh. So, okay. Squiddy, so here's the thing. It doesn't matter if it's a Gundam. It doesn't matter if it's a battleship. If it re-enters the Earth's atmosphere and you don't have some type of thermal protection system, it will ablate. Stuff will melt. Yeah. It doesn't... Yeah, Space Battleship Yamato, right? Or the Bebop, right? Yeah, that's a good show. You need some type of thermal protection system. There's no... Like, if you just have this... Like, if you just took, like, the Yamato, right? The Space Battleship Yamato, and it wanted to come back down and you know, land in the water like a seaplane. Say we wanted to do that. I mean, I'm not saying that we shouldn't do that. That would be really cool to see. I'm not... You could say that it wouldn't be, but... A battleship without some kind of damper, it would go to broadside in space and it would just start flipping over because Newton's third law, but that doesn't matter. The guns would have to be center mounted, so doesn't matter. So tungsten skin. Oh yeah, great. Tungsten skin. That doesn't matter. That doesn't matter, Tessa. I don't think people realize how hot it actually gets. We're talking 3,000 centigrade here. 5,000 Fahrenheit. Tungsten? No. No, it will ablate. It will ablate. Even tungsten. You can't just make... I mean, you could. What you could do, Tessa, is make an ablative tungsten heat shield, and you could use it for a number of times, but eventually it'll just... plasma, man. Plasma will just score it right off. And I say plasma scoring like it's some sci-fi term, but that's exactly what happens. When you're re-entering the atmosphere, and this is why it doesn't matter what it is, battleship, whatever... a battleship, a Gundam, it doesn't matter. Or you could have a banana-shaped spacecraft, you know, and it would do the same thing. What happens is you're starting to hit the atmosphere at a very high rate of speed. And what happens is the air molecules that are in the upper parts of the atmosphere will start hitting whatever body you're coming back inside of, right? And when they hit, they compress. And what happens, if you know a little bit about basic physics, what happens when you compress a gas? It gets hot. What happens when you compress anything? It gets hot. Mostly with gases, though. It's called the ideal gas law. PV equals nRT, right? Or for you guys, it would be PV equals nRT. It'd be backwards, because flipped around, because you guys are looking at me. So that's exactly what happens. And it compresses it so much, it puts those air molecules under such intense pressure that they actually ionize. Basically, whatever's coming through the atmosphere literally rips air molecules apart. It is going so fast, and those air molecules are compressing up against the vehicle so hard, it will literally rip the molecules in half. When that happens, when you take the ion out, when they ionize, when you rip the molecule in half, it releases an insane amount of energy, right? Splitting the atom, remember that whole thing? It's not splitting an atom, you're splitting molecules, a little bit different. So what happens is it generates plasma. When I say plasma scoring, that's exactly what I mean, plasma. The thing about the plasma is that the plasma actually ends up getting compressed against the vehicle because there's a bunch of air behind it and you're still coming at it, right? There's a bunch of air behind it and that air pushes up the plasma and the plasma kind of accumulates. It kind of sits there and does nothing. And it's literally like a blowtorch. It's a blowtorch to the thermal protection system. And it'll just stay there until you slow down. You're converting that kinetic energy to heat. And yeah, that's why it doesn't matter what it is. Think about like if you just took a blowtorch to a piece of metal and just kept it there for like 8 minutes. It'll just melt. Heat, the metal can only absorb so much before it reaches a critical mass and then it starts melting. I think that's how that's said. Yeah. But yeah, it doesn't, Squiddy, doesn't matter if it's a Gundam, doesn't matter if it's a battleship. It's gonna melt. It's gonna melt unless you have some type of thermal protection system. Now, NASA, with the space shuttle, they came up with a really good idea. So metal melts. Metal will melt at a certain temperature. What material does not melt? Or not does not melt. What is the strongest material that is most heat resistant that we have, that we know of? Anybody? Hey, Jesus, what's up, man? Spoiler alert, go outside and look down at the ground. You'll probably see one of them. Very small rocks. Their solution with the space shuttle was to literally glue a bunch of rocks to the bottom of the vehicle because rocks can resist heat better than metal. They're silicate-based tiles. They're rocks. Like a porous rock, like quartz almost. Ridiculous, right? Yeah, I know. Rocks. It works. Dude, it works great. Works freaking awesome. Yeah, well, the shuttle turned me into a newt. I got better. I don't want to talk about it, Squall. It's too much money. Picture a guy with a glue gun. That's not far off to how they did that, Llama. They glued the tiles to the bottom of the shuttle. Yeah. Can you show the class a video of the tile coming out of the kiln? That video's floating around, but yeah. I kind of wanted to make sure we don't stray too far away from that. But yeah. Is the physics in the Expanse realistic? Asimalock, it's realistic enough. Yeah. Think about it like Kerbal Space Program. That's my favorite game. It's the game that made me successful here on Twitch. And I haven't played it in a little while, and I know people are going to give me crap about that. I'm sorry. There's other stuff I got to figure out right now, okay? Look, I'm a moron. I can only do one thing at a time, all right? What do you want from me? Okay, Phil, I see it. Another one? Why no magnetic field for a shield? That's a good question, Lodata. And I'll answer that in a second. What was the other question? I lost track of chat. I sent you a DM vid. Please advise me. I don't know, man. Oh yeah, Expanse. Expanse is good enough. It's like Kerbal. Kerbal will get the point across, but it won't. It's not going to teach you all the fine details of it. Now, the engines in the Expanse, the Epstein drive and stuff, once again, plausible, sure. You could have a magnetic fusion containment drive like they do in the Expanse. That is theoretical, though. No one's ever done that. It's basically a fusion reactor with a magnetic field that's shaped like a rocket engine. And all the heat that's generated from fusing atoms together gets just ejected out the back. That's, yes, you could do that, but you need a lot of energy, and you have to solve that whole, you know, fusion problem. Yes, Wefrel, it will. So, okay. Lodata, you asked about a magnetic heat shield. You could do that. Sure, absolutely. Earth's magnetic field does that. It protects us from that sun thing, making sure everybody doesn't get microwaved down here. Am I right? You could do that. Sure, a magnetic field could contain the plasma. But, so we have to think about the engineering here for a second. You're going to need a lot of energy to generate a magnetic field. So your ship's basically going to have to be a giant Tesla coil, right? Let's say we're going to entertain this idea, right? Your ship would have to have a giant Tesla coil in it. How much weight is that going to be? Where are you getting the energy from? Where are you getting the electricity from? Batteries? Those are heavy. Even lithium batteries that are really light, they're still heavy. That's still mass for your spacecraft. Now, let's think about it like this. The space shuttle had 30,000 of those silicate tiles attached to it. They're very light. They have about the material consistency of styrofoam, believe it or not. Right? Is the Tesla coil and the batteries and all the electrical equipment associated to discharge that during reentry, right? Does that have more mass than the tiles? Most likely, yes. So why would you do this? Why would you do this way? Why don't you use tiles? See what I mean? That's what you got to think about with engineering. It's always a trade-off. There's always benefits. There's always pros and cons. You have to weigh those pros and cons, and you have to figure out the best application for what you're trying to do. This one requires energy. This one absorbs energy. Does that make sense? You could get it from the heat, but yeah, if a scavenging system, I suppose that's possible. I don't know how you would do that. I don't think that a heat transfer system, so you're talking about taking the reentry heat, converting it to electricity, and using that to make a magnetic field. So kind of a basically like an air intake on a jet, right? But with plasma or heat in this particular case. I don't think you can flux energy like that fast. I don't think there's anything that can do that. I mean, don't get me wrong. I know there's heat plates that can take heat and convert it to electricity. What I'm saying is I don't think any technology exists to be able to do that quickly. We're talking about an insane amount of energy. But if you could find something that could give you the bandwidth, so to speak, to take that heat from the plasma and convert it to electrical, yeah, maybe. But then again, that would mean that some part of your spacecraft needs to be outside of that magnetic field that you're making. Or else it's not going to get hot at all, right? So that magnetic heat shield thing with your plasma intake would only work for a second. And then you'd generate a nice magnetic field, and then you wouldn't take any more heat, and then you'd hit reentry heating full blast for a second, and then it would just keep going, right? Right? See what I mean? You gotta think about this stuff. A magnetic containment system, a magnetic field on a spacecraft, not a bad idea though. But low data, I wouldn't use it for reentry. If we could figure out a way to do that, and maybe we could in the future, but if we could figure out a way to do that, I would use it for radiation shielding, man. Do exactly what the Earth does. Keep the bad solar winds away from you, because that's the stuff that makes you grow a third arm. You don't want that. That's figure of speech. Only kind of. Right? That's what I would use that for if we could. You would, because remember, with radiation on a spacecraft, you got to bounce the radiation away, just like the magnetic field does. Now, don't get me wrong, the magnetic field does absorb some of it. The Van Allen belts, or the Van Halen belts, as I like to call them, they absorb a lot of those solar winds, and the boreal effects at the North and South Pole are some of those solar winds reacting with the Earth's atmosphere because the magnetic field isn't there, right? You know, the lights in the sky. Yeah, Foz, I saw it. Yeah, solar winds and DNA doesn't play nice. That's right. Yeah, it flips the bits, so to speak. Yeah, computer tech. Yeah, I know. So with spacecraft, you don't want to make something that absorbs radiation. So like a lead-lined spacecraft, that would be a bad idea. You don't want to do that. Even using water to kind of absorb radiation, because water's a great moderator for radioactivity. You still wouldn't want to do that. You're still absorbing radiation. That's like making a boat hull out of a sponge. Oh yes, I'm going to make this boat out of sponge. I won't get wet. Yeah, you don't want to do that. But yeah, Lodata, I mean, your mind's on the right track, dude. It's not a bad idea, right? I'm disappointed at the Expanse series. It's supposed to be about exploring space, but the whole series they just stay inside the solar system. Sag. Spoilers. The lead will heat up. Well, of course, it's in the sun. But the part of it that isn't in the sun is going to be really cold. Got to think about that too. That's one of the major hurdles for colonization. Otherwise, you'd have to bury yourselves under water and soil. I mean, Hal, there's ways to get around it. Or you could just accept the risk. I mean, you just have a moon base and then just get hit with radiation and kind of go with it. But yeah, if we went to the moon, if you wanted to do long-term presence on the moon, you'd have to find a way to really rad shield that stuff. Or play Minecraft on the moon. Don't dig straight down, though. There's lava tubes on the moon. Yeah, don't dig straight down. Could end poorly. You see Elon's tweets. I'm here to talk about SLS, Thomas, but sure. What is Elon's tweet? Do you think Artemis will lift off someday? On the 27th, if everything goes right. Of course, has Malak. Yeah, of course, it's gonna work, dude. You don't get this far and then get rid of the damn thing, all right? If we do that, that would be a big mistake. In fact, every time somebody has said, oh, we have this system, there's a better way to do it. Oh, we have the Saturn V. Oh, we should move to reusability. There's a better way to do it. We'll be back to the moon soon. Don't worry about that. That didn't end very well, did it? I mean, look at the end of the space shuttle program. They said, the space shuttle isn't really working. We're not exploring like we want to. Let's go back to making moon rockets because that could end up being less expensive. And then somebody right after that said, no, this is too expensive. Bye. Let's give it to commercial. Where did that get us? Oops. That got us flying on the Russian Soyuz craft, which is not a bad vehicle. There is a Soyuz with a NASA astronaut that's launching in a couple hours, actually. Actually, it's more like an hour now. Well, does the moon have lava? We can make it magnetic shit. No, Noswolf, no. The moon is not volcanically active. No. It's basically just a big rock. But the rock is similar to Earth, but there are lava tubes on the moon, interestingly enough. So it was volcanically active at some point. Strange, right? Are we going to watch that launch? I don't know, maybe. Yeah, every time, long story short, every time somebody says, no, that's a dumb idea. We can do that better. Oh, this is too expensive. There's a better way to do it. Okay. You'll find the better way to do it. Sure, absolutely. It'll take about a decade. It's true. Look, okay, let's look at the Saturn V.
Couple updates here.
No, let's not.
For some milestones reached at 8:42 a.m. We went into core stage liquid oxygen slow fill.
Okay.
Again, core stage liquid oxygen slow fill has now begun. So the chilling of the transfer line.
I agree, Jack. I'm with you 100%.
We are now in slow fill for liquid oxygen.
Okay. Got to monitor them leak rates here. That's why we're here.
And on the liquid hydrogen side,
that's the
just
oxygen.
got the go to proceed with propellant load for liquid hydrogen.
Okay. That's the one.
Got the go.
That's the one we got to be careful. They're trying to be careful
loading
with.
of liquid hydrogen propellant into the core stage.
It's just a tanking test, Blinga. If it was a wet dress rehearsal, they would call it a wet dress
again,
rehearsal.
Liquid oxygen now in slow fill. Liquid hydrogen has the go to proceed. They are now going to begin chilling down the transfer lines.
Mike, I don't have the flow rates, dude. I don't have the exact flow rates for the hydrogen. What I can tell you is they're slow flowing it into the rocket to get the pipes at the right temperature for fast filling. You don't want to just, it's the same thing that I've been talking about with hydrogen. You don't want to just yeet the hydrogen up, turn the taps on, and hydraulic hammer hydrogen into the rocket. That's not gonna work. What happens is you're gonna get geysering, and then you're going to get too much leaks. Herb. So what happens is if you flow hydrogen too fast through that pipe, it'll evaporate. Like I said, the hydrogen's boiling, all right? It'll evaporate because you're heating it up, right? You get too much gas in the line, and now liquids are not compressible. When you have liquids, the pipe is designed for a flow rate. Gas is compressible. You can overpressurize the pipe, and it can create a geysering effect. And you could back pressurize the line and flow hydrogen backwards into the tank and then overpress the tank. And I'm talking the tank on the pad, like I'm talking that thing. That's the LOX tank. The hydrogen tank's over there. You could do that. You don't want to do that. It happens more with liquid oxygen than it does with liquid hydrogen, but you got to slow fill. You got to get the lines thermally conditioned. If you thermally shock the lines, you could get a geyser effect and the line could pop. You overpressurize it. Water hammers, but for hydrogen. If you water hammer hydrogen, explosions. Yeah. Stuff breaks. Yeah, you don't want to do that. That's why they slow fill. And Mike, I don't have the flow rate, dude. I don't know how fast they're flowing. I know they're flowing it at a rate to make sure that they don't generate too much gas. But they also want to slowly get that pipe down to the right temperature. Now, what's the right temperature? Minus 420. Minus 423 degrees Fahrenheit. Or 271 C. Minus 271 C, not positive. Was there a chance this could have happened to cause the leak the first time? Huge crit. What was happening during the second launch attempt? What was happening, they could have flowed too fast. What happens is, at the point where the fuel line connects into SLS, it's a tapered fuel line at point of connect. So the fuel line is like this, right? It looks like a cone with a hole at the very top of the cone, right? So think like if you took an ice cream cone and you cut the bottom off, that's what it looks like. It's designed to seat inside of SLS's fuel umbilicals. So here's a picture of what that looks like. That's the fuel umbilical on SLS. Okay. So see this taper right here? That hydrogen fuel line is attached to a carrier umbilical plate, and the plate bolts, and the plate's about the size of the white area right here. And the fuel line goes through the plate, and it goes into this taper right here. Inside of that taper, there's a groove for a seal. Okay? When they flow the hydrogen, if you flow the hydrogen too fast, you could thermally shock the seal. And when I say thermally shock, I mean basically you cool it too quickly. And if you cool that seal too quickly, it'll contract. And if it contracts too fast, it might not be able to seal around that taper correctly. If they go too fast, it'll contract too quickly, and then it won't seat correctly. It won't seat in the groove, and then you'll leak. Then you'll leak hydrogen. I'm pretty sure that's what happened. Pretty sure that's why they pinched the seal, and then the seal contracted too quickly, and it didn't seat correctly, and then it damaged the seal. So what they're doing is they're focusing on doing a shorter slow fill here. They're doing a shorter, a longer slow fill at a lower flow rate to get that seal to seat correctly. So once again, NASA tried to flow it too much. They tried to do too much too fast, and they damaged the seal by they basically thermally shocked the thing. And that's not my guess. That's right from what they said in the press conference. They had to replace the seal. They had to take that whole dang thing apart. and put it back together and replace the seal. And then they needed to look at the seal and they needed to figure out exactly if that's what they did. They're pretty sure that that's what happened. Kindler, yeah, you got a kinder, gentler machine gun hand. Hey, hey, my. Flowing too much hydrogen and you will die. You know, saying it's better to burn out than fade away here in this particular scenario doesn't really make sense. Because hydrogen will burn, and it burns really good. Now, I know what people are going to say. I know there's somebody judging through the computer. Not me. They're judging NASA. No, not you. Not you. You. Yeah, the guy in the back. Yeah. You're like, what do you mean? You can't get a freaking seal to work correctly? Now, don't get me wrong. I understand the frustration. It's a little annoying, isn't it? This is a new rocket. Even if it's using old parts, it's still a new configuration for this. You still have to learn new things. You can't, if you take the engine out of a car and put it in another car, it's not going to act exactly the same, is it? Even though you reused the engine. See what I'm saying? If you took tires off of a Humvee and put them on a smart car, it's not going to work the same. And with NASA, with rocket science, with engineering, a really important thing is understanding what the heck you just made. What did we just make? And how does it work? What are its limits? Now you can figure out a lot of that with analytical data, like basically nerds crunching the numbers, right? You can figure that out a lot that way. But that's just one part of the battle. If your nerds crunch a bunch of numbers, right? And they say that, oh, it's going to do this if you do this, 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 and this. And then you go out on the test stand and you do this, 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 and this, and the thing blows up. Well, your numbers weren't right, unless that's what the nerds told you what was going to happen. If the numbers say that it's not going to blow up and you put it on the test stand and it blows up, you didn't do something right. And that's what I mean about understanding what you made. It's a new vehicle. Even though they're using the same parts, it's a new rocket. It's going to do something different. Doesn't matter if you use the same parts. And they did. This is using a lot of shuttle components. Not the actual components off the shuttle. They're shuttle derived, which means they're based off of it, but they're not the same. They're the sequel, so to speak. Okay, Thomas, you really want me to see those Elon tweets, but tanking test. So, yeah, I know it's kind of annoying. It's a little bit frustrating. It's like, what do you mean they can't get a hydrogen seal to work? Like, really? Give them a second. They'll get it right. They will get it right, and I guarantee you, when they get it right, it's going to be awesome. Hi, how'd it go? They're still tanking right now, Bree. Good morning. That's right, Hal. The hydrogen.
Just about 10 minutes before 9 a.m. Eastern Time here at the Kennedy Space Center in Florida. You're looking at a live picture of Launch Complex 39B, where the Space Launch System is on the pad, and currently cryogenic loading operation demonstration test is underway. We are flowing liquid oxygen into the rocket at this moment. And we are currently chilling down the other side of the propellant, the liquid hydrogen.
That's what he means by chilling
down the lines that lead
from the cryosphere
to the mobile launch pad. So far, procedure is going very well. The cryogenic loading operation in sync. And we currently stand at roughly 5% full on the liquid oxygen side. Again, we're just about 5% full. It's a 196,000 gallon tank, but the liquid oxygen is very dense, so it takes some time to fill that. We're going to be in slow fill for
this UI makes me want to listen to
just about 15 minutes,
music.
And then we're going to transfer.
I can't understand why.
To fast fill, and that's roughly 3 hours. A long pole in the tent, so to speak. I want to also make you aware of a programming note. You can see on your screen there, we're tracking the capacity of the liquid oxygen tank, and you can see there, minus 295 degrees Fahrenheit, super chilled liquid oxygen.
Couldn't they use some kind of cooling effect?
That when combined with the liquid hydrogen creates the...
Couldn't they use some kind of Cooling effect? Well, Paul, that's why they slow fill propellants, dude. Yeah, yes. They move the propellant slowly to bring the temperature down slow, and that creates the seal. Remember, the line isn't designed to work at ambient temperature. It's designed to work at minus 400 degrees. 271 C for you. Minus 420 degrees Fahrenheit. Minus 271 C. So it's designed to work at minus 200 C. It doesn't work. The line won't work correctly at 70 degrees or 20 C. It won't work correctly. That won't work. It's designed to work when it's really, really cold. You got to slow fill it, though. You got to slowly cool it down, and that's what they're trying to do.
That is the link. That is where you'll find the tanking test. If you're
Why
not
does the LOX go
already,
down sometimes? I think that's
again,
just
on the NASA public channel. We'll be switching to
or it's boiling off.
Coverage from our friends
one.
at Johnson Space Center for the Soyuz
Ain't
launch.
Gonna feel like that.
After the completion of the Soyuz launch coverage, tanking coverage will resume to NASA TV's public channel. Again, that's set to begin here in just a few seconds.
27th inverter.
This is Artemis Launch Control.
But it really depends on this test, guys. The 27th is what they have penciled in right now. It depends on if they can flow the hydrogen. If they can fast fill the hydrogen and the leak rates are acceptable, below 4% of the total flow rate, we're good. We're good to go. Yeah, a launch on the 27th is looking good. There is one other hurdle that they have to overcome. The other hurdle that they have to overcome is the flight termination system. So this is an uncrewed rocket. There's nobody on board. But if something does go wrong, they have the explodey key. The range. So the range for rockets is basically like what the air traffic control is for an airport. That's they basically oversee the launch. They're the stewards of whether you can launch or not. The range monitors weather, conditions, temperatures that basically end the corridor to make sure that there's no planes flying around or anything. That's what they do. They're an air traffic control, but for rockets. I would say space traffic control, but that's not really the right way to say it. So the range guys have to make sure that the systems on board SLS, in case something, like God forbid, if something goes wrong and the rocket starts flying like over Cocoa Beach or something, or it starts going towards Orlando, the range guys have to be able to make sure that they can hit the button and the thing will terminate. It's called a flight termination system. Why? Because it's a system that terminates flight. Engineers aren't really good at naming things. You know what I mean? The flight termination system is basically a detonation cord that's up the side of the rocket. That goes up the side of the rocket. It's a det cord. And that det cord is attached to a battery, right? And there's a switch with a receiver on it, right? So if the range hits the yeet button, it'll send a signal to that receiver. It'll receive the signal, and it'll basically ignite the det cord. And the rocket explodes. That's only if something is going very, very wrong. But they have to make sure that those batteries are charged. Now, where are these batteries located? Well, there's batteries all over the place. There's one, I'm not sure exactly where it is, but I know there's one on the SRB for the flight termination system. There's one here, there's one there, there's one on the core stage, and there's one on the ICPS as well. The upper stage, which is the white upper stage that's right there. I know there's a termination system on all of those. So they have to make sure that the big one that they're trying to monitor is the big orange tank, the core stage battery. So basically what NASA is doing right now is they have to prove to the range that those batteries are still good. They're still charged. Now, don't get me wrong. It's not as simple as like going in and putting it on a charger and just being like, see, it's charged. It's good to go. Those batteries are not in easily accessible places because they really weren't designed to stay out here for this long. But if NASA can prove that it'll be okay, hopefully not with demonstration. If they can prove that it's okay with the numbers, then the range could approve the 27th for a launch window. That's why I say the 27th of September. So that's next Tuesday. Tuesday could be when it launches. It really depends. It's pending range approval. They have to make sure that if the rocket flies in the wrong direction, however unlikely that might be, that they can make sure that it doesn't hurt anyone. Hey, Zero. 29 months, the longest sub on Twitch. Thanks for the good streams. My pleasure, man. Nearly 1 hour to go. Forge, you You got me pictures of the carrier umbilical plate with the taper and the seal. That PDF. Can you get that PDF? I need that PDF today and I can't find it. The one you sent me about Ares 1 with the ground umbilical carrier plate and the TSMUs. If you could find that, dude, that'd be awesome. Ready for another long day next Tuesday? I was born ready, dude. I've been waiting for this for easily over a decade. This thing, man, when it goes, it's going to be unbelievable. Basically, Hal. Yep. That's right, Gujar. Yeah, you got it. I sure hope there's a cap on that button. Oh, yeah, there is. Yeah.
Discovery,
it's time to wake up. Huge Grit gifted us up to Forge. You mean this one? No, that's for the GUP on Ares. That's not exactly the one that Forge got me the other day when we were talking about this. I have that one already, Thomas. There was another one that showed like cross sections of the tapered fuel line and the carrier umbilical. It was isometric, looking at it from the side with the seal and everything. That's the one. I can't find the dang thing. That sounds right, Perky. Yeah, I mean, I would say, yeah. Launch operations.
It's 9 a.m. Eastern Time
take a second,
here
but
at
yes.
the Kennedy Space Center in Florida. You're looking at a live picture of the Space Launch System at Launch Complex 39B. We are tracking operations here on NASA's media channel. Thank you for joining us. If you're just tuning in, we'll get you caught up on the operations. We are in the midst of a cryogenic demonstration test with NASA's moon rocket. As we look up at the rocket skyward, some light clouds overhead. Weather has been cooperating with the start of tanking today. We are underway with liquid oxygen tanking.
Yeah, Rora, there's 1,000 faster ways.
Just hit 5%.
We want to make sure that's the one that we use if we have to use it, right?
196,000 gallon tank and the liquid oxygen side.
Oxygen.
Which is in the upper portion of that rocket, as you're looking there.
The
liquid hydrogen, they are preparing the transfer lines, which run from the 900,000 gallon cryosphere, liquid hydrogen cryosphere, to the mobile launcher and into the rocket. They're pre-chilling those lines down to prevent thermal shock. The liquid hydrogen combined with the liquid oxygen, the oxidizer, create a very powerful thrust that helps put 2 million pounds of thrust right through those RS-25 engines that you see at the bottom, right there in the center of your screen. On either side are the boosters, 5-segment solid rocket boosters. Together they put down 6 million pounds of thrust, altogether 8.8. And that gives the lift necessary to put a spacecraft in orbit around the moon.
That's the one.
We are checking a new procedure today in loading the liquid hydrogen after scrubbing the last launch attempt on September 3rd due to a hydrogen leak.
Thanks, man. Danke.
The seal where the leak happened has been repaired. It was on the propellant line that feeds super chilled liquid hydrogen into the rocket. It is just on the other side. Yeah,
Nachos, it very much seems like they flowed too fast, huh?
Launch teams over the past few weeks demated a connection plate where the umbilicals flow those super chilled propellants into the rocket. They demated it, pulled a seal that had an indentation on it, replaced that seal, and then made sure the rest of the connections were sealed up good. When the rocket lifts off after it's fueled, that plate on the other side pulls away from the rocket, allowing it to lift off.
Space flight is about being patient. Okay. Oh. Gotta be patient. This stuff takes time. And it's annoying that it's taken.
Coming
I'm
up,
not
we're
going to
getting
sit here
ready
and
to
say that it's
start
not annoying that it
flowing
hasn't
that
taken
liquid
this long to
hydrogen
go back
into the tank.
to the moon, because it's really freaking annoying. But I understand what you're saying.
They're pre-chilling the
At
lines.
the end of the day, at least we're doing it. We're getting there. That is a sweet picture. It's on one of the lightning towers. So if it doesn't work, would they have to roll back to the VAB? They're trying to avoid a rollback to the VAB pretty much as possible. I'm not going to sit here and say that rolling back to the VAB is going to damage the rocket, but it'll more fatigue the rocket in a way that's not conducive to proper testing. Long story short, in an ideal scenario with SLS, right, you'd build the rocket in the VAB, you'd roll it to the pad, and then you'd launch it, right? NASA's trying to emulate that, like the ideal circumstances to get a good baseline. They need a good bench test for the rocket. That's what this is. Not this particular tanking test. The Artemis 1 mission is a bench test for the vehicle. And if your test vehicle...
Everything proceeding nominally at this point.
If your baseline data includes a certain amount of rollbacks to and from the VAB,
the shot of the pad
you could put the vehicle into a... Your baseline data could be based off of...
the fueling...
Not junk data, but you're not getting a good baseline. Your baseline could be offset to what it actually should be.
It's at the lower part of the mobile launcher. So if you're looking at the rocket, go down to the bottom.
He's talking about the fuel line. It's right there. So now don't get me wrong. That core stage was used during the green run. It's been fired for a full duration burn. They used it for tanking tests. They used it for the wet dress rehearsal. They're already a little bit away, but they designed tolerances into the vehicle to be able to still emulate baseline testing data, or to give you a good bench test. Long story short, that thing is overbuilt. It's way overbuilt to be able to account for all the problems that could happen when you enter a launch campaign for the first time with a brand new vehicle that's in the super heavy launch class. Basically designed to go to the moon. Building rockets to go to the moon is tough. It doesn't matter if it's Apollo. It doesn't matter if it's now. It doesn't matter if it's in the 60s. It doesn't matter. Building moon rockets is tough. Even with all the technology that we have, there's still a lot of things. Like the rocket science is more bound by physics than anything. The technology is just, like with computers and stuff, we can figure out better ways to understand the physics, but the physics are still there. You're still bound by the same physics at the end of the day. It's just like if you look at a car, for instance, from the 60s, it still has a tire on it. It still has 4 tires. Cars nowadays still have 4 tires. There's not really much you can do to get around that, right? Like a car usually, I mean, I get it. There's like Reliant Robins and stuff, which we should make into space shuttles and motorcycles and whatnot, right? But even a motorcycle design, that hasn't changed much, right? Reliant Robin space shuttle. The physics doesn't change. Having 4 wheels in a car is still the most stable way. The Reliant Robin kind of showed that it's probably a good idea to do that. Top Gear. That's my favorite episode of that show. But so this still takes time. You're still, it doesn't matter with all the computers that we have. It still doesn't matter. It's going to take time. You got to understand what you made here, When you're free, sometime you can check this. NASA did transfer the quick disconnect tech to industry. Check the timestamp. That's the disconnect. Okay. Anyway, so they want to make sure that they get a good baseline, and that's how they don't really want to roll back to the VAB, because it could put it too far out of family that when you go to put the second one on the pad, the launch campaign was so ridiculously different from the test flight, it's really hard to kind of plot that, like what Artemis 2's baseline data would be and Artemis 1's baseline data would be, because the launch campaigns are so different. NASA really doesn't want to put the vehicle, they don't want to put the vehicle into a mode that could potentially hit like the one side or another of that nominal window of what gives you a good baseline data. Yeah, it's there's really not a better way to explain that. Like, if that doesn't make any sense, yeah, I'm trying to think of a good analogy, but it is a little early and I still need more coffee. Are you planning on going to Artemis 2? Yes, I'm going to go to Artemis 2. I don't want to go down to Artemis 1, but it is short notice at this point. I should have probably done that right after, but I had so much real life stuff to deal with that I haven't. There's cars with 6 wheels, the AMG 6x6 and the Hennessy Velociraptor. Yeah, Sevi, I know. I know. I knew you would do that. I knew you would do that. But you missed the point like usual. Dude, it's not, and I'm not trying to be a dick. How many cars have 6 wheels? There are cars with 6 wheels, but how many of them have 6 wheels? You named 2. How many production cars out there have 4? See what I'm talking about? You see what I mean? You missed the point completely. Like, you're over there. We're at the goal and you're in midfield. You know what I'm saying? Like, I know there are 6x6s. I want one. I know, but that's not what I'm getting at. I understand, dude. I didn't miss the point. I'm just trolling. What? Sevi, I can't hear you. I think your internet connection's going away. I can't hear you. You're breaking up. What was your last message? I didn't see it. You must be going into a tunnel or something. Guys, can you hear what he said? I can't hear what he's saying. I don't know. He must have gone into a tunnel. Oh, there you go. You're back. Jeez. Can you hear me now? No. Not good. I saw one of those AMG 6x6s and it was chrome gold wrapped and it was like a GTA car in real life. Money don't buy you taste, serious, am I right? Ugh. Any news on the range waiver extension? Matt, I haven't heard anything. Nah, not yet. I think they won't announce if the range is good to go until they make absolutely sure that LH2 can flow correctly, dude. How's the test progressing? They're slow filling liquid oxygen and they're priming the hydrogen lines, Drummer, but we haven't had an update in about 10 minutes. Hey, Prey, what's going on? I do have kind of a PDF of what we're looking at here. Now, keep in mind, this is the vent line. This is not the fueling line, but they are similar. They're similar, but they're not exactly the same. Here's, and Forge, thank you for getting this for me. Yeah, see, this is the GH2 vent interface. SLS does have something like this, but it's not exactly like this. But see the seal right there and the taper? This is an isometric side view. See the seal and the taper? That's exactly the kind of thing we're dealing with here. If that seal doesn't contract around the taper correctly, I mean, keep in mind this is a vent line, so on the fill line it would be the opposite of this. In this diagram, gaseous hydrogen flows this way. In the fill line, liquid hydrogen would flow that way. And it would kind of be the reverse of this, like there. See the taper? The taper would be rocket side instead of vent side. And once again, that's not the exact seal. That's not the exact thing that we're talking about, but it kind of looks like that. Kind of. It's not exact, but see what I'm talking about right there? The taper. That's what they needed to seal around. Once again, it would be inverted because this is a vent line. It would be inverted because that's a vent line and not necessarily a fueling line. The differences. But that's the general idea here. I've worked on a 6x6. Not fun. Ew. Will we ever see you at Hot Rod Drag Week? Oh, I'd go, Noswolf. I got to build a car for it before we do that. But I would love to do that. Yes, that would be amazing. So, yeah. Forge, it seems like all we can get is really the ground umbilical carrier plates. And see that? See the three-pronged thing? That's the thing that we were just looking at in that PowerPoint. SLS's umbilical doesn't really look exactly like that. It's inverted from that design because it's a fill line and not a vent line. But that's generally the idea. And Forge, I've done my homework since you showed me these PDFs, and I've done my homework since you showed me these PDFs, and I'm like, I have no idea what I'm looking at here. Yeah, that's kind of, once again, this is a vent line, so it doesn't exactly look like this. Yeah. Yeah, it has a probe and drogue, basically. Let's see what NSF's showing. They're showing the same thing. Okay. So once again, guys, what you're looking at here is a tanking test for SLS. No, it's not launching today. Last time they did do a launch attempt, they had problems with the fuel line. The fuel lines were leaking too much. Now, don't get me wrong. They're designed to do that because flowing liquid hydrogen is annoying. It's really, really hard to do. It's not just like filling your car up with gasoline or petrol or whatever. It's not that simple. You know, if you go to fill your car up, you see the vapors come out of the fuel tank, and it kind of distorts light a little bit. You see the little waves coming out when you go to fill the car up with gas. They have to worry about that, but with hydrogen. Yeah, and you don't want that to go around the rocket where, you know, the hot parts are. It could cause an explosion. You don't want that. Actually, I could get you something to show what happens when you have copious amounts of unpurged hydrogen. A Delta IV Heavy is actually a really good idea. ULA released this video the other day. United Launch Alliance operates the Delta IV rocket. There's only 3 of them left, and the L91 mission is coming up. So you're going to see this is the last time a Delta IV is going to launch from Vandenberg Space Force Base in California. The last 2 Delta IVs are going to launch from the Cape. But here's what happens if you don't catch the hydrogen and purge it. Take a look. Watch down there. See that? You don't want that to happen to SLS. Bad idea. Why is it okay for Delta? Well, Aldezert, I anticipated that question. Why is it okay for Delta? A number of reasons. RS-68s are the big thing. There's not really a good way to get around it. The engines that are in a Delta IV, if you notice, there's 3 big boomy boys down at the bottom, right? They knew that, long story short, they knew this was going to happen with Delta IV. Because you see those 3 big things right there? Those are RS-68As. Now, little bit on propulsion here for the propulsion nerds. That's an RS-68A. If we look at a picture, thanks for the bits. The thick Australian accent, welcome to this week's world of explosions and fire. All right, so with an RS-68, take a look. Let's take a look at it. Propulsion nerds, what can you tell me about this motor just by looking at it? Anyone? So, if you're a little bit of a propulsion nerd like I am, you'll notice that this engine is what's called open cycle. Okay, it's glorious. I mean, you're not wrong. It's a gas generator, open cycle, liquid hydrogen, liquid oxygen motor. Now, don't get me wrong. The RS-68 is derived from a shuttle engine. The shuttle engine is derived from a J2. But the thing about the shuttle engine versus the RS-68A is that the RS-68A is an open cycle engine. What's open cycle? Well, you see that big exhaust pipe right there and that big exhaust pipe right there that seems to have a lot of gas coming out of it? That's open cycle. If we look at an RS-25, right? The RS-25, you don't really see anything like that. The reason why you don't see any pipes dumping over the sides, the reason why is because the RS-68 is a closed cycle engine. If you really want to know, it's a closed fuel-rich stage combustion cycle. I can get more into that in a second. Long story short, actually, this is, you know what? I'll be honest. This is not going to be a short story. Propulsion is complicated. So, okay, hear me out. So, with liquid hydrogen and liquid oxygen, when you're using what's called a hydrolox motor, which is a fully cryogenic motor, because long story short again, no, both your propellants are really cold, right? You have 2 gas generators here on an RS-68. Let me back up a little bit and see if I can get you a better picture. You have 2 gas generators on that thing. That's actually a really good picture. So these gas generators right here are basically little jet engines. They're a jet engine that uses liquid hydrogen, or gaseous hydrogen and gaseous oxygen. They generate gas. I know, complicated, right? They generate gas, and that gas turns a turbine. There's a turbine wheel right here, like on a jet engine. And what happens if you have a pinwheel and you go, you force gas through a pinwheel? It spins, right? That's what a turbine is. That turbine is connected on an axle to a fluid impeller up here, or just turbo pump. Turbine, pump, turbo pump. It's a jet engine that spins the fuel pump. That's what it is. And it's a jet engine that has no intake because you have the oxidizer already on board. There's no air, you don't need to suck in air. Where the rocket engine goes, there's no air, so you don't have an air intake. That's why it looks different than a jet engine. But it's the same idea. There's a combustor in there, and that combustor is taking hydrogen, gaseous hydrogen and gaseous oxygen, and using it to spin a turbine. Now, why is there 2 of them? Well, when you're flowing liquid hydrogen and when you're flowing liquid oxygen, the turbines have to move at different rates. They have to move at a different rate, the different RPM, because you have to move hydrogen faster than you do liquid oxygen in order to get the right fuel ratio inside of the rocket engine. How much oxidizer and how much fuel you deliver.
Update on the cryo loading procedure here at 9:21 a.m. Eastern Time here at the Kennedy Space Center in Florida. You're looking at a shot of the engine section and the solid rocket boosters of the Space Launch System rocket, currently in the midst of a cryogenic demonstration test. You can see the vapor coming up there, just water vapor condensing from the venting of liquid oxygen, which is flowing into the rocket. It is the oxidizer that provides the oxidation of the liquid hydrogen.
They're fine, Fire 2. They wouldn't be testing it out here
thrust through those 4 RS-25 engines that you see at the bottom. We're currently at 15% filled on the liquid oxygen side.
He could aerodynamic,
and we are also flowing liquid hydrogen. From this shot here, you can see the lines that go into the bottom of the rocket.
That rocket is
gray protrusion called the tail service mast.
Look at how nice that looks.
That is where the propellant is flowing into the rocket.
Beautiful.
Both sides are
beautiful,
flowing.
Man. Look at that thing. Oh, that just looks so right.
We are about 15 minutes into slow fill for liquid hydrogen.
Okay.
And this is a part that
right, Dark Guy. Look at that. Oh,
been looking
pretty,
forward
man.
to seeing.
Oh.
There was a leak that was repaired in the fill line that is currently flowing propellant at this time.
Yeah, you're not wrong, Oswald.
They've got a mild pressure on the storage tank, which allows the liquid hydrogen to flow into the rocket. And they do it with just the pressure of the propellant evaporating into a gas. There are no pumps on the liquid hydrogen side, unlike
that's right
on the oxygen side. The procedure they're doing today is a kinder and gentler procedure where they are stopping and checking before proceeding to the next milestone of the in the tanking of the liquid hydrogen.
That's just
taking a moment just to look and check it.
Oxygen.
And
I hope there isn't any kindling down there. We don't need any more explosion than what comes out of the rocket engine.
Carefully dropped to cryogenic temperatures. And there's a great shot right there of the tail service mast umbilical.
Yep.
That was the area that was prepared. The gray protrusion, you see the lines going into the rocket
I know,
there.
Slipped. He definitely did. He's reading chat. Daryl, you here? Wave if you're here.
The launch team put an enclosure over that entire area when they went to repair it.
No, not
we have
you,
a graphic
Plius,
which is
unless you're
updating
Daryl,
us,
in which case, hi. I love your work.
on the progress of tanking.
Daryl, do another William Shatner pause if you're watching the stream.
I'm just hearing now from the launch team that they're slowing the liquid oxygen pumps just a little bit. And that is because they're waiting to get a little more liquid hydrogen in the tank. There is a requirement called the aft strut constraint, which requires that before the liquid oxygen gets to 50%, it's at 16% now, but before it gets to 50%, they have to have at least 5% in the tank on the liquid hydrogen side, and they're not yet there yet. So just anticipating, the launch team is that they might need to slow the pumps a little bit.
Okay. 27th is what's penciled in right now,
that,
Arrow.
That requirement valid.
So, aft strut constraint. Here, I'm going to keep Daryl unmuted just in case. The aft strut constraint. So,
again, going back to the repair of the 8-inch fill line on the liquid hydrogen side. So that's where the repair happened, in the area between the rocket and the tail service mast. They enclosed that area completely from the environment and made repairs to a defective seal that they pulled out of the fill line. And in between rain showers that happened over the past few weeks, they managed to complete that repair with the rocket on the pad. Something that they would like to do in the VAB, but in order to preserve a possible launch period here in the next week or so, provided that the launch team get a waiver from the Space Force for the flight termination system batteries.
Interesting, Forge. Of course.
They did all these repairs on the pad. And so I'm monitoring now as the team is
that's supposed to happen,
fueling
fellas.
the liquid hydrogen.
I'll tell you why when we get back to talking about props in a second.
With the new loading procedure. We started loading liquid hydrogen at 9:09 a.m., so we are just about 17 minutes into that operation. It lasts about an hour. After that, we will have liquid hydrogen in fast fill.
Nothing right now, Ark. It's pending range approval. So,
it's going to be
aft strut constraint. This is a GIF that my buddy Tristan Moody.
And then 15 minutes later,
and it shows
they'll start that engine bleed kickstart.
It shows why the aft strut constraint is a thing. So take a look.
And in order to do that, they seal off the vent. Pressure rises in the tank, and this will give us
look at the aft struts.
A good look at how that seal is holding.
So let's make sure, stop for a second and make sure that Daryl is good.
Once this test is completed, the SLS rocket will launch an uncrewed Orion spacecraft from right here at Launch Complex 39B.
We know what it's going to do. All right. So the aft strut constraint that he was talking about, they can't fill up the liquid oxygen tank too much without having the hydrogen tank filled up at least a little bit. The reason why is what you see on your screen. Look at the aft struts. So my buddy Tristan made this a little while ago. See the aft strut? There's a reason why you have to fill up the hydrogen tank at least a little bit. The main reason why is because SLS does not get structurally sound until you have a certain amount of hydrogen in there and the vehicle has contracted. Hydrogen propellant, liquid hydrogen, very freaking cold. You have to flow enough of it in there. The vehicle is not designed to fly with an empty fuel tank, right? It's designed to fly with a full fuel tank. You have to take into account what's called thermodynamics into this. When SLS is fully fueled, it actually contracts, and that's when everything moves into alignment. When it's just sitting there on the pad, the core stage is actually just kind of hanging there. But when it fills up with fuel, the whole entire tank will contract a little bit, and it'll pull the struts up into position. See where it says 813? Right? Above and below it. Below it, above it. Below it, above it. See the struts moving? That's the aft strut constraint. If you fill up the rocket with too much liquid oxygen, you could bend those struts. Pretty straightforward stuff. See that? The rocket's only designed to work when it's fully fueled. Because, I mean, at face value, you're looking at that and it's like, the whole thing bends? Is that supposed to do that? Yeah, of course. You're not going to launch the rocket with a half tank of gas. Why would you do that? You will not space today if you do that, right? The thing's only supposed to launch and be structurally sound when it's fully fueled. A lot of rockets do that. A lot of rockets do that to save mass. Why does the rocket need to stand up by itself? If it's standing up by itself, that means you intend to launch the stupid thing, right? It's not stupid, I get it, but see what I'm saying? Kind of interesting how they work with thermodynamics to get the rocket to be the strongest that it possibly can be, only when it's fully fueled. That's why that aft strut constraint exists. That's why it's there. Because if you fill up one tank and don't fill up the other one, well, if the bottom of the rocket isn't structurally sound and you go to fill up the top of the rocket, you're going to have a problem. It'll tip over. We don't want that. I've had that happen in Kerbal many times. Not good. Not fun when your rocket just... That usually leads to explosions. Usually. Also, I've never seen that camera before. TSMU cam. Oh, that's sick. That's the hydrogen TSMU right there. And that's the oxygen TSMU. Tail service mast umbilical. Basically the fuel lines. There's a picture of the fuel lines. Are any of the SpaceX crafts the same way? Falcon 9, absolutely, Frozen. Yeah. Falcon 9 really can't stand up in full stack configuration with no fuel in the tank. No, absolutely not. It'll tip over. Now, I know what people are going to ask. Well, EJ, how can the first stage stand up by itself then when it comes to land? There's nothing on top of it. There's no second stage that's fully fueled on top of it. That's how it can stand up by itself. But if you have a Falcon 9 with an empty first stage, right? With an empty first stage and a fully fueled second stage and a payload on top, the thing will fall over. True story. That's why they have the transporter erector. The erector on Falcon 9 will hold it in place. There's those clamp arms at the top. They'll hold the second stage in place. And then when Falcon 9 goes to launch, they release it and move the strong back away. The rocket can only stand up straight when it's fully fueled. And once again, that's on purpose. Because why do you need to make the rocket stand straight up with no fuel in the tank? That's just a waste of materials, right? And with rockets, it's all about min-maxing it. Factorio players, if you're here and you play Factorio, you know exactly what I'm talking about. You got to min-max everything to make it the most efficient it possibly can be. You especially have to do that with rocket science. That's really, really important. Because the way I like to explain it feeds into basically like the general rocket science formula for how far a rocket can go. It's called the ideal rocket equation. But I don't like to, I could sit here and show you the ideal rocket equation, which is change in velocity is specific impulse times gravitational constraint, natural log, final mass, initial mass over final mass. If that made no sense, what that means is the more fuel that you have on your rocket and the less rocket that you have on your rocket, the further your rocket will go. If your rocket is more fuel tank, less rocket, you go further. Simple as that. That's a really simple way of explaining it. So, with rockets, if you can use the fuel for structure, right? The pressurized fuel tanks, if you can use that to help keep the rocket straight up, you don't need as much rocket on your rocket. So your rocket can go further. It's more efficient. You have more delta V. You can change your velocity further. Understand? That's called initial and final mass. That's a really important thing to understand. And the relationship between initial and final mass is called a mass fraction. Rockets are generally, like 98% fuel and like 2% rocket. If you can get it to like 99% fuel and 1% rocket, you're way more efficient. That is way more efficient. You'll go way further. 30% less rocket per rocket. That's right. Anyway, we were talking about open cycle propulsion here, fellas. So the R68, why does the Delta IV, which also uses hydrogen, why does it do that when it goes to launch? See, watch right down here. Hydrogen. Why is NASA worried about hydrogen leaks? Well, they're worried about hydrogen leaks because it does that. See that big that area down at the bottom? Not here or here so much, but right in this area here. You see that? Yeah, that's hydrogen. That's burning hydrogen. Hydrogen, if it's burning off, it burns orange. See it like that? Right in here? That burns orange. Now, I don't think you want that to happen, but Delta IV, they did take that into account when they made Delta IV. The reason why is because the R68 is an open cycle engine. Now, when Daryl was talking here a second ago, I was saying why. Well, what makes it open cycle? What is an open cycle engine? Where I was talking about is that you have two gas generators here. There's basically a jet engine, right? It's a jet engine, but it has no intake because it's using liquid oxygen and liquid hydrogen. You have two of them. See these the gray things right there and right there? Those are gas generators. And what makes it open cycle is the exhaust from the gas generator, because it's a jet engine that's spinning a fuel pump, a turbo pump. Where that exhaust goes is it gets dumped overboard. This is an open cycle engine. Now, keep in mind, there are many there's only really one type of open cycle engine like this, right? If you're open cycle, that means you're dumping your fuel pump exhaust overboard. But open cycle could mean a lot of different things. The Delta IV Heavy and Delta IV rocket engine, the R68A, is an open cycle engine. So they're dumping it overboard. In the particular case of the R68, if you notice, there's a flex pipe right there and there's an actuator. They actually use that to steer. It's called a vernier thruster. They're using it to steer the rocket. So a Delta IV can launch with a single core with a single engine, and it can actually roll because they actually divert the gas coming out of the hydrogen pump. True story. Now, from there, with the R68, from there, your fluid impellers here go into the combustion chamber, and they make explosion in there, and explosion comes out the nozzle. This is different than a shuttle motor. The shuttle motor is a closed cycle engine. More specifically, it's a fuel-rich stage combustion. Now, what is that? Okay. What's the difference? Well, one, you're not dumping anything overboard with this particular design. What they do with the shuttle engine, and once again, fellas, if you know propulsion, bear with me. I'm trying to keep this simple because there's a lot of new faces in here, okay? So I'm trying to keep it simple. Bear with me. I know the difference between an open cycle two-turbine hydrolox motor and a closed cycle fuel-rich stage combustion, okay? Just bear with me here. They figured out in the 70s that if you took this, right? If you took the gas from the gas generator and you figured out a way to dump that in to the rocket motor, you can make way more thrust that way. Why? Why can you do that? Well, rocket engines are combustion engines. They are an internal combustion engine, just like a car. But they're not exactly like a car because rocket engines don't have a piston that goes up and down. They just take the gas and they shoot it out of Venturi. Straightforward stuff. But in order to get good combustion, you need to have what's called atomization. That's really important. And I swear I'm not just making up words, okay? I swear. I'm not just making up words. What's atomization? Atomization is what happens when you take fuel and oxidizer and you introduce them to each other in a low pressure environment. They spread out. And when stuff spreads out, they tend to kind of attach to each other. The liquid oxygen and the liquid hydrogen in the case of, like the shuttle engine or an R68, right? They attach to each other. The better atomization that you can get with a rocket engine, the bigger explosion you can make. And if you can make a more energetic explosion, you create more thrust. And honestly, it makes it more efficient as well. Because all of the fuel that you're putting in there gets combusted, right? It gets blown up. You're not shooting extra, like carbon emissions, like on a diesel truck. You're not shooting coal out the side or carbon emissions. Or in the case of a rocket engine, like a Hydrolox rocket engine, water. Yeah, water's a byproduct of unburnt propellants coming out of the rocket engine. It literally creates water vapor. Funny story. So what they figured out in the 70s, and this is why the shuttle engine is still used today with SLS, is that if you can find a way to atomize your fuel better, right, you can create a bigger explosion inside of the rocket engine, and you can create a more powerful, more efficient rocket engine. Now, the other thing is that it's easier to atomize gas than it is to atomize a liquid. On a car engine, you have oxidizer in the form of a gas being combined with fuel or gasoline or petrol in the form of a liquid, right? So you have a liquid to gas atomization. If you want to see this visualized, there's a video by a YouTuber called Smarter Every Day. So it's Destin. He has a video about carburetors where you can see fuel get atomized in real time because he made a carburetor out of acrylic. And you can see the fuel get atomized. Rocket engines do the same thing. Rocket engines do the same thing as a carburetor or a fuel injector on a car. Same thing. It's just spraying the fuel and going from high to low pressure really, really quick to try and get better atomization. So with the shuttle engine, they figured out that if you take the exhausts right here and you dump them back into the engine through what's called a preburner, you can create a much stronger, much more efficient motor. And that's why the shuttle engines are still used today, because dude, this is cutting edge technology even by today's standards. Now, Aerojet Rocketdyne figured this out in the 70s, which is unbelievable. So what they do with the shuttle engine is you have preburners. Well, actually, you have one preburner, but you have two power heads on the sides of the shuttle motor. And what they do is they take the liquid hydrogen and they basically get the hydrogen to go to, they combine the hydrogen with a little bit of oxygen before the rocket engine, before like the big boomy part, right? And they get the hydrogen to turn to gas. So basically they combust the liquid hydrogen inside of what's called a preburner. Now, I'll get to why it's called a preburner in a second. And then they use a little bit of oxidizer to take that hydrogen and blow it up. Basically turn the liquid hydrogen that's coming in from the fuel tanks into a gas before they put it into the rocket engine's main combustion chamber and blow it out the bottom, right? They turn it into gas. If you atomize your hydrogen, right, and then combine the hydrogen with liquid oxygen, you get much better atomization and you get much better efficiency. Shuttle engine has like literally no emissions. The only thing that comes out of the back of a shuttle motor is water because you're using hydrogen and oxygen. And if you take hydrogen and oxygen, you combust it as a gas and then you shoot it out the back, it's really hot. And then when it finally condenses, because the gases don't stay hot down here for a long period of time, right? They find the atmosphere and they exchange heat with the atmosphere, et cetera, it'll turn back into water. The H2 and the O will combine and you get water. That's it. That's the only thing that comes out of the back of that thing. But because they can atomize that hydrogen and get it to expand and spread out like crazy by blowing it up a little bit through the preburner, they spray liquid oxygen, liquid into a gas, just like a car engine, and it makes it super freaking efficient. Now, so that is an example of what a fuel-rich stage combustion cycle engine can do. That is a closed cycle engine. The RS-68 is open cycle. So with the RS-68, you're going to have that hydrogen explosion. There's nothing you can do about it because of the open cycle on your engines. Your engine is going to shoot that atomized mixture out the bottom. Now, don't get me wrong. So why they do that with the RS-68? Cost. They did it because it's low cost. It's easier to make an open cycle engine than it is a closed cycle engine. So when the Delta IV goes to launch, you have the engines throwing out liquid hydrogen or gaseous hydrogen, atomized hydrogen out the bottom from the gas generator, and it creates a big explosion like that. You don't want to do that with SLS. They don't have to worry about that, to be honest with you, but that's why they're so worried about hydrogen leaks in the first place, because you don't want it to do that if that's not intended. With Delta IV, that is intended because you can't really do much about it because of the open cycle engine. No, Forge, I don't know. I've seen that, but who knows? So, a little bit on why Delta IV explodes. SLS isn't intended to make a big explosion like that at launch. This explosion comes from gaseous hydrogen being all over the place because the exhaust from the engine is gaseous hydrogen. It basically Hindenburgs when it launches. It's the same exact thing. SLS doesn't do that because of the closed cycle in the engine. So with SLS, they're a lot more cognizant. They have to be a lot more careful with hydrogen leaks. That's really, really, really important. Okay? It's really important to understand that. I'm going to miss Delta IV Heavy. Yeah, me too. Me too. What comes out of the back of the SpaceX engines being methane? Carbon? Yeah, a little bit, Flatgate, but methane tends to be a little bit more... yeah, basically carbon. But the carbon emissions aren't that bad for a methane engine compared to like a Kerolox engine. The Merlin 1D motors that are on Falcon 9, those things roll coal because you kind of have to do that with kerosene. Just because if you want to use simpler propellants, you're going to have to take an efficiency hit. And a lot of the times, engines... Here, hang on. A lot of the times, engines run extremely fuel-rich to keep the motor cool. They spray way more fuel in there. They spray fuel... They run fuel rich. They spray too much fuel inside of the combustion chamber to keep the engine nice and cold. Now, that's SpaceX's Merlin engine. Can you tell me if the Merlin engine is open or closed cycle? Hey, Mike, what's going on? It's open cycle, Bryce? Why? Why is it open cycle? How do you know? Well, that big coal plume, that big unburnt carbon soot plume that's coming out of the turbo pump gas generator, yeah, that's a pretty good indicator. Yeah, see this this whole thing going on there. It is open cycle. Yeah. Now, I got another one for you, fellas. Here. Let's look at an F1 rocket engine. Saturn V rocket engines. The first stage Saturn V motors. Are those open or closed cycle? Think about it for a second. Look at the flames coming out the bottom. What do you see? I know, Kev. I know. Now, this is camera E8, by the way. SLS has an 8 camera, which is basically the business end of the rocket when it launches. It's a camera designated 8. If you look at SLS, if they go to camera 808, oh, it's right up there. There's camera 8 for SLS. It's the same camera, and we will get similar views to that eventually. To this, right? There is coverage, Dave, but I'd prefer to cover the tank test. So, it's closed. Well, you got a lot of soot coming out of the nozzle. Are they running fuel rich? No. I mean, they are a little bit. So let's take a look at an F1 engine, okay? So F1 rocket. If you type in F1 engine, it's going to pop up with something different. So if you guessed closed cycle on an F1 engine, you're right. But this is the thing. Closed cycle doesn't necessarily mean that it's a stage combustion, okay? Open cycle means it's dumped overboard. But there are different things you can do with the turbine exhaust here. There are different things that you can do. Remember how I said that some rockets, like Merlin, run fuel rich? They run fuel rich, and Raptor, frankly, runs fuel rich as well, to be able to keep the nozzle cool, right? The shuttle engine runs fuel rich. It favors the fuel combustion, it favors the fuel, the hydrogen. It favors the hydrogen, and they do that to keep the motor cool. They actually use the liquid hydrogen. That's what these channels are on the motor, those ridges. They're cooling rings. They run the liquid hydrogen through the nozzle, and then that goes into the preburner, and then that goes into the combustion chamber, okay? They favor the fuel for cooling the nozzle. Now, if you look at an F1 engine, on an F1 engine, it's closed cycle, but it's not closed cycle in the same way that a shuttle motor is. It's closed cycle because they're using the turbo pump exhaust to cool the nozzle. This is called closed cycle regenerative cooling. Now, I know what people are going to say. That I know what the next question is. Isn't that a jet engine? What do you mean the jet engine's exhaust is cooling the rocket engine? Well, it's all about relativity here, right? Relativity in terms of temperatures. The exhaust coming out of that is a lot cooler than the exhaust coming out of this. The exhaust that comes out the bottom of this is really freaking hot. Don't get me wrong. That's also really hot. I wouldn't stand behind either one of these. It wouldn't end well. But relatively, that exhaust is a lot cooler. So with the F1 engine, they have a closed cycle regenerative cooling loop. The gases from the turbine basically get spread into this manifold, and they film cool the inside of the nozzle. They provide a cool gas thermal medium between the nozzle, the really, really hot rocket flamey bits that come out the bottom, the gases from Kerolox combustion, and the unburnt fuel. It's called film cooling. That's regenerative closed cycle film cooling, right? That's why when the Saturn V engine goes to launch, it is a closed cycle, but it's not closed cycle in the same way that a shuttle engine is. That's why you have this black soot coming out the Saturn V engines, but it's only there for a second because it exchanges the heat with the extremely hot gases coming out of the bottom of the rocket, and it burns it off. That's why the Saturn V motors have this distinctive kind of stripe here in the exhaust plume. Is there an oxidizer-rich engine? That's a good question, Hinks. Yes, there absolutely is. Oh, yeah. Oh, yeah. Anybody give me an example? 4 minutes to launch. I know, guys, I don't really want to cover the MS-22 mission. Should the BE-3 in the tap-off cycle? Yeah, that's not a bad idea. The Merlin 1D vacuum, the second stage on Falcon 9 is a closed cycle regenerative cooling engine. They use that to keep the nozzle cool. Just like the Saturn V motor, but they're doing it with an upper stage engine. So, what's an oxidizer rich? Is there an oxidizer rich stage combustion cycle? Absolutely. That's the Soviet Union's contribution to liquid fuel rocket engines, and it is a damn good one. The RD-180 that flies on Atlas V is an oxygen rich stage combustion cycle. Now remember, I said with Kerolox, you run fuel rich to keep the motor cool, right? You run fuel rich to keep the motor cool. But it has a ton of carbon emissions, right? Just the byproduct of exploding hydrocarbons is it's not very efficient, but it's very energetic. You get a nice, good, healthy explosion. But you get a nice, good, healthy explosion because you're spraying a ton of fuel in there, right? You're spraying a ton of fuel. As much fuel as possible can combine with as much oxidizer as possible. And then there's some fuel left over, and then that gets shot out the bottom. Literally carbon emissions, right? The Soviet Union figured out that if you take your liquid oxygen and you atomize the liquid oxygen, or basically you turn it to a gas and then spray it into the fuel, you get a very energetic explosion. You get a very efficient kerosene explosion. So kerosene is not very efficient. RP1, so Kerolox engine, like Merlin 1D, it's not very efficient. because you're shooting a lot of unburnt fuel at the bottom. Same with the Saturn V first stage engine. It's the same exact idea, right? Wouldn't O2 rich ablate the nozzle away? How do you cool it? Well, Orion, you're trying to get the oxygen to turn to gas. So what the Soviet Union came up with, right, is taking the liquid oxygen and putting that through the nozzle first. And then they take that gaseous oxygen and they put it into a pre-burner again, right?
Quick update on the cryogenic.
And then they combine it with the kerosene
here.
and shoot it out the bottom.
At
The engine runs
9:39
extremely
B, you
freaking
see
hot.
the
But they
lower
regeneratively cool it with
of
the,
the Space
well, not
Launch
regeneratively,
System
they cool it with
rocket.
the oxidizer.
And venting of liquid oxygen that is condensing into water vapor. A little bit of a cloud coming up there, all part of normal operations. We are currently 32% filled on the liquid oxygen tank inside the core stage. And we are currently still
Kumo, I'll get to that in a
getting
moment.
the sensors covered on the liquid hydrogen side. There was a brief pause as we've been in slow fill for
John.
a period of time. Liquid hydrogen slow fill started at 9:09 a.m.
Not interested, LJ.
So we've been going for 45 minutes now with slow fill, but this is part of the new operation where they're taking it very slow with the liquid hydrogen, allowing the lines to get very slowly chilled, and then slow fill has gone a little slower than usual into the tank. There was a temperature sensor on the inlet side of the liquid hydrogen tank that was off in its reading, and it is the sensor that triggers to fast fill. So the team identified that. They are going to use a backup sensor or another sensor rather, to verify that they're at the right temperature and that they can go ahead and continue with fast fill. Again, that temperature sensor was a trigger for fast fill, so fast fill was held off a little bit for the liquid hydrogen side until they were able to troubleshoot the temperature sensor on the inlet of the bottom of the rocket.
I hope so, right?
That has been taken care of, and so we expect in the next 10 minutes to get into fast fill on the hydrogen side. And again, that'll be a test of the repairs that were made. The repairs to the liquid hydrogen side, you may recall, after a launch attempt on September 3rd.
They flowed too fast, Keyboard, I'm pretty sure. They won't, they haven't said it.
The line was demated
photobomb.
From the rocket. They pulled off a seal that had indentation on it, repaired that seal, and reattached
it seems like they tried to flow a little bit too fast, and they pinched the seal.
Good test of that
8-inch race, 19 months.
fuel line that goes into the rocket from the mobile launch tower. This is Artemis Launch Control.
Okay, John, you wanted to see the TSMU or the TSM shot? It's right there. See? Camera looking up at the tail service mast umbilicals. The problem where they were having leaks was over here. It's on this side. So these guys, what you're looking at is the fuel lines. Those are the fuel lines going into the vehicle. Liquid oxygen over here, liquid hydrogen over here. That's the hydrogen. See that pipe right there? The top pipe. That's the fuel line. And then it's an 8-inch fuel line that goes in here, and then there's a 4-inch vent line that goes below it. Yep. This is a full tanking test. It's not a partial fill. Twilight effect on the Soyuz was amazing. Yeah, guys, I'm more interested in this right now. Don't get me wrong. I'm not trying to be a jerk with the Soyuz launch. I really, this is really important. I know, I have faith in Soyuz. It's a good launch vehicle. I know it's going to work. Because it's a Soyuz. It always works. It's a freaking monster of a vehicle. But I'm really interested in this right now. It goes good, Brandy, yeah. Parametry constructor rocket nositel no normalno. Yes, normalno. Birds. Nice bird. How many tank cycles do they have left on this booster? There's 22 total, Dread, and they're at like 12 or 13. It's fine. I'm glad the Soyuz launch was good, fellas. Yeah, that launched 2 cosmonauts and a American astronaut to the ISS, the MS-22 mission. Parametric construct a rocket inertial normal. Except MS-10. Yeah, we don't talk about that, Shinar, okay? We don't talk about that one. They're getting loads of tanking data at least. Yep. What if the engines ignite because of a failure? Train, I'm not going to sit here and pretend like if the engines ignite before they want them to, that good things are going to happen. What I will tell you is that there's a lot of safety systems in place to make sure that that doesn't happen. What NASA has here is basically a computer. There's a computer program that's controlling the sequence of events, right? All the way up until launch, and then right before it launches, it hands it over to another computer, and that handles the launch. The first computer is the ground computers. Okay, so
good morning. It's 10 a.m. Eastern time here at the Kennedy.
That computer is called a ground launch sequencer, and then the ground launch sequencer's final thing is to tell the auto sequencer, which is the flight computer on SLS, right, to start doing its thing. Because once the rocket detaches from the ground launch sequencer isn't good. It isn't going to do anything. It's on the ground when the rocket's flying, right? So, long story short, there's a computer that's controlling this sequence of events to make sure that the rocket engines don't, light early. Now, don't get me wrong, that has happened before. Not with this rocket, though, but it has happened.
Hydrogen. It's currently in slow fill.
Vasia, yes, normalno. I think
Standby
right.
Launch team is discussing.
Why does the side of the rocket look like Tetris?
NASA test director.
Those are probably covers and access panels, Panic, if I had to guess. I'm not exactly sure why it looks like the Death Star trench run up in there, but I'm pretty sure there's a good reason for it. Temp sensor failure, they're switching to a backup sensor. Yep.
And to continue, there's just some housekeeping matters they were going over. You're looking now at a shot right up against the umbilical, the tail service mast umbilical, which is the area that was repaired after the launch attempt on September 3rd.
Not yet, Alex. I mean, it's always leaking, but it's the rate of leak that's what they're wondering about.
We are in stop flow.
Uh-oh. They stopped. The turrets, they've stopped. Cut the chatter, Red 3.
We are in stop flow on the liquid hydrogen side. Stand by for more information.
It's just, Kumo, that's just gaseous oxygen. That's fine. Yeah, not ideal. Not ideal. That's not firing room 1. Yep. Astronaut to ground control. Pull my finger, please. Cowboy, I'm not going to sit here and say like you would want gases in places that aren't. You don't really want explosive gases in places on a spacecraft where they shouldn't be. Right? They're worried about hydrogen leaks here. Pulling your finger could cause an unregulated flammable gas leak. You don't want that. Hopefully the astronauts didn't eat Taco Bell. That would really suck. And remember, you're in a tin can. I mean, don't get me wrong, there's nobody aboard this, but you're in a tin can. Hopefully the HVAC system in there is good. Methane leak in an oxygen-rich environment. Yeah, that's why they have spacesuits, Hal. Yeah. So that's why they have spacesuits.
Discovery, go at throttle up.
If you snail trail it into the spacecraft, the only one that's going to suffer is you. You got to seal. You got to put the helmet on. You got to put the helmet on and seal that all up when you're in the spacecraft. Am I right? The only one that's going to have a bad day is you. Oh, God, no, get this off. Get out. Nope, you're stuck in there. Have fun with that. There's a reason they didn't do refined breeds and tacos in space, but yeah, I don't think anybody wants that, CIA. Well, everyone loves their own brand, don't they? Yeah, no. They did stop Phil on the hydrogen. How's Soyuz doing, fellas? Soyuz getting there? Soyuz made it? Of course it made it. It's freaking Soyuz. Oh, rain. You see that? You see that fog that's over there? That ain't fog. That's rain. It's raining at 39A, but not 39B, which is funny. In Florida, it downpours so much that it looks like fog rolling in.
Okay, quick update. I'm listening to the team discuss, but they did have a detection of a hydrogen leak in the tail service mast umbilical. It's in the lower portion of the rocket. They had a 7% reading of hydrogen in a cavity there where that quick disconnect line is.
7%? That's worse than the other time.
You're looking now at the area. As soon as stop flow happened, the leak rate immediately came down.
Roll her back. No, please. Shh. Don't say anything. Chat. Just shh. Don't freak it up. Don't freak it up. Shh. They'll figure it out.
The launch team is discussing possibly doing their warm-up procedure, but we'll have to see where they go. Evaluating and discussing. We'll keep you updated. This is Artemis Launch Control.
Excellent. Netco. Spasiba. It's the same leak sensor, Havocs. I mean, guys, once again, it's going to have problems. It's up to you to sort those problems and figure it out. You don't want to put the vehicle into an unsafe configuration and then launch it. Now, one, this is a test mission. It's not going to give you good data for when you actually go to put people on this. Second part about that is that once you get into operational missions, you shouldn't see any surprises, right? Don't get me wrong, stuff does happen. Apollo 13, that was technically a QA issue if you really want to know. But you shouldn't get surprises like that after operational missions. If you're encountering stuff like this during operational missions, figure out what's going on and fix it. Because if you don't, and you launch it out of impatience, bad stuff happens. It's possible, Vickers. I don't have enough information to really tell you what it is. Blackness, 37 months, and Joe with a 9-month resub. I really hope they get this figured out. They will, dude. Don't worry. You just got to be patient. They'll figure it out. The incessant need to launch the vehicle because you're impatient is called go fever. And that's something that was observed on January 28th, 1986. And yeah, it didn't end well. Yeah, Cowboy, I wouldn't say this was built by the lowest bidder, if you catch my drift. Yeah, Kigster, it's not just that. Challenger wasn't just about the O-rings, dude. That had a lot to do with it, but it wasn't just about that. Yeah, turns out that space shuttles aren't very aerodynamic, and when it's too windy to launch them, it can crack failed O-rings even more. Yeah, that's what happened. Good times. No, there's a bunch of different bidders, Sebi, but yeah. Yeah, 7% leak is a behavior that they didn't see previously. Yeah, Kickster, it is, but, we learn from those mistakes, and that's why NASA's going slow. Go slow, take your time, get it right. They, of all people, know. Guys, you got to be patient with this stuff. I'm sorry. I know I'm not sorry, to be honest with you. In this day and age, if you don't get instant gratification, everybody gets annoyed. Well, honestly, when there's lives at stake, I don't care about your instant gratification. That's why I'm not sorry. It's going to take time to get this right. And anybody that gets impatient can go watch Netflix or something. Spaceflight is not about instant gratification. It never has been, it never will be. You have to take your time, and it has to be right. Long Eye, what's up, man? 2 questions. Seems like it takes us a day or so to launch and dock with the space station, but Russia does it in 3 hours. Why? And then SpaceX dumps a big battery pack into the ocean. Not good for the ocean, right? Dumps a big battery pack into the ocean. I'm not sure what that means. I don't know what you're referring to, Long Eye. The reason why Russia can do a fast transfer to the ISS is because Soyuz is a very well understood vehicle. There's also orbital mechanics that do need to figure into that. But Soyuz is a very well understood vehicle. It's a very mature design. If you build, think about this. Say in my garage, I build a car, right? I build a car, and I want to drive the car to the supermarket. So I take a kit car, I put it together, right? We drive it to the supermarket. Are you going to be worried about it? Like, say, for instance, that when we drive it to the supermarket, I'm a speed demon and I break the law. You go fast, right? You wouldn't want to do that on your first try with a car that you just built. What if you didn't screw a bolt in all the way? You're more cognizant of it might fail, right? What if a tire comes off? I've had that happen. That's not fun.
Welcome back to coverage of the.
But if you do it 20 or 30 times, then you're more confident in the design.
Timeline here.
Same idea with Soyuz. Soyuz is driving us to the supermarket,
those who are watching,
so to speak.
NASA's public channel.
But it's done that a lot, so they can do it faster. Dragon will eventually be able to do that once it gets matured enough, once they're more confident in the design.
Of the Space Launch System rocket, which you see on your screen there. We started prop load at 7:30 a.m. this morning.
By the way.
Flowing liquid oxygen and liquid hydrogen. But at 5 minutes past 10 a.m. this morning Eastern time,
no, Funky.
we
Not
went
at
into
all.
stop flow on the liquid
Good
hydrogen
questions, though,
side. The area you're looking at
SpaceX doesn't do that. Rocket Lab does that.
That is the gray protrusion.
Rocket Lab has the hot swap battery, and you don't need to worry about dumping into the ocean. It burns up before it even gets near the ground. Got to remember, it's going about 15,000 miles an hour, 14,000, 15,000 miles an hour. When they dump the battery, it'll burn up. Yeah, it burns up before it ever gets near the ground.
Gaseous commodities to operate valves, as well as fluid lines for hydraulic maneuvers. This shot here, you're looking exactly at the location where just minutes ago the liquid hydrogen team detected a leak.
Yeah, Boone, right? It's just like people say, oh, they're venting gases. What is that? That's oxygen. It's gaseous oxygen. I don't think anybody's going to scoff at, venting gaseous oxygen into the atmosphere. I don't think people would make a big deal out of that, right?
Just listening to the launch team.
Don't drive a car you just bought across the country.
Hydrogen team
yeah,
reporting to the NASA
that's right, Orion. That's a great case scenario, right? Yeah, just you don't want to be up here lighting one up. That
has the same signature as the previous.
Probably not a good idea.
They caused a launch scrub on September.
Oxygen itself doesn't explode, but gaseous oxygen makes things explode really, really nicely.
Percentage hydrogen that was detected was 7%, according to the hydrogen team. And so now they have just gotten signed off a plan from the launch director, a pre-plan, in the case of a leak like this, which is one that they did. You may be familiar with as you followed our launch coverage.
Also that.
Of the first launch attempt. This is a similar pattern, plan that was used to warm up the line that goes into the rocket and fills it with hydrogen.
Truck was understood by the time you got home. That's right.
Now at the
it's literally that, dude. Got to figure out what you made.
And in the center of that room is the cryogenic propulsion team, and they are the ones that are working this current plan. They're going to let the line warm up. They've allowed it to stop flow. They're going to allow it to warm up a little bit, and then in the hopes that when they start flow again, it will reseat the connection in hopes of curing the leak. If we could take a look at that that area in the lower portion of the rocket where they are working that.
No one's
There's
on this
8-inch
one,
fill
Cowboy.
line. This is the
they're not playing Candy Crush. That guy may have been playing Galaga,
into
though.
the bottom of the rocket.
That man is playing Galaga.
Tail service mast umbilical on the left into the rocket.
You understood that reference. Meta.
And at that point where they connect, that is the umbilical disconnect point. Once the rocket lifts off the pad, the fuel lines must disconnect at that moment. Once the boosters light, that is when the umbilicals disconnect. And in that point where they are connected, there is a flight plate on the rocket side and a ground plate on the ground side where they disconnect. And it is in that area, we've got a shot of it. It is in that area right there. That's the connection point.
That's the flight
plate. The vapor
plate.
you see is liquid oxygen. It's actually not indicative of the liquid hydrogen leak. That leak is actually contained in between the plates there.
See that? That's the flight plate.
The
flight plate is on the part that flies.
The entire square plate, but you can see part of it.
And then the ground umbilical carrier plate is right there. See it?
The lines connect into the rocket and fill the tank
with all the dots on
liquid hydrogen. That's where they saw a 7% hydrogen
yield gup
leak.
Well, that's a tail service mast umbilical
so it
carrier
automatically
plate.
Went into
the ground
stop
umbilical
flow.
Carrier plate is up there, about 200 feet that way.
Configuration is safe. And now they are allowing that
nice
line
cooking.
right there to warm up a bit for about a half hour, and then they're going to reinitialize the flowing of propellant
now,
back into the rocket.
CIA Cowboy, you're saying you're an original Nintendo guy. Duck Hunt or Donkey Kong?
Again, launch director Charlie Blackwell Thompson signed off on the plan to warm up the line. We're currently in stop flow on liquid hydrogen, and they are slowing the fill.
I don't know much about rockets. I fly in real life and fly in the simulator, but rockets I don't know about. Oh, bro, Duck Hunt, hands down. Good man. Good man. I also would have accepted both of them. Yeah, why not both? Yeah, that's also a good answer. But yeah. Such a good game, man. I wonder if they could put a bucket under the plate. So, see, the thing about rockets, the thing with the rocket is, you know, like, okay, so if you fly in real life, right? You have to be prepared for whatever throws it at. You know how you like prepare for an engine failure, right? Like you know, bird. If there's a CFI, if you're CFI, you're trying to get hours, and your CFI, you know, goes and shuts the fuel line off. You know, what do? You don't panic. Try to figure out what's going on. Altitude is your friend, etc., right? Like I know a little bit myself. I don't fly in real life, but I played a ton of Flight Simulator, and the mentality is the same. That's what I'm getting at. The mentality is the same. Take like you know, like another scenario, like the ultimate nightmare scenario, like what Sully did. So the Miracle on the Hudson, right? Double bird strike, post V2 on initial ascent. You're like, that's like nightmare scenario. There's not much you can do, right? But you got to stay calm. You got to figure out what's going on, work the problem, and go. Rocket, that's very much like rockets. Rockets are very much the same kind of methodical mentality. It's very similar. So like now, they have that hydrogen leak. They got to figure out why it's doing that. So what they're going to do is try to do it again. That's basically what they're going to try. They're going to try to do it again. Is this repeatable? Just like if you're in a plane and you lose both engines for whatever reason, like if you have a compressor stall on both engines, hopefully not a bird strike, right? What's the first thing that you do? You got to try to get power. Got to try to get power so your hydraulics work, right? So APU, right? That's you want to start the APU, and if so you can get power to control the hydraulics in an attempt to try and restart the engines, right? It's the same kind of mentality. You know, and if the APU doesn't work, you're not going to sit there and be like, oh, all right, it didn't work that time. Okay, cool, let's try something else. No, you try it again, just to make sure that it's a repeatable thing. And you got to do that before the plane crashes. That's what makes like what happened with Sully so ridiculous. But it's the same mentality, dude. Same exact mentality. So like the point is like if you know how to fly an airplane, you can understand what they're doing here and why they're doing it. It's the same exact thing. So what NASA's going to try to do here is literally they're just going to try to flow it again. Try it again. Make sure that the leak is verifiable, right? You're not going to flow it the first time and it leaks and just be like, all right, it's leaking, boys. All right, see you next year. Bye. I'll see you later. No. That's not how this works at all. This is a test flight. Now is the time to figure this out, why it's doing that. Now, I'll be honest with you. If they try it again and it works, that's probably that's probably going to be a little concerning. I wouldn't that probably I don't know what it would do. What did you do different? What's different this time around on your second attempt? They want to make sure that their second attempt here is emulating the first attempt pretty much exactly. Because if it's not, and the thing actually works, well, now you got to go figure out why the thing worked. Why not simply put a guy inside of the tank to look at it from there? A camera could do that. Slipped, and they probably have cameras that do that. You know, the camera will do better than a person, I think. Also, explosions. Yeah. Might be a stupid question, but this rocket, is this so far one of its kind? This is the first one, dude. They have 3 more in the pipe. This is the Artemis 1 mission. They have Artemis 2, 3, and 4 in the pipe. The parts are being made right now. In fact, you can go, if you want to see, images.nasa.gov, and you just type in SLS. You could probably find some pictures of the rocket being made. Actually, a better thing would be
Discovery, go at throttle up.
SLS Michoud. It's being built in Louisiana. And you can literally see new parts as they roll off the assembly line. Now that's what's called an STA. That's from a couple of years ago. So that's not exactly it. But here, check this out. So there's the main propulsion section. That's actually the MPS that we're looking at. That's that thing. But if you go and you look, where was it? Go and you look here. Let's try this one. Core stage 2. Oh, there you go. Core stage 2. That's from 2019. Tries to me. 11-month resub. Core stage 2 is actually pretty much fully assembled with the exception of, here, we'll just try CS2. See if that gives us anything. Except for the engine section. It's pretty much built. And you can see pictures of it in the factory. NASA publishes all these pictures. They have to be transparent. That's part of, by law, that they have to tell us what's going on. At least with this thing. There's a picture of them manufacturing it. NASA down in Michoud, down in Louisiana, has this. Oh, no, not that one. There was a sub in there from Tresemme? Yeah, Tresemme. That was the only one. That thing right there is the vertical friction stir welder. Basically, they stack the tank here, and then they have a welder that goes around and welds all these seams. Now, the welder isn't exactly what you think it is. It's not like... They use a stir welder. Basically, they have a piece of metal that looks like a drill, but it's flat, and then it just spins up against the seam. And what it does is it's pushing on it, and that it actually melts the 2 pieces of aluminum together. It's a stir weld. It basically melts and spins them together. And basically... Now, why would you stir weld it? You can see that see the scuff marks right around the seams from all the aluminum panels, right? Why would you do that? Well, this type of welding, using friction and stirring the metal together, that type of welding keeps a uniform molecular structure between the plate, the stir weld, and another plate. It keeps it nice and uniform. Now, anybody that knows a little bit about welding knows that the weld bead that you make, right, with like a MIG welder or even a TIG welder, the weld is stronger than the metal around it molecularly. Like the way that the weld gets arced, right, and you arc flux, you're basically shooting flux like metal onto other metal, and it uses an electrical short to basically liquefy the metal for a second, right, and it melts the metal together. The weld is usually stronger than the metal around it from a molecular standpoint. With a stir weld, you get a uniform structure. So if you have a pressure vessel, for instance, something that's designed to hold stuff in, having a uniform structure around the entire cylinder makes it so, you know, you can pressurize it. You can pressurize it better. You don't need to worry about leaks. You don't need to worry about deformity in the weld. And the entire tank contraction expands uniformly. That was a really important innovation in aerospace engineering. And the shuttle is actually, the external tank was actually the first thing to implement it. Right nowadays, stir welding is industry norm. Falcon has a stir welded aluminum core. Atlas has a stir welded aluminum core. Delta has a stir welded one. Vulcan will in the future. Starship, I don't think is stir welded. I think it's tip welded and TIG welded because you can't stir weld stainless. Stainless doesn't like stir welding very well. Aluminum, though, very good. Same principle for subs then, I guess. I don't think they would stir weld the submarine packs, but it's not the same. It's an inverse. Submarines are trying to keep out pressure, so you have low pressure inside, high pressure outside. Rockets have high pressure inside, low pressure outside. So I'm not sure if that favors a different welding technique. I don't know enough about submarines. Aluminum stir fry. Yep, get the wok out with the aluminum flakes and am I right? They just paint subs with Flex Seal, obviously. Duh. Wait, does that mean they sawed the submarine in half? I don't think that's good for it. Yeah, Jason, it's fine. 22 times is how much this core stage can be filled and drained. They're not even close to that. They're at like 13 or 14. They're easily 10 more times. Aluminum stir fry, now with extra magnesium. Yeah, Teflon, and it's funny that we're talking about that because what aluminum stir fry is basically what's in there. Yeah, but instead of soy sauce, it's hydroxyl terminated polybutadiene. And instead of broccoli and chicken, it's ammonium perchlorate. But the aluminum flakes, yeah. Oh, yeah. It's aluminum stir fry in there. I'm serious. You think I'm kidding? Here. You think I'm kidding? I'm not. That's what's in there. It's basically an aluminum epoxy stir fry thingamajigger. See? There it is. They mix up the propellant and they don't stir fry it. They don't pan sear the freaking SRB fuel. Yeah, that probably won't end well. They cast it like concrete. I call it forbidden Play-Doh. But it's hydroxyl terminated polybutadiene, ammonium perchlorate with an aluminum flake stabilizer. Yeah, the SRBs partially burn aluminum for more uniform combustion. True story. Aluminum is great fuel. Oh yeah, great solid fuel. You got to get it hot enough though. But if you can get it hot enough, great solid fuel. You ever notice if like a plane does a belly landing on a runway and the plane, skids to a stop, right? Everybody gets off and then the plane catches on fire. And then after the fire, there's no plane. There's just a scorch mark on the ground. It's because aluminum's great solid fuel. True story. Yeah. Yeah, I know. It's weird to think about that way, but it is. It's great solid fuel. So is magnesium. I mean, if you ever in high school science class, you would know that. Magnesium is a great solid fuel. That's right, Wombat. Yeah. 25-year shelf life. Yeah. Why is that, though? Yeah, Havix, that sounds right. Yeah. Yeah, Boone. Yeah, you're not wrong. I live right by a huge aluminum factory. I've heard many stories of containers of aluminum shavings exploding. Oh, it's very flammable. Yeah, you wouldn't think metal is flammable, but aluminum's very flammable, especially in flake form. Because if you have like a solid block of aluminum, it's not very flammable. It doesn't, you don't, there's not a lot of surface area for any heat to start burning things, right? You know, you hit an aluminum block with a blowtorch, it's not gonna, I mean, if you do it long enough, it'll eventually just catch on fire and burn, right? But if you just hit an aluminum block with a blowtorch, it's not going to do anything. It'll just heat it up, right? It'll just get really hot to the point where you can't hold it. It's like having a campfire. Anybody know anything about making a campfire? What happens when you make a campfire? What do? You got to chop the wood up. You really want to chop the wood up, and you have to kindle it. You put kindling in there. Why do you do that? You're exposing more surface area of, like, if you chop up the wood and you make mulch and you put kindling underneath the logs, right? That's how you do this. You're exposing more of the combustible wood to flame. More surface area is being exposed to heat, so it burns a lot faster, and that can get your campfire started. Just like a blowtorch isn't going to heat up that aluminum block, but if you introduce a lot of heat to that aluminum really, really fast, then it'll catch on fire. Like if an airplane crashes or something, hopefully nobody gets hurt, right? It's just like starting a campfire. Aluminum flakes, same thing. Same thing. Aluminum flakes are basically kindling. They'll, you know, that's why you got to be careful with that stuff. Aluminum metal shavings are very flammable. Absolutely. Yeah, steel wool. Steel wool is the same way. Yeah, metal is flammable. Yeah, you don't really think that way, right? You think like, oh, metal isn't flammable. It's metal. It can absorb heat. No, it's flammable. Just got to do it right. Don't try that at home, please. Look, NASA doesn't even do that. And when they do that, he said doo-doo. When they do that, it's in a very controlled manner. Don't do that at home. Activated charcoal, same system, loads of surface area. It's about how much, that's exactly knowledge. It's about how much surface area you can expose to heat. That's why on a car, a bigger radiator, for instance, will keep the car cool. And what the radiator is made out of. Ironically, it's made out of aluminum nowadays. Fire doo-doo. Fire do be like that. That's what I'm trying to tell you. Don't launch SLS at home. Got it. Yes. Yeah. That's what I'm saying. Yep. Any update on why it's leaking? I have the audio unmuted and I hadn't heard anything, which means that they're trying to cool down heat up the hydrogen line, and then they're going to slow cool it again to see if this is repeatable. They had a 7% leak rate on the first attempt, which is not good. It needs to be below 4%. They had almost double that. Just got here. How was your weekend? It was great, Zane. How about you? Warship hulls are mostly aluminum-based these days, so stir welding is usual. Submarines, though, are made of steel and welded with TIG. Yeah. Good to know. Ugh. Christian, I'm disgusted. I just want to let you know. I just want to let you know, Switch, that I'm judging you. This is my judging face. See that? If it's not leaking, then it's empty. Yeah. Now, Boone, you speak helicopter. Yeah. Yep. You want to know a good way to be sure that a helicopter still has oil in it? If it's leaking. If it's not leaking, then it has no oil in it. Don't use it. True story. It's gaseous oxygen moving, and yes, that's expected. Mm-hmm. Any aircraft. Yeah, even old cars, Elias. I found with my project cars, like with my 59 in the garage. Yeah, if it's not leaking, that means there's no oil in it. All right. Look at these peasants in your command center background. They have old Herman Miller Aeron versions. The newer ones, the lumbar support is different. Damn peasants. I think I got the only Volkswagen Golf 2.0 turbo that doesn't leak. Yeah, that's probably going to break soon. They are not Harley Davidson rockets. You go to buy a Harley and there's no oil stain under it. You walk away, it doesn't run. You know what's messed up? Cowboy, you know what's messed up? We're talking about this, but that, dude, honestly, if this thing isn't leaking hydrogen, then you're probably not flowing hydrogen. Hydrogen will always leak. It always leaks because it's so damn small. It'll just go right past a seal or an O-ring. But honestly, if SLS isn't leaking something, then there's probably no fuel in it. It still holds true, even for this multi-billion-dollar rocket. I mean, it's true. That's not wrong. Yeah, Sebi, that's gross. Why would you replace a... Yeah, no. Yeah, Sebi, I agree with you. No, I want Mick, please. Given your bout of Instavia, did you see the DeBoss vid on that solid axle swap? I did, Ernhawk. I actually did watch it while I was working on some other thing. Uh-huh. Helium and hydrogen leak out of everything. Yeah, bingo. Oh, it's such a pain in the butt, dude. It's like trying to water your lawn when your garden hose has a freaking hole in it. It's like, yeah, okay, that's not really going to work. The sprinkler ain't working right. The salami lid ain't gonna fit. Could you charge the hydrogen and use magnets to prevent the leak? Kappa. Okay, there's a kappa after that, Bright. I had to catch the kappa. Because, no, I wouldn't do that. Good pointers in that vid. But he was swapping an axle Ernok that looked like it was from a 79 Bronco. If I looked at that correctly with those trailing arms. I don't know if that will work with my truck. I don't think it will. I mean, it might. I don't know. Helium leaks suck because then the guys sorting out the issue are laughing too hard at how everyone sounds. How everyone sounds like this? Yeah, it's really freaking annoying. But mildly funny. Is there a theoretical way to contain hydrogen? Would the container need to be made out of hydrogen, or would it need to be multiple layers? I mean, nuclear, the only thing that you could really do it with is like solid hydrogen or solid helium to create like a super, like, foolproof leak. The problem is trying to make solid hydrogen or solid helium is kind of at odds with this whole, you know, inside the atmosphere or sea level thing going on. That whole atmosphere thing. I mean, we could do it, but I mean, a rubber seal that seats correctly could probably also do that, and it's probably simpler. Yeah, it's probably simpler. I thought that it was the seals on the SRBs that were the problem, traditionally. No, A4. No. They're using even this, they're using a triple O-ring design on the SRBs. Yeah, well documented that one actually seals correctly. Yeah. Sulfur hexafluoride as a voice changer. Everyone loves the evil doom sounding noises from chipmunks. Yeah, that'll do it. Apart from the once. Yeah, that's why they redesigned the SRBs after that. A4, would you like to know more? Bird. Have these guys ever heard of Flex Seal? Yeah, the problem is that hydrogen will just freeze the Flex Seal right off. B1RD, did you see it fly around? Yep. Are these rockets at the limit of pressure that modern materials can handle in the nozzle? Could you have a higher pressure, super small rocket nozzle that lifts a big rocket like that? I mean, what you're describing is something like Raptor, Slow Chief. Yeah, you can. Yes, you can. A lot of smaller engines working in tandem can give you better performance. It's possible. But that's more moving parts. It's a trade-off, man. It always is. Yeah, it'd be cool if the mouse actually decided to go to the other monitor instead of just, you know, nice W. Instead of just, you know, doing the. I mean, A4, if you want to know more about how the O-rings work and why they redesigned the O-rings, I could tell you about that, but yeah, I would really prefer to listen. Dang it, is it still leaking? Yep. But Manazi, don't get too distraught. They'll figure it out. They might even figure it out today. Who knows? We're waiting on an update. Yeah, Ernak, I watched that video too. Love that my mouse hangs at the edge of the screen. I have a 4-monitor set up for flight sim. Yep. Why is it quite well documented? Well, okay. All right. A little bit on SRB O-rings here. So this always comes up every time we talk about any shuttle-derived launch vehicle, which is fine. That's okay. So this is the O-ring design that did not work. Okay. So they're using, basically it's a clevis with a pin, okay? So what is a clevis? What is a clevis? See the thing that does this? The SRBs are held together by a clevis. Inside of that clevis, there's a pin that goes through that holds the two segments together, right?
10:40 a.m. Eastern Time.
And then you have the double O-rings right there.
Florida.
Hang on.
At a live image of Launch Complex 39B, where the Artemis rocket is currently on the pad undergoing a cryogenic demonstration test. We had a stop flow on the liquid hydrogen side at 10:05 a.m. I want to update you on what's been happening there. We are currently in the midst of a troubleshooting effort by cryogenic engineers to try and cure a leak that was detected. We had a stop flow in one of the two super chilled propellants that the launch team is testing in their loading operation today.
No,
this
that's
is the liquid hydrogen side. It showed the same signature as a previous leak. It happened at the same moment that the super chilled liquid hydrogen was transitioning from slow fill to fast through those very lines that you're seeing on your screen now. That is coming from the tail service mast umbilical going into the rocket. There are plates on both sides. In between those plates are the connection point. They disconnect at T0 to allow the rocket to lift off and go into space. That's also where they fill the propellant. So in the cavity between those lines, they have leak detectors to make sure that the seal is tight and that when that minus 423 Fahrenheit hydrogen is going through there, as long as no hydrogen is leaking, they're safe to continue fueling the rocket. While a leak was detected, mass spectrometers contained inside that cavity reported a 7% concentration of hydrogen.
Words, I swear.
And again, right at the moment that they transitioned from slow fill to fast fill.
Yeah, Halo. It looks like
which is very similar to what happened during the second launch attempt on September 3rd. Currently, the team is working a plan to troubleshoot. As we stand in terms of the propellants on board the rocket, we've got roughly 58% filled on the liquid oxygen side. They have slowed their pumps a bit.
It's possible, Nubits.
Given the situation on the liquid hydrogen side. Hydrogen is in stop flow, so they are sitting at 6%. But that propellant that is in the tank is boiling, and it will slowly deplete down, which the launch team is keeping a close eye on.
It slipped. I think that's what they're going to try to do. I would, if it was me, don't get me wrong, I'm an armchair rocket scientist. I would try to do the same thing again, just to see what happens.
Allow that line that goes into the rocket to warm up. They've purged the line with helium. This allows the quick disconnect, as it's called, that connects into that plate there to warm up. They warm it up for about a half hour.
Yeah,
and then they're going to resume flow.
Yep.
Back in.
Guys, I'm going to take a leak real quick. I'll be right back. You know, like the hydrogen leak, it's controlled. Just saying.
We're inside Fire Room 1 here at the Kennedy Space Center, Launch Control Center.
No, put your hand up again. I'll shake your hand, man, I swear.
The hope is that the warm-up of that line will allow it to reseat in that seal. And if there's been a gap that was created, that it will tighten up and reseal that quick disconnect to the 8-inch fuel line for the liquid hydrogen, hoping that that will cure the leak. The liquid oxygen team has advised the NASA test director that if the liquid hydrogen goes below 2%, they will need to stop flow so that they don't violate what's called an aft strut constraint. The aft strut is what connects the two solid rocket boosters there on the side to the core stage. As the core stage is filled with super chilled propellants, it moves, the metal shrinks ever so slightly, but enough to put strain, so they want the propellants filled in proportion to each other. And that proportion is over 50%, 50% on the liquid oxygen side after they reach 5% on the liquid hydrogen side. And so you can see we've met that aft strut constraint at the moment, but the liquid oxygen team is advising that if it that 6% starts going down and reaches 2%, they're going to have to stop their pumps as well. Again, troubleshooting for the liquid hydrogen line after a leak was detected just about 40 minutes ago. They're warming up the line. And any minute now, we're going to resume flow back into the core stage, see if they can reseat the connection to the rocket. This is Artemis Launch Control.
Leak rates on the waste drain procedure were nominal. Oh, Marcus is a great chair. Best chair I've ever owned, dude. Manual or auto flow resume? You on the rocket or? Open cycle. Yeah, open cycle. That's an open loop system. Okay, I'm changing the subject. Anyway. Yep. NASA is currently conducting a tanking test of the SLS of the Space Launch System rocket here for the Artemis 1 mission, and basically they're trying to ensure that they can flow fuel into the rocket correctly. And the first attempt was not good. It leaked too much hydrogen. Now, don't get me wrong, it's supposed to leak a little bit. Hydrogen, that's just a byproduct. It's just a byproduct of what happens. It's like if you pull a cold snack out of the fridge. It's always, on a hot day, it's always going to condense a little bit. It's always going to leak. That's not leaking. That's cooling down the ambient moisture in the atmosphere. But it'll always condense. The point that I'm trying to get at is that they're not dealing with a condensation problem here. Hydrogen will leak because of physics. Just like it's always going to condense if you take a cold can of soda out of the fridge on a warm day. It's always going to do that. NASA's dealing with a physics problem here. They got to figure out the right way to try and fill this thing without leaking too much. That makes sense? Tanking versus fueling. Interchangeable, Brent. Interchangeable. They mean the same thing. Negative. I am a meat popsicle. Chat! Dallas! You're the annual winner of the Gemini Croquet Contest! Quiver, ladies, quiver. This chat's gonna set the world on fire. Yesterday's frog is tomorrow's Prince of Lost in Paradise! Love that movie. Thought I'd let you know. I don't know if you could tell. Hey, Liam, what's going on? How are the tests going? They tried to slow fill J-Speed on the first try and it leaked. Multipass. Yeah. What the heck, Grab? Why do they not test the fueling and engines at the same time? They could have caught this problem earlier. Nuclear, I firmly believe you should test as you fly. So whatever they did on the test stand for the green run, they really should have done here. But also, now is the time to make changes. You know, if you want to make changes to try and make things easier. So, long story short, NASA was confident that the changes would make this easier, and it doesn't seem to be the case. Nuclear, I honestly think they should... I honestly don't really understand. Like, that's not true. I understand why they changed the things. What I don't get is why... So, they did the green run, and they made all these changes to the fueling systems on the pad because of the green run, which is fine. That's okay to learn new things when you test. That's the whole point. The thing is, they implemented all these changes, and then they didn't test it again. The next time they tested it would be on the, the next time they would test it was the wet dress rehearsal. And supposedly that's enough to qualify the vehicle, but also here we are. You know what I mean? So, once again, if you're going to change systems before the beta test, now is the time to do it. But don't be surprised if those systems that you changed are going to give you a bug. But it is a beta test. Now is the time to do that. You don't want to do this with like Artemis 2 or Artemis 3 or Artemis 4. Now is the time to make it right. That's why this is taking so long. So I've been watching you a while. Seems you know everything about this. Is there something that leaves you bumfuzzled? Like, what the heck is this? How does this work? Paximus, that's a good question, dude. That literally happens on a daily basis. Yeah. Yeah, it happens on a daily basis. There's no one singular entity that knows everything about rocket science, and how you really get good at this is learning new things about rocket science all the time. So literally every day that I go to read about different applications of engineering when it comes to rocket science, I usually learn something new, and there's something that usually blows my mind so much that I have to go read about it and I have to learn. That literally happens on a daily basis. My favorite things to read about is how much rocket science, everybody considers rocket science to be this abstract concept that they can't understand. Oh, that's not rocket science. I won't understand that. Right? It's not rocket science. We throw that around a lot. My favorite things to learn and understand is that rocket science is a lot more... There's a lot of correlations to how, like, a car works, for instance, with a rocket. There's a lot of correlations there. I always say what a car does and what a rocket does is not that far off. They're just using energy to create a different type of work, right? But they both combust fuel. They both have an oxidizer and a liquid fuel. The oxidizer with a car is gas, and in some rocket engines, the oxidizer is gas, and the fuel is liquid. Oxygen-rich stage combustion cycle. It's not that far off. I mean, don't get me wrong. You couldn't put a rocket engine in a car. I mean, you could. It'd be a nice way to punch your own ticket, if you catch my drift. But my favorite things are just realizing that all of this is very practical. Rocket science, it seems like this crazy abstract concept. It's pretty practical. It's pretty straightforward stuff because they're still confining to the same laws of physics. It's not like there's a special set of physics for rockets. You know what I mean? Same thing. The leak has consistently been a single quick disconnect connector, and it starts to make me wonder if they were just lucky on the wet dress. Yeah, Prey. I'll answer that in a second. But yeah, I mean, yeah, guys, that's my favorite thing. My favorite thing to learn is like there are so many practical applications here. So, okay. All right. I'll give you an example. The tail service mast umbilicals, these two things that are on either side of your screen. These TSMs, or the tail service masts, these two vertical things, they're two big gray lobes that are at the bottom of the launch pad. They have the fuel lines for the rocket, the one that's currently leaking. This is your hydrogen line over here, there's your oxygen line over here, and then there's a bunch of other stuff that the rocket needs to make it do, okay? So these tail service mast umbilicals, you know, how do they get away from the rocket? Obviously, the TSMs are on hinges because they want to pivot away when the rocket launches. You don't want your fuel line, which you just quick disconnected and is currently depressurizing hydrogen, right? Spraying hydrogen on the vehicle and oxygen. You don't want that near the rocket when it starts to go up, right? So, you know, how do you think they get the tail service masts to pull back, to retract? How do you think they get them to pull away? It's probably some crazy hydraulic system, you know, with a hydraulic ram that pulls the thing away fast, right? No, it's literally a dumbwaiter. It's gravity. Gravity pulls it away. The tail service mast has a pivot point right here. There's a pivot point. And right, there's a pivot point and it goes back here to about here. There's a counterweight on the end of the tail service mast umbilical, right? There's a counterweight here, and then there's a pulley right here. So there's a counterweight on the pivoting TSM, and then there's a pulley right here. There's a pulley that's literally attached to a gigantic weight. And that pulley has wires that go out and they attach to the tail service mast carrier umbilical plate. You could literally see the pulley wires right there and how they're not stretched right now because the counterweight is being held up. See the lines right there? So when the rocket goes to launch, there are electronically actuated collets here that open and the quick disconnects, right? The ground carrier umbilical plate for the hydrogen, that plate right there will disconnect from the flight plate. And there is another thing right here that literally drops the counterweight. It'll drop the counterweight and it'll pull the thing back. Gravity. It's just a dumbwaiter, like an elevator, pretty much. Same idea. It's just a counterweight that pulls it back, like almost like a trebuchet. That's it. You'd think that they have some like super complicated, you know, mechanical, you know, this huge retracts, like it retracts up, and then you know it's like a transformer. No. That's much too complicated. It's literally just a counterweight, a big freaking concrete weight in here that pulls this thing back. And then the door. Yeah, there's a door that slams shut. I actually can show you. Give me one moment. You'd be surprised how simple some of this stuff is. That's my favorite thing to learn. This stuff is not as complicated as you think it is. It's very, very straightforward stuff. See? Now, those swing arm umbilicals, those are using... I'm not sure about the actuation on the swing arms, to be honest with you. That's the hydrogen GUP right there. Gaseous hydrogen umbilical plate vent line. See? See the TSMUs? You see them right there? That's exactly it. Watch. They'll go, the collets, the solenoid collets unsnap, and the slide wire, that wire pulls taut, and they drop the counterweight, and then the thing, it folds up into position really, really fast because it needs to get out of the way really, really fast because it's about to get really hot right here if the rocket was launching, right? And then there's a blast door, literally a blast door, because rocket, blast door, that is kind of circular shape that'll slam down in front of it. If you watch top right, see? Those open up and then the thing closes. Watch, you'll see it up here. You'll see the lobe come down. Crunch. Just a counterweight. It's just a counterweight. That's it. It's like a trebuchet. That's all. Doesn't need to be complicated, right? You'd think like it's some transformer thing because now no, it's just a counterweight. Counterweight. Simple. Keep it simple, man. See, the wires aren't taut right now because the weight isn't hanging there. They'll do that later. Yeah, gravity can't have a mechanical error. If that thing doesn't work, Spider, that means gravity isn't working. That's the best kind of engineering, dude. The one that basically needs physics to work. Physics needs to stop working to get it to not work. That's the best one. And rocket science is full. Rocket science is full of stuff like that. Or a broken cable. Yeah, I know. Yeah, you could have a broken cable. That's why there's 2 of them. Oh, look, that is 2 of them. Time to wake up. There's 2 cables. Double redundant. You don't know how fast that is, man. Those TSMs are not, or the TSMUs are not small. So, you know, you see this picture. Look at this. Look at the step ladder right there. You see the step ladder? See the railings? Get your bearings here with scale. And you'll be like, wow, that thing is not small. That's moving really, really fast for something that heavy. Heck, the tail service masts are 3 stories tall. Seriously, 1 story, 2 story, 3 story. Look at it compared to the railings. They're freaking huge. I've stood next, well, not stood next to one. I've seen one up close. Are those squares 1 foot by 1 foot? No. 4 by 6. 4 feet by 6 feet, which is, I don't know. It's like 1.5 meters by 2 meters, basically. Those plates are huge. I meant the white and black ones on the tail service mast. I don't know. I don't know. Yeah, it looks like it. It looks like the checkerboard squares are 1 foot by 1 foot. Thanks for the seriously in-depth answer. Oh yeah, Pax. Well, that's a complicated question. I tried to answer the question in the simplest way. I try to do that with my responses. I try not to make them too overcomplicated, but sometimes you have to. Sometimes that was the simplest way to explain it, dude. Yeah, I get dumbfounded by stuff constantly. Like the fact that, and that dude, it's like a circular cycle. So I want to learn something about rockets because I'm interested, right? I go and read about it. My mind gets blown by how cool it actually is, and that makes me, you know, I eventually find a concept that I don't understand, and that makes me interested. You know, I found a concept that I don't understand, and that makes me interested in rockets again. And it's just rinse and repeat. I've been repeating this cycle for like a decade. Yeah. What happened to me? Yeah, dude, it's so ridiculously complicated. You're going to learn new stuff every freaking day. Yeah, unbelievable. It's unbelievable how complicated this is. But at the same time, it's not. At the same time, it's so simple. But it's not. It's really complicated, but it's also not complicated. But it is complicated, but it's not. Does that make sense? That's a really long spiral down the rabbit hole. Dude, the rabbit hole for rockets with me is like the size of the Grand Canyon, Darius. No. You know what? Marianas Trench. Yeah. It's amazing how much I retain. Yeah, Animal, I'm a steel trap when it comes to that stuff. I have pretty good memory. I don't know how that happened, but genetics, I guess. Let's go with that. Can't they just hover a rocket till Earth moves away and it's in space, Kappa? You see, Spider Launcher, you're making a joke. That's literally what a nuclear warhead does. They don't launch a nuke kind of sideways like an orbital rocket. They launch it straight up. The Earth spins down and the nuke comes down. The reason why they do that, and I know it's a Kappa. I know you're kidding. I get it. But that's what a nuke does. That's what an ICBM does. It goes up. It goes straight up. Well, not straight up, almost straight up. It basically flies on a very, very high ballistic arc. And the reason why they do that is because when that warhead is coming back down, it's going as fast as possible. They use gravity to accelerate that thing as fast as humanly possible so you can't intercept it. Yeah, you can't hit it. What are you going to do? Make a missile that goes 15, 20,000 miles an hour to intercept a nuke on a ballistic arc coming back in? No, that doesn't work that way. I mean, maybe Star Wars or something, I don't know, right? But yeah, you say that, but also that's what nukes do. Yeah. First principles. Yeah, Rocket. Yeah, there you go. Oh, what a view, Forge. Yeah, nice. Yeah, the SDI, the Strategic Defense Initiative. I mean, Helios, yeah, there's certainly enough merit in that idea enough that it scared the Soviet Union to convince them that it actually existed. But then again, I wouldn't throw it past us to say, after we develop something like that, to say, oh yeah, that doesn't exist. Ah, yeah, that's impossible. We were bluffing. That sounds like us. Any good books about the workings of jet engines? You can figure, Wikipedia would be good enough if you want to just learn basics, W. How detailed do you want to go? Yeah, Pax, exactly. That's what I've come to figure out, man. The maths? Yeah, you can get the maths from... You can get it from Wikipedia. It's pretty good it's pretty good documentation. I don't know of any books particularly offhand. Rocket Guy, are you here? Do you know any books about jet propulsion? I know rocket propulsion. The rocket propulsion is, I think. The book Skunk Works is great about the development of a stealth bomber. Yeah, Quad Zero by Ben Rich. Oh, yeah. Oh, yeah. That really takes you really in depth to what they're thinking about. It's really interesting. It's super interesting stuff. I would recommend that book to anybody that wants to learn about the engineering process. And Ben Rich is a freaking genius, by the way. Personally, Quad, I like his boss. His boss is a pretty cool dude. Or was a pretty cool dude. It needs about 30 minutes for chill down, Jim. We're just kind of waiting here. I have this stream unmuted. When Daryl gives us an update, you'll hear it. JWA, I'm doing just fine. It's kind of sad how scaled back the ISS is from the original Space Station Freedom plan. Yeah. Helios, I agree. Space Station Freedom was supposed to be amazing. I've actually gone and read about the documentation for what they were going to do with Space Station Freedom with the, like propellant depot storage technologies and basically utilizing the space transportation system for what it was intended to do. It sucks. It sucks. But that's what happens when, space isn't a priority. Space should always be a priority.
7 minutes past 11 a.m. Eastern Time. This is Artemis Launch Control with an update on the hydrogen leak that was detected inside the Space Launch System core stage.
WC, what Rocket Guy said.
Recommended and the launch director approved a troubleshooting plan
had a leak again
to try and seal a leak on the liquid hydrogen side. It's located, and you're looking at your screen there. You have the tail service mast umbilical, the large gray structure coming up from the zero deck of the mobile launcher, and then to the right of it, the rocket. And those lines that go between them contain in them the liquid hydrogen line as well as the liquid oxygen line. The team has a pre-planned procedure that they go through when they reach a hydrogen leak. This is similar to the one that they did during the second launch attempt on September 3rd. They have allowed the line to warm up. They purged the line, allowed that liquid hydrogen line to warm up, and now they're going to begin flow again through there. The hope is that the warming of the line allows the seal where they believe there's a leak to kind of reseat against the quick disconnect, the 8-inch line that fills the tank with liquid hydrogen.
I agree, Funky.
But there's a slight change to this plan.
Okay, here's the important one.
That they just got approval from the launch director. A slight change to this plan. It's different from previous plans during the second launch attempt. And that is that they're going to drop the pressure on the storage tank to less than 5% PSI. They're going to drop that. That is very low pressure for this operation.
5% PSI what?
And then as they recover flow into the tank, into the cryosphere,
I can't change the laws of physics,
very
Captain.
Slowly and as kind and as gentle as they can step up the pressure for the fill of the hydrogen. So a little bit of different approach here to the warm up and recover fill that they've done previously. They were already taking great care to not thermally shock the system, going very slow with the chill down, going very slow with slow fill, and then even to the transition to fast fill where the pump speeds are running. I'm sorry, there's no pump speed, no pump on the liquid hydrogen side. Rather, they increase the pressure at a very slow rate to allow that liquid hydrogen to flow in. So that's the plan. It's been signed off on, and the liquid hydrogen team
SLS,
is putting
do you
it into
want
work
a
right now.
new
You're looking at the area
hydrogen
where that
slow
liquid
build
hydrogen
rate
flows
plan
into the
question?
rocket. And it's on the
Question?
other side of that flight plate, that square plate, where
it's the seal again,
leak was
Pascal.
detected. It was a 7% hydrogen leak detected by the sensors in there. And so from there, they're hoping
No,
that
we're
resets
not
the
talking
leak.
about
The
heat
leak
and
stopped
seat things. We're
immediately
talking
once
about
they stopped
cold.
flow.
It's not expansion into the
We're
seal. It's
standing by. We'll let you
contraction
know how the
into
flow
the channel
goes,
to seal it.
the
It's
recovery.
the opposite of that. He definitely does
Start of
go.
this launch control.
I wouldn't be surprised if he saved people from burning buildings in his spare time. Daryl's a pretty cool dude.
Discovery, go at throttle.
Guidarino. So hit it with a blowtorch. I would not hit a hydrogen line with a blowtorch, Mike. Remember, once again, hydrogen is cold. Heating it up is going to make it leak more. And then that leak Hindenburg torch. Yep. Let's not do that. Rocket Wells looks like my college trig professor. What I was actually going to say is, how do I control the rear end of the car after it snaps back following a slide and a drift? Keep on the throttle, Sirius. You gotta let off the throttle to power out to slowly ease the tires back into grip. If the tires snap, like if you let off the gas when you're coming out, right, the tires are gonna slow down and they're gonna stop and they're gonna gain grip and you're gonna spin out. Chaos, you'll like this. I've been having clutch issues where my clutch would over time move the engagement point to basically pass my firewall. Turns out my pedal box broke and I got to fix it. It broke again, so my mechanic, quote, repaired the crap out of it, welded a bunch to put it back together. Hopefully it's actually fixed now. Yeah, it sounds like metal fatigue, Chaos. That happens with clutch pedals because of how often you have to. Yeah, Funky, that's probably what's going to happen. So what they're going to do now, guys, is they're going to try to slow fill even more by dropping the pressure inside of the hydrogen fuel tank. When I say the hydrogen fuel tank here, let's look at this picture of 39B. I'm talking about this thing, that thing, the hydrogen fuel tank that's on the pad that fills the rocket with gas. This is the gas station. That's the gas tank. It's not gas. We're moving liquid hydrogen. Gas short for gasoline. It's just making a joke. The liquid hydrogen is in here, and they're going to drop the pressure. inside of this to get a slower flow rate into the vehicle. Now, once again, how do they do that with the hydrogen? There's a heater coil inside of this tank. What it does is it heats up the liquid hydrogen, and the hydrogen will somewhat expand into gas. That creates pneumatic pressure. The pneumatic pressure inside of the tank, if you open a valve down here, will push hydrogen through the line and into the rocket. The rocket is right here on the pad. It's over the flame trench, right? What they're doing is they're dropping the pressure inside of this tank. Why are they doing that? They're dropping the pressure inside of this tank to get the flow rate of hydrogen in to the launch vehicle, right? Slower. So they can hopefully seat the seal correctly and not have to worry about it leaking too much. I'm not 100% sure if that's going to work correctly. I would need to know what the tank pressure was at when the seal worked in the first launch attempt a couple of weeks ago. But yeah, hopefully this works. Doesn't this seem like a band-aid, or are they still trying to locate the issue? Rocket World, let me put it to you like this. If they were doing this during operational missions, if they were doing this during Artemis 2, I would be very, very concerned. But it's Artemis 1. This is the beta test. This is the beta test for the vehicle. You're going to have bugs. Just like any beta, this is why you do beta tests with software, for instance, right? You're going to have bugs. It happens. Now would be the time to change configurations on the vehicle to find the best way to do it. I know that sounds ridiculous. Like, they're just going to shoot from the hip with fueling here? No. They're going to use the previous data that they have from other fueling tests, the wet dress rehearsals, the green run, tank tests, cryo tests. They're going to use all that to find the best solution. Now is the time to do this. I know that sounds ridiculous, but now's the time to figure out the best way to do it. You want to figure out the best way to do it now, so you don't have to shoot from the hip when people are on board. That's a bad idea. They tried that once. It didn't work very well. I'm talking about the shuttle. Zed, we got a bug. Oh, please, not green. So Rocket Well, it's like, I'm telling you, if this was an operational mission, so if this was like Artemis 2 or Artemis 3, and they were having this problem, I'd be a little concerned. But right now, I'm not concerned. Take your time, get it right. You're putting people on the next one. Don't screw it up. Make sure this works correctly. Find the best way to do it. And more importantly, find the safest way to do it. Because when you put people on board, there's no undo button. I know it seems like I'm getting dramatic when it comes to this. You can't screw around with this stuff. I know it's just a Twitch stream. Like, oh my god, it's Twitch stream. EJ is really intense for just a Twitch stream. This is stuff you don't screw around with, especially when people are on board. Don't mess with it. You gotta be serious about it. Take your time and do it right. Now is the time to do that, Joe. If you figure out the best way to do this, figure out the best way to fuel this to get that seat to seal pretty much every time. This is why they're doing a tanking test. If you figure out the best way to do it now and that it's repeatable and it works, that's going to make operational missions, when you put people on this, it's going to make it a lot safer. Yeah, there's no revert to VAB or F9 quick loading. I don't get it though. Hasn't NASA been loading cryofluids into rockets for a long time? What's different now? Bam. See that thing? That's not there. That's the difference. Yeah. Like, I know this is going to come off as like a dick explanation, right? But honestly, that's not there. SLS doesn't have a shuttle on the side. What it does have is a 4-engine shuttle aft segment attached to the bottom.
The team is in revert and
even if you're
recovery.
using shuttle-derived parts, man, it's a different vehicle.
Now getting ready to begin.
It's going to do different
liquid
things.
Hydrogen flow back into the vehicle. Again, getting ready to flow liquid hydrogen again back into the rocket from the tail service mast umbilical that you see on your screen. We're going to get that flow going here momentarily.
It's supposed to be a new, different system to load instead of the Falcon 9 SpaceX Starlink launches, huh? I don't understand why they should start having this load problem for Artemis. Long Eye, Falcon 9 does not use hydrogen. It's using kerosene, basically diesel fuel. Diesel fuel is a little bit easier to get things to move around than hydrogen. Yeah, that's the difference. Falcon 9's not even in the same family of vehicles. You're comparing like a diesel locomotive to an airplane. No, not the same. Yeah, that's all. Liquid oxygen and kerosene is a little bit easier to flow. Don't get me wrong. Any cryogenic propellant is still a pain in the butt. Even SpaceX needs to worry about anti-geysering with liquid oxygen. They can overpress the lines and break seals. It does happen. I don't think SpaceX has had it happen ever in a little while, but I know that SpaceX did have a problem with the seals closing on the transporter erector umbilical lines, and the transporter erector was catching on fire in the early days of Falcon 9. Yeah. Oh, good. I didn't realize that prop was loaded through the orbiter and not directly into the tanks. That's right. Yeah, Bam. On the space shuttle, the propellant is loaded into the tail service mast umbilicals on the aft shuttle section. Yeah. And, well, why would you do that? Well, why would you want to have two fuel lines going into your external tank, one for filling and one for draining? That's a waste of weight. Fill it up, basically, at the point where the fuel is going to go anyway out the engines, right? SLS does the same thing. You want your fill points to be near the engines. That way you only need one fuel line and one oxidizer line to go to each tank, right? And it's funny because SLS in this case has 2 oxidizer lines on each side because they're using 4 shuttle engines instead of 3, but that's another story. But yeah, dude, I know it's like, didn't they use this thing for 30 years? What the heck? Like, it should work, right? But even if you're using the same parts, it doesn't mean that it's going to work the same. Oh, here comes the car analogies from EJ. Whoop, whoop, didn't expect that. If you take an engine out of one car and you put it in another car, right? Is it going to work exactly the same? Well, it should, but how can you be sure? You got to test it. You got to test it, right? If you take the tires off of a Humvee and you put them on a smart car, provided you could make that work somehow, gonna need some real offset spacers. If you take the tires off of a Humvee, you put them on a smart car, it ain't going to work the same way, is it? Oh, well, Humvee tires work on a Humvee, and a smart car works with its regular tires, so why shouldn't Humvee tires work on a smart car? Right? You gotta think about it. Even if you're using parts that already exist, you're putting them into a new configuration, and that new configuration needs to be tested, and it needs to be documented. That's why this is, I know it seemingly seems like it's such a pain in the butt. Like, what is NASA doing? Do you guys even know what you're doing? Like, that seems like the obvious question to ask. But if you take a second and try to learn and understand exactly how and why NASA goes about testing things and just how complicated this can actually get, I'm frankly surprised they didn't have more problems, right? It's frankly impressive that they haven't had more problems. The only problem that they've really had with SLS is that damn seal and a DFI sensor on the engines. That's pretty freaking good engineering. You know, just like, you know, Humvee tires on a smart car, or, you know, LS engine in a Prius or something, right? Like a muscle car engine in a Prius. It doesn't make any sense. Like they did the swap and it's working exactly as intended. That's a sign of really good engineering. Like, frankly, I'm amazed more things hasn't gone wrong with this rocket during its testing regime. Literally, that seal is the only thing that's being a pain in the butt right now. Everything else on this thing is working just fine, which is pretty insane. The other way around, smart car tires on a Humvee causes even more problems. I don't think smart car tires on a Humvee, Synerd, I don't think the smart car tires could even hold it up. You'd crack a rim. Am I right? Or at least it wouldn't work very long, that's for sure. They should just buy larger hydrogen atoms. Yeah, so fellas, like, it's the same parts, yeah. But you got to remember, different launch vehicle. That matters. That absolutely matters. If it matters in my silly car analogies, it definitely matters for the rocket, because the rocket's way more complicated than a Humvee, that's for sure. Look at me. I can operate a Humvee because I'm an idiot. You know what I mean? Like, the Humvee is easy compared to that. That's right, EVX. Yep. Those seals are extreme engineering. It's an inlaid ceramic and an alloy shell. Ceramic to metal sealing is tough in extreme environments. Yeah, EVX, that's what freaking works. Yeah. So I do have a picture, I think. That's the O-rings. I never got to finish talking about those, but that's from when we talked about propulsion. That's the umbilical test. I'll keep that open. Aft strut constraint, fire. Yeah, here we go. Now, keep in mind, this is for a vent umbilical, but this did have a picture of the seals in this PDF. There they are. Yep. EVX, they have the two-piece seal, if I'm remembering right. They're using that.
Discovery, go at throttle up.
After this last launch attempt, did they ever do any unit test on this LH2 system where they isolate and test only the parts that are failing instead of needing to test the whole rocket again? Jim, that's literally what they're doing right now. Yeah, your mind's in the right place. That is what this is. This is a tanking test. They're isolating the fueling systems from the ground launch sequencer and only doing the fueling right now. This is not a launch. This is just, they're just testing the fuel flow systems. And Chris gifted us up to EVX. Thanks, Chris. Is it hard to title in street legal a Humvee, tempting with how people drive these days in the snow? Depends on the state, NX. Exactly. They static fired this thing. They were able to load prop at the test facility, and it doesn't seem like they had to do this weird low pressure thing. Well, Bam, here's the thing. You and I don't know better than NASA. We don't. It's an important thing to understand. Stay humble, especially when it comes to a field that you're not an expert in, right? And don't get me wrong. I'm not saying you don't know what's going on. I'm not saying I don't know what's going on. What I am saying is with what little knowledge that I know about rocket science, it pays to test as you fly. So if it was up to me, I would have had the rocket fueled with the exact same equipment in the exact same way on the test stand that it is on the pad. Because if it works on the test stand, it's going to work on the pad. That being said, they did change a lot of things. They did change a lot of things between the green run and how they fueled during the green run and how they fueled during the wet dress. The idea was to catch those problems during the wet dress. You know, because you know the engines work already, so the wet dress rehearsal should be a way to basically put those changes to the test. And you have problems, right? Now, don't get me wrong, dude. I'm an armchair rocket scientist. I'm not an engineer. But that's with my limited knowledge of this. With how NASA tests, think of this like a beta test. They use waterfall testing, so instead of like, think of it like video, you know, if we want to talk about video games because we're on Twitch, think of it like early access versus beta testing, like nothing, and then you get a beta test and then you get a release, right? Early access is very much how SpaceX does things. There's rapid prototyping going on. They make new versions of Starship all the time. They make new versions of the rockets all the time. They're constantly testing things. They're constantly implementing changes. And you see the whole process kind of laid out in front of you. That's part of the reason why people love SpaceX so much. With NASA, they've basically been like, oh yeah, SLS is going to fly, SLS is going to fly. And what we're seeing now is the beta test. We're seeing a small window into NASA's troubleshooting process, like you would see with a beta test release for a game, right? Does that mean that the beta test software is going to work correctly? No. Nope, not at all. Your beta test is there to catch bugs in the system. It's there for that reason. Now is the time to change things. Now is the time to implement the changes, and now is the right time to find the best way to do this. I know it sounds stupid, but if you sit there and think about it, it makes sense. Yeah, Joe, cryoengineering is no joke. Yeah, Bam. What bothers me is, you know, if it was me, I would test as you fly. The test stand would be the same as the launch pad. But there's a reason why I don't work at NASA. There's a reason why I do this and I'm not sitting behind the firing room control center, you know, like They clearly think that that's better, and to be 100% honest with you, they know way more about this than I do, so I will defer to their judgment. You know what I mean? It doesn't seem right, but you got to take into account that I don't know dick compared to these people. You know what I'm saying? I know nothing. I know nothing. Nothing. Hey, Smoke, what's going on, brother? No, Tessa, it's not akin to Cyberpunk at all. They're actually doing beta testing and troubleshooting during the beta test. Yeah, guys, you know, it's funny. It's funny you say that. You know, it's like, oh, I hope it's not like Cyberpunk. I hope they'll release it and it's really buggy. I can think of one prior launch vehicle that where they released a buggy piece of software, so to speak. The shuttle. Shuttle's testing was never conclusive enough. NASA designed that space shuttle with the budget of the Gemini program. The testing was never conclusive enough. They didn't do enough robustness testing. That's why they ended up having so many problems during operations during the shuttle that eventually led to people to loss of crew, which really sucks. It really sucks. Does that mean that the shuttle is a bad design? No, hell no. I still will maintain that the shuttle is one of the craziest, best pieces of engineering that the space program has ever given us. Oh yeah, easily. Easily. It's my favorite launch vehicle for a reason. What that thing does is frankly absurd. You know? However, you know, with that being said, it wasn't really tested well enough. That's why they ended up having so many problems during operational missions. Testing wasn't, the beta testing wasn't robust enough. So, you know, taking it back to a game analogy, Cyberpunk was not tested enough. They weren't tested enough because they were under the gun to produce results. Right? They were under the gun to produce results. Does this sound familiar? There's a correlation here. Absolutely. So they ended up releasing a buggy game because they were under pressure to launch the game. NASA was under pressure because the shuttle was under delivering compared to what was promised because they didn't test it enough. The testing was not robust enough. So they were pushed to fly the space shuttle more and quicker. They were under pressure to produce, and they found a bug. They found a bug in the system after release. Does that make, you know, going back to a game analogy, Cyberpunk has a lot of bugs. Does that make it a bad game? No. In fact, they just released a really nice patch for it, and now it's really good from what I understand. Maybe we'll go play it again. Who knows? But in that same way, you know, the shuttle had all these bugs that ended up working their way into the systems that eventually resulted in a loss of crew. Does that make the shuttle a bad launch vehicle? No. To this day, I will maintain that the shuttle is a damn good launch vehicle. It's launched more people into space than anything else. And you could say, the Dragon, the Apollo capsule, yep, doesn't matter. The numbers don't lie. It ain't what you know. It's what you can prove. Empirically, the shuttle has launched way more people into space. But conversely to that, it's also killed more people than anything else. But it's also launched more people into space. It's a great system. I still think that it's a great system. And for what it's worth, I still think Cyberpunk is a good game. I enjoyed it. Shuttle never went out of beta testing. Simple as that. And that's because its testing regime was not robust enough because NASA's budget got cut so ridiculously bad that they ended up engineering a vehicle that's probably 20-fold complex as a Gemini spacecraft for literally the same price. Yeah. Yeah, no, I've crunched the numbers before. The shuttle, NASA's budget for human spaceflight in the 70s is very similar to their budget in the early 60s for the Gemini program. The development money allocated for human spaceflight is literally the same, adjusted for inflation. NASA developed the freaking space shuttle for the same budget as the Gemini program. That's absurd when you think about it. If you think about it like that, I'm frankly amazed that nothing else went wrong. That is a 20-fold complicated vehicle compared to that Gemini capsule. The Gemini capsule doesn't have a computer with it. It's an analog capsule. The shuttle has a 4-fold redundant digital flight computer. Or 4 fault redundant, not 4 fold. That's ridiculous when you think about it. What happened with the test? They're going to flow hydrogen again here. They had a leak on the first try, Jack. So think about that when you go talk about the shuttle. Oh, it's a piece of junk. No, it's not. It's amazing for the constraints that NASA had. It's God tier, S tier launch vehicle for the constraints for the circumstances which it was forged. It's unbelievable that thing is as good as it is for what it is. Like dude, I still love the shuttle. I still love it. It's amazing. It still flies in my head. I still have to remind myself that the program hasn't flown since, well, in 11 years. It still irks me a little bit. S tier fanboy. Yeah, I mean, Charlie, you're not wrong. You're not wrong, dude. I'm not going to say that you're wrong. I love that thing. It's amazing. But, Charlie, I will say this. If I had to choose between having a space shuttle and having the Saturn V, I'd take the Saturn V. I like the space shuttle because it existed. But I'll take the Saturn V, my dude. I'm not going to lie. I want boots on the moon. You could take the Saturn V and work on trying to figure out ways to make it reusable like what they did with Falcon 9. Duck! We okay? All right, cool. How about combining the two? Saturn shuttle. You could have done that if you kept using the Saturn V!
We are now in LH2 fast fill. We are currently now in LH2 fast fill.
Ooh, it worked! Yes! Yes!
This after a troubleshooting plan was put into play to try and reseal a leak.
They wanted to do that, Flash Wolf.
Hydrogen fuel line that developed after the previous transition from slow fill to fast fill. So again, currently we are now in fast fill on the hydrogen line.
Yes. Lowering the pressure on the main cryo storage tank on the pad seems to have fixed the problem. They got the seat to seal. That's really, really good news, guys. Yeah, that's great. That's really good. Good news, everyone. Bad news. No, that's really good. So it was the pressure issues. It's always been pressure issues, Alex. Yeah. The leak rate is correlative to pressure. But yeah, you could see the lines moving up there? You can definitely tell that they're fast filling. Look at that. See everything shaking around? They're fast filling it, baby. That's really good news. Smoked, ask away. Probably needed a lower pressure to fully seal off. Well, pressure is correlated to the flow rate, Scythe, right? And if you flow too fast, you're going to thermally shock the seal and it won't seat correctly. They found a way with the current system, with the given system that they have, to flow the fuel at an acceptable level to seal that seal. Oh yeah, definitely condensation. You're getting condensation everywhere. They're definitely flowing hydrogen for the seal to seat correctly. And now they're in LH2 fast fill, which is great. That's really good. The next step in the test is to make sure that you fill that whole hydrogen tank up with fuel and then make sure that the replenish fill mode works correctly. And then, I don't know, they might do an engine bleed. Who knows? Fast filling, just not that fast. Yeah, exactly. Oh, man. Oh, that's such a relief. I'm super freaking happy. That's such a relief. I'm going to fast forward. Prepare to fast forward. Fast forward. Fast forwarding, sir. They should reduce flow and do it again. I agree, Vixit. I would stop fast flow and cool it and then do it again. No, it's not leaking, Endo. They brought down the pressure. They brought down the pressure closer to ambient inside of the liquid hydrogen cryo tank. And when I say cryo tank, I mean that thing. They brought down the pressure in that to get a slower hydrogen fill rate into the vehicle, and it's seated. They moved to fast fill. That's really good news. That means it's working. That means it's working. Now, don't get me wrong, guys. It is still leaking. It always leaks. Hydrogen, it leaks. It's always going to leak a little bit. Hydrogen's a very small molecule. It'll just go right past a rubber seal because it can weave its way through the molecules. Hydrogen always leaks. The problem is having an acceptable leak rate. That's what's super important. You don't want it to leak too much because physics says it's always going to leak. There's nothing you can do about that. Don't you leak on me. I'll leak on whatever I want to. It's my stream. Don't do that. That's weird. I had a thought the other day concerning the lack of tiles on Ship 26. Do you think SpaceX could try a Falcon 9 style re-entry fire on fire before transitioning to a belly flop and then landing with Starship? Why would you do that, Darius? I'm not. If this sounds like I'm being a jerk, I'm not trying to. Why would you do that if you have tiles? Who knows the Delta V needed to get to Minmus and back? 4,000 plus 900. 5,500 meters a second total Delta V should get you there. I'd go to 6,000 just to be absolutely sure. Elimination of another system. Tiles are a part and the best part is no part. I mean, so you're swapping tiles for fuel at that point to be able to do supersonic retropropulsion, Synerd. Does the fuel required to do an 8-minute burn on descent outweigh the mass the mass of the tiles? Yeah, of course it does. Tiles are very, 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 very light, very inexpensive solution comparatively to other thermal protection systems. The best part is no part. If you could possibly remove the tiles from the equation, then you wouldn't have to worry about them breaking off and falling. Yeah, but you're subtracting the mass of the tiles, Darius, and you're adding fuel. So Starship would need basically a full tank of gas to do supersonic retropropulsion on the way down. I'm not saying they couldn't do that. Sure, of course it could work. You would need to be burning the rocket engine for a very long period of time. An 8-minute burn for a rocket engine is a lot. That's a lot. That's a lot. That's gaseous oxygen. That means they're fast filling it. That's normal. The clouds of smoke coming out there. I mean, you could do it. Yeah, sure. Of course. I think there are easier engineering solutions than trying to take into account an extra 100 tons of fuel on the way up. Now, don't get me wrong. SpaceX could be doing refueling depots, and they might be able to do that. I think that the tiles are not on Ship 26 for a very good reason. I think the reason is because they need to get those Starlinks operational. Remember, they signed that deal with T-Mobile. Starlink satellites need to get up there. That should be thing one. If the first couple of Starships need to be expended, so be it. My thought was that a short re-entry burn like Falcon 9, then go into a belly flop for increased drag and slow down, and then try to land like Ship 15. Okay, Darius, I need to make sure we're on the same page. What is a short burn to you? Should NASA redesign the fuel line seal to deal with high pressure? No, you can't. You can't, O-Force. The laws of physics. I can't change the laws of physics, Captain. That's impossible. The thing is, the reality of the situation, dude, is that you just can't deliver hydrogen at high pressure. The only time you can really do that is when you're using a turbo pump to shoot it into a rocket engine, in which case you don't need to worry about it turning into gas because it's going to get turned into gas anyway. If you deliver hydrogen at too high of a pressure, it leaks too much. If you overpressurize a hydrogen tank, all that's going to happen is hydrogen is just going to leak. It will leak like if you made a boat hull out of a sponge. And, you're not worried about sinking. You'd sink pretty fast, right? What about the nuclear warhead bleed heat shield that ITAR banned on Starship? That's a really complicated system, Forge. You want it to sweat like that. I think tiles are still a simpler option, guys. Yeah. Darius, a short burn, if you're coming back, if you're doing supersonic retropropulsion coming back from orbital, even with Falcon 9, it's like 15, 20 seconds, right? You're coming back from, and Falcon 9 gets nowhere near orbital velocity. It gets
We'll get an update
on a good day, a third of the way
flow
there.
Of liquid hydrogen.
We're talking about a 1 to 2 minute burn. That's a lot of fuel to carry around with you just through a thermal protection
stop
system.
Flow with a leak.
Tiles are literally simpler to do.
We are currently at roughly 14% filled on the liquid hydrogen side after getting back into LH2 fill. So there was a discussion between engineers and the launch director about getting data about this pressure-assisted seal that leaked. The moment that it leaked, they're actually currently pretty close to the point of having the same amount of pressure when the leak started, so they're currently watching this very closely. And at this moment, their data is telling them that they're less than a 0.5 percentage point concentration of hydrogen on the leak. So there is a very small leak, less than 4%, which is the constraint.
That's 0.5 leak rate.
But they are tracking to see if it's following the increase of pressure. SLS Chief Engineer and others requested that they be able to gather data as they raise the pressure, and they're currently doing that now.
Interesting.
They want to gather data to see at what point the leak changes with an increase in pressure. During the first run, they went straight to the roughly 10 psi when they went from slow fill to fast fill, but in this case they're stepping it up very slowly. And so the chief engineer for SLS, John Blevins, and the EGS chief engineer requested and got approval from the launch director to have a contingency plan in place if the leak reaches an more than 10% concentration of hydrogen inside that cavity for more than 5 minutes.
Yeah, they're watching.
They want to see if it goes up to 10%.
Thanks
it stays less than 10%, 10% or less for five minutes. If it reaches that level, they want to be able to gather data on this pressure-assisted seal to see how it's performing. If it goes above 10, they're going to go into stop fill and revert. The launch director says that if they also see a sharp increase, she wants measures immediately put into play to stop the leak. This plan is all in the name of gathering data about this seal, which has been troublesome.
Washing bugs, dudes.
In a previous launch attempt, if you've been following the Artemis 1 program, it created it caused a scrub back on September 3rd. And so the team really wants to closely watch what's happening as they raise pressure and the flow increases hydrogen into the rocket through that umbilical line that you see there. The tail service mast umbilicals, the gray protrusion on the left. The lines go into the rocket on the right. And the area with where the leak is right up against the rocket at the plate that connects those umbilicals right there.
How much more time was it the SRB's viable, Rich?
To the rocket.
They're using
Again,
HTPB
they detected a leak in 5 minutes after
they should be
10 a.m.
NASA thinks they're fine, and if they think they're fine, I'm inclined to
stop
agree.
Flow. This time they want to maintain a slow flow, track the pressure, track the rate of leak.
No, Seiner, it's about finding the right way to get the seal to seat every time.
That's currently the contingency plan that's in place.
That's why they're monitoring this so
as they raise
so closely
the
because
to get to a faster rate of fill.
They got a way. They found a way to do it.
Currently, we're at 17% full on the hydrogen side.
Nothing yet,
on the
Chris.
Liquid oxygen side, we're at 89%. The goal of today is
a
cryogenic demonstration test to tank all 4 cryogenic propellant tanks, super chilled propellants, into the rocket to determine if they repair to a seal on the hydrogen line into
What do
the
they
core
need to fill
stage
locks?
is going to hold. They encountered another leak today, but again,
test as you fly.
they
Vixen.
are watching that closely.
Yeah, Charlie, that seems right. You got to be careful with that. We got to consult Gene Kerman
as they are slowly raising the pressure, which results in more.
What did they do to fix it? JW, they lowered the pressure in the hydrogen.
Stand by for more updates. This is Artemis Launch Control.
The hydrogen commodity fuel tank. So that's the tank that's on the pad, not that tank right there, not the orange one. They lowered the pressure, the absolute pressure inside of the tank to get a slower hydrogen fill rate. And it seems like the seal has worked correctly. So for the people that don't know, this is pad 39B. This is just on Google Earth. This is pad 39B. You have a hydrogen tank over here and a liquid oxygen tank over here. Now, the liquid oxygen tank does have a pumping system. You can use pumps with this. That's fine. Liquid oxygen is stable enough to be able to use pumps correctly. Now, hydrogen, on the other hand, no. Hydrogen, if you try to use a pump, you could potentially get overpressurization, and if you get overpressurization on the pump, it'll cavitate and the pump won't pump anymore. How they move hydrogen around is a lot simpler than that. The reason why is because when you have liquid hydrogen, it cavitates really, really easily. So you have to slow fill it. You have to go very slow with how you fill this thing. So a pump won't do it. The pump will just dry fire and it won't do anything. You just create hydrogen gas, and that can overpressurize the line and cause it to explode. It's called a geysering effect. They have heater coils inside of this tank. Just a heater coil, like if you have an electric stove. Same thing. I mean, it's a little bit bigger, but you get the idea. It heats up the hydrogen, and some of the hydrogen boils off. And it turns to gas, and that gas pressurizes the line. It forces the liquid through the line because they heat it up, and then they open a valve, and the hydrogen will go through the fuel lines up into where the mobile launcher would be up on the rocket, right there. What they did was they lowered the pressure in the tank, and then they opened the valve.
Currently in
and it's working.
The pressure
up until now. Let's see.
Required for fast fill operation. On the liquid hydrogen side, we've currently reached that pressure. And still showing around
There's no leak on the white tank, Rich.
0.5 percentage point concentration of hydrogen inside the can where the leak is. Again, we are fully in fast fill on the liquid hydrogen side.
Yeah,
with just
great picture.
A very small leak being detected in the can.
How much are a set of SRBs? They have another set if they wanted to do that, Rich. But what I was trying to say is that they use
not in the can, within the side, the QD cavity where the connection point is, right up against the rocket.
That's right, Sol. This is a tanking test. This isn't a launch test. Yeah, of course, Chief. There's that too. Guys, the SRBs on this use HTPB, and so hydroxyl terminated polybutadiene and ammonium perchlorate with an aluminum flake stabilizer. I don't know for sure if I don't know how long those SRBs can sit there on the pad like that. What I do know is that ICBMs that the United States uses, submarines, silos, stuff like that, the ICBMs that we use the same propellant. And those things are designed to sit in a silo for 30 years. I can say based off of what we know about that I'm pretty damn confident that those SRBs would just fine. Yeah. No encabulator? No, maybe. I don't know. Those ones that went off back in the day were just due to overproduction, right? Those ones that went off back in the day. What do you mean, Tessa? Nice, 48. That's funny. All right. Sweet. We got the fill rate UI up. Oh, the PepCon. Yeah, PepCon was, yeah, exact. Yes, Tessa, yeah. Yeah, that's because they had too much stored up because they were trying to scale up propellant to match the 24 flights a year flight rate of the space shuttle. And then Challenger happened, and then they just stockpiled a bunch of HTPB and ammonium perchlorate at the factory. And yeah, that didn't end well. Yeah. Ah, bugs. Ah, that's a small flirt of bug, dude. What is the max fuel fill rate? Don't know. I don't know the exact fill rate. You could probably extrapolate it from these numbers, but I don't know what it is offhand, Chaos. Are you taking a break after this test? I don't know. I'm not really thinking about it, Linus. I mean, maybe. Who knows? I live in a Nordic country. We don't see bugs that much. Oh. Rocket Lab Investors Day with Neutron updates coming in about 2 hours. Yeah, Core. We're definitely watching that. I want to hear about Neutron. I'm eyeing that flow rate for the hydrogen. 130, 436. 138.62. Okay, they're still fast filling. That's still fast filling hydrogen. Boca update, Booster 7 is in the air for the swap. Dude, there's too much space stuff going on. Like, don't get me wrong, Thomas. I love it. I love it. We got Booster 7 being taken off to go back to factory for robustness testing. Booster 8's going to take its place. They're going to do testing there. SLS has a tanking test. We have the Neutron update. We had a Soyuz launch going. Like, dude, there's so much stuff going. You know what? I ain't even mad, but I can't cover all of it. I'm not even mad. This is great. This is great. I'm just sitting here going, all right.
Discovery, go and throttle up.
Oh, you got gifted a sub by Chris Thomas. There you go. Chris, thanks, buddy. Time for more screens. Clone yourself already. Yeah, right? Spider's like, yeah, I even got a Windows update. No, we don't want that. We don't want you don't want that. Split screen background time? Guys. I can't find the tab. I can't find the tab. I have Starbase Live basically on 24/7. I can't find the tab. Oh no. Oh no. Where is it? Is it that one? There's so many tabs on my left browser. It's kind of bad now. Ah, there it is. No, that's not it. That's this. I have this stream up on the other computer too. There we go. I found it. Yeah. Also, there we go. Is this what you wanted to see? That UI, Tessa, makes me want to listen to lo-fi for some reason. You can almost hear the vinyl scratch. You know what I mean? That. Why is the hydrogen tank only at a quarter fill? It's because they had to slow fill the hydrogen supercraft, and the first time they tried it, they had a leak, but they kept topping liquid oxygen up to 50% because of the aft strut rule. If you want to know what that is, I can explain it. Long story short, they had a leak with the hydrogen, so they had to stop it for a second, and then they started filling it again. Oh, Sneaky, I love the vinyl pops, dude. I don't know about you. Booster 8 is going up to the standard. That's 7 going down, Alex. Also. Oh. Damn. Damn. How many engines you want, Elon? Yes. 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 You love your vinyl closing in on 4,000 in the collection. Rich, there really is nothing like it, dude. There's nothing like that. Dude, I don't know what it is. I don't know what it is about vinyl, man. The sound is unbelievable. That view from your window? Is this the end of Booster 7? No, failures, not at all. They're taking Booster 7 back to the hangar for robustness testing. They're basically going to, based off of what they tested, there's some components that need to be strengthened. They're going to strengthen those components, and Booster 7's the one that's going to fly the flight test, I'm pretty sure. Actually, now would be a good time to share all those Elon tweets. Our focus is on reliability upgrades for flight on Booster 7 and completing Booster 9, which has many design changes, especially for full engine RUD isolation. Yeah, they're making a octogrid. Yeah, they're gonna make something RUD isolation, something similar to Falcon 9, which has segmented engine compartments. The Octaweb is what it's called, but I don't know what the designation for a 33 engine isolated thing would be. Remember, SpaceX can lose 15 Raptor engines on Super Heavy, and it would still make it into space.
Discovery, go at throttle up.
Agreed. Vinyl beats the crap out of any digital format, even though a lot of current stuff has a digital footprint. Yeah. Are they now back at normal pressure for fast fill? Yes, they are, LJ. Yep. I've been through the process of producing an album. I know what's the difference. Vinyl is literally mastered better because it's assumed to be played on a high-end stereo, not a mid-range model. Interesting. I'm making you lunch. If you're hungry, I can bring it to you. I'll take a break in a little bit. So what else is Elon saying? There was a couple of other things, from what I understand. He pinned exactly. What is that pinned to? Oh, no. Yeah, we don't need to talk about that. Oh, here we go. It's still that thread from what I can tell. Animal SLS, go for liftoff. Hopefully not right now. Tritria Conweb. Oh, thanks, Reagan. Do you have KSP multiplayer? I don't. Oh, okay. Yeah, it's right here. Can you please give us some updates about the orbital flight date? I can't wait to see this launch. Late next month, maybe, but November seems highly likely. We will have 2 boosters and ships ready for orbital flight by then, with full stack production at roughly 1 every 2 months. That's absurd. That's in a good way. In a good way. How about a nice thermal curtain failure right now? I don't want that. We don't want thermal curtain failure. That could accidentally launch the vehicle into space. Probably Q2 next year. Vehicles initially transferred by boat from Port of Brownsville to the Cape. This is what you guys... This is what you guys wanted me to see, isn't it? Not to get ahead of ourselves, but you have an estimate for the first booster at 39A. Probably Q2 next year with vehicles initially transported by boat from Port of Brownsville to Cape. Unbelievable. That's pretty damn good vindication, isn't it, Thomas? We've been saying that for like the past year. There's no way, yeah, they're not going to get, they got to move. They're going to move them by boat. That big concrete road and the radius on that concrete road at Boca Chica that goes to the Port of Brownsville. Dead giveaway. Boom. We literally used a road to figure that out. Isn't that cool? I love doing that. Elon says just 1 month left for the last 20 months. Rupert, yeah, I know what you mean, Elon time and whatnot. But also, I try to look at what SpaceX is doing and try to correlate that to what what Elon says. And what I mean by that is that right there, that See all this right here? That leads me to believe that's probably a more accurate estimate. You know what I mean? Because turns out if you have a huge freaking gigantic booster, right, with a lot of engines on it, you know, you're more likely to launch soon because the booster is there. It exists. It's pretty self-evident that they're getting close to an orbital flight because of that thing. Right? Am I wrong? I think that's a reasonable extrapolation there. But yes, I know Elon time. Yeah, he said that we'd be going to Mars in 2022. In 2018. Yeah, I think it's pretty reasonable. Not because Elon says it is, but because there's a huge booster that suggests that it is right there with 33 Raptor engines on it. You know what I'm saying? You know what I'm saying, man? You picking up what I'm laying down? Yeah, exactly. That's what I mean. Rupert, this leads into a larger thing. I commentate on a lot of launches. I commentate on a lot of things going on in the space program. The thing that I've learned, it doesn't matter if it's Elon, it doesn't matter if it's NASA, it doesn't matter if it's Tory Bruno, it doesn't matter if it's Jeff Bezos, it doesn't matter if it's Richard Branson. Talk is cheap. Talk is cheap. Look for the hardware.
Which is the kick start.
Because it's easy to say you're going to make SLS fly.
Engine bleed kick
It's harder to actually make it fly.
With the liquid hydrogen. So in order to do this, there are several lines that pull the liquid hydrogen back out of the rocket after it has run through the engines. They want to make sure that they can get this bleed started and going. This is part of conditioning, thermally conditioning the RS-25 engines at the bottom
FAA, Rich,
of the
but
rocket.
Yeah, I know what you
Four
mean.
RS-25s made by Aerojet Rocketdyne.
I try not to dwell on the past like that,
Boeing.
but yeah, I do
There
understand
they
what
are,
you're getting at.
four RS-25 engines. So the kickstart bleed was a major milestone that they wanted to get to in this particular cryogenic demonstration test.
Yeah, Thomas.
So they're going to pre-chill a 4-inch and a 6-inch bleed line that comes off of these engines and then vents that or bleeds that liquid hydrogen out of those engines. They need to condition the engines to get them ready to start, and this is a test of that, the initial part of that bleed. It's a pressurized bleed to get it going. They close the vent, the liquid hydrogen vent, the gaseous hydrogen at that point when it's venting out. They close that vent to pressurize it, and then a small amount of liquid hydrogen is then bled through all four of those engines. Currently, they're managing a very small leak.
That's supposed to happen, guys. Hydrogen will always leak. It's the rate of leak that's always been the problem. So it looks like once they get it filled up, they're going to make sure that the engine bleed system is working correctly. What's engine bleed? Well, I'll let Daryl explain it.
And so currently, we're at 35% full on the liquid hydrogen side. And they are monitoring a leak that is less than 1%. So engineers and safety, they're comfortable with that. The margin, the area of concern is when it goes over 4%.
Do I know of any new launch vehicles that had teething problems like this? Yes, only every single one of them. Yep.
Engineers have
NASA's just more transparent about it.
Got approved a contingency procedure.
We got many problems
Astra's
had.
Allow the leak percentage to go up to 10% for no more than 5 minutes, after which they would
Lofty. Try to keep it classy in here for me, dude. But yes, they're flowing the hydrogen. Yep, they're fast flowing and they're monitoring the leak.
Discovery, go at throttle up.
Trying to get
stop proceeding with hydrogen flow into the tank.
Why is the fuel tank orange, Looper? It's insulation to keep the propellants cold.
Collect data.
Yeah, it's all good, man. Don't worry about it. What was the solution? They dropped the pressure in the commodity storage tank on the pad. In the hydrogen storage tank on the pad, they dropped the pressure drummer to get a slower fill rate, and the seal seated correctly, which is excellent. Now,
okay, and I've just that the bleed kickstart has now begun. Again, the kickstart bleed running liquid hydrogen now back through the engines and then off the rocket has begun.
Cost scales exponentially with capability, Rich.
Over on the liquid
saying that
oxygen side, they have reached 98%.
saying that, well, NASA has a bigger budget, so they should be able to get this done. Cost scales with capability, man. It's just really how it goes. If you have a Mack truck and you have a Prius, which one of those, which one is harder to operate? Which one costs more? Does a Mack truck do more than a Prius? Oh, yeah, absolutely. Citing cost when comparing rockets doesn't make any sense, especially when the rockets are designed to do two different things. This is not Astra's rocket. Astra's rocket could fit inside of the SRB, in one of the segments of the SRB. See what I'm saying? Just because, well, NASA has more money, so they should have less problems. No, that's not how that works. It's not how that works at all.
Space station. We are going to go into live coverage of the docking, and we will be continuing our coverage, as you can see on the bottom of your screen, on the YouTube channel at youtube.com/NASA Gov video. So again, we will continue coverage there, but in the meantime, our NASA public channel will pick back up with coverage of the Soyuz mission to the International Space Station. This is Artemis Launch Control.
There you go, Wicked. Happy birthday, buddy. Thanks for bringing us the news and taking us through it. Yeah, my pleasure. I meant to ask if you knew specific examples of these types of issues that other new vehicle had. The space shuttle had hydrogen leaks. Delta IV has hydrogen leaks. It has hydrogen leaks every time it launches off the pad. Teething problems happen with every vehicle, guys. NASA's just more transparent about it. There was that whole, there was that whole thing where SpaceX didn't get their umbilical fill rates correctly. They didn't get the umbilical fill rates right. And they started, the rate of leak went way too high. And SpaceX tried to emergency depress SN4. And they couldn't control the fill rate correctly because they overpressurized. And that led to some issues. This was back in 2020. I hate that I have to say that. Oh, yeah, there you go. Is that a big enough teething problem for you? Is that a big enough one? Dude, it happens all the time. Every rocket has problems like this. It's just NASA, you don't hear about it. I mean, SpaceX gives us pretty unprecedented coverage, which is pretty cool. You just don't hear about it. They don't want to tell people that they're failing. You don't want to fail publicly, right? Especially when investors are involved, right? That's the duality between a government-owned space program and a commercial space program. NASA has to tell us their failures. They have to tell us what's going on by law. And that transparency is accountability for NASA to do the right thing. That is law. That is the law. They can't not tell us. They have to. They have to hold press conferences. They have to tell us what's going on. So the cool thing about that is that you end up learning a ton of things, But
the engine bleed kickstart.
The accountability there, by having to answer to the public because it's a taxpayer-funded thing, makes it so they won't. It's accountability for them. They have to answer to us, man. That's why by law they have to tell us.
Increasing the pressure on the tank.
Every rocket has teething problems like this, dude. It's just NASA has to tell us about it because we're funding it. We're the investors. Got to tell the investors, man.
But the engine kickstart bleed
is
Thailand,
it was amazing.
Nominally.
Yeah. Yeah, then there was the hard start, Hellfish. Yeah, SN11's Raptor hard start that blew the entire bottom of the vehicle off. Yep. When rollback, just saying. They got hydrogen to flow. They're not rolling back, bro, Andy. Now it's just pending range approval. Do they have to play the Space Force theme now before every test? NASA is not Space Force, Snickers. Those are two different organizations. What you just asked is like asking the Marine Corps to sing the Army anthem. I'm pretty sure that's a good way to get a combat boot up your tailpipe. Just saying. No, Turing Twitch, well, it is still leaking, but it's leaking at acceptable levels. Hydrogen is always going to leak, guys. That's just physics. That's like saying water, water will never be wet. And I understand that there are circumstances, well, water's not always wet, blah, 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 blah. You understand what, you get what I'm trying to say. Don't be a smart aleck. Yes, it is. My steel toes are ready. See, Perky knows. Yeah, Nuclear, I saw your question. Sorry, man. There's been Daryl started talking right when I tried to answer it. KSB and Real Rocketry question. How do you design a rocket that will be used for multiple missions? Manned science around Kerbin, and when to use cryogenic engines over chemical engines. Cryogenic engines are chemical engines. Yeah. All liquid fuel rocket engines that we have right now are chemical rocket engines. So I think what you're asking is using cryogenics versus not using cryogenics. Nuclear, it comes down to what you're doing. SLS uses hydrogen. The reason why it uses hydrogen is because when you get beyond low Earth orbit, efficiency is key and not TWR. TWR will help you get there faster. But you want a higher energy transfer? It favors specific impulse. Hydrogen gets you the best specific impulse. It's the best propellant, the best chemical propellant we have to use to move around in space. That's why a lot of upper stages, like on Atlas or on Vulcan or on Delta, are fully cryogenic stages. But Atlas, for its first stage, for instance, uses a semi-cryogenic. It uses kerosene and liquid oxygen, right? Because
just a few minutes
first stage needs more energy because it needs to lob that second stage up there.
On the LH2
so
side.
It favors TWR over Delta V. See
just
what I'm talking about?
To reach the max pressure on the kickstart. Leak is up over 3%.
It did, bro, Handy. Yep.
It topped out at 3.4%.
Perfect.
It's tracking.
Perfect.
With increase in pressure.
Yeah, they're in fast fill, bro, Handy. Yep.
But the kickstart bleed is now at the point where the valves are cycling the pressure, meaning it's got it at right about the right pressure for this particular engine kickstart bleed.
So an interesting thing to note, guys, that I noticed they didn't do this last time. For the first launch attempt, when they got the hydrogen to flow, they topped off the tanks completely and then they bled the engines. And the bleed lines didn't work. With this test, they're bleeding the engines, basically getting the engines cold enough to start them. Thermal conditioning the engines is basically the equivalent of priming the engine. So like, if you start the car, it goes like for a couple seconds and then it starts. You're getting the fuel system primed to be able to deliver the fuel for the engine to start, right? They do the same thing with rockets, but it's not necessarily to just prime the engine to make sure that when you turn it on, it starts right away. They prime the engines because, once again, the propellants are really, 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 really freaking cold, and you don't want to thermally shock the rocket engine, meaning you don't want to change the temperature of the rocket engine too fast. It'll literally cause it to crack. The thing will contract and it'll shatter into a billion pieces. Think like Terminator 2. Hasta la vista, baby. Just got shatters like that. It will literally do that. And if the rocket engine cracks, well, this kills the rocket engine. In the particular case of thermal conditioning in the shuttle engines, they're actually worried about spinning bearings on the high pressure fuel turbo pump, the hydrogen turbo pump on the motors. They don't want to spin a bearing. You have to get it so the bearing contracts around, the fuel pump bearings have to contract correctly to seat correctly. So when they go to start the engine, it works. That was one of the reasons why the first launch attempt scrubbed, because they couldn't get a good reading on whether the bearing was cooled down enough. But that is what they are doing right now. They are still fast filling the hydrogen tank on SLS, but they're also priming and bleeding the engines. That's what that's called. You also want to, this goes back to priming the engine. You also want to make absolutely sure that there is no gas in your liquid fuel rocket engine. You don't want helium in there. You don't want gaseous hydrogen in there. You don't want gaseous oxygen in there. It is a liquid fuel engine, meaning you need liquid oxidizer and liquid fuel in the form of liquid hydrogen and liquid oxygen. If there's any gas in the system before the gas comes out the bottom, it's going to have a hiccup. And if it hicks up, it's going to explode.
Is now complete.
They've bled the engine. So all four engines are thermally conditioned.
To the vented bleed at this point.
Also, the bottom of R2-D2.
Filling the rest of the tank. So the pressure now drops a bit, and they continue.
They use that in dermatology rings,
Again,
actually.
Kickstart bleed is complete.
A liquid nitrogen cryogun. Yeah, it's used in dermatology all the time. Yeah, Junie, if the thing hicks up, it blows up.
Filling the tank.
That's simple. Hard starts, it'll create a hard start scenario. Hard start scenarios for rocket engines would be like the equivalent of starting a car with your foot fully, with the gas pedal fully down. Starting a car at full throttle. Yeah, not good for it. Very not good for it. Yeah, usually will break something. Yeah, you gotta make sure it doesn't hiccup like that. I wonder why there's no weapon. Because a bullet does fine and it's a lot simpler. Oh, now he tells me, yeah, right? So it turns out my gas tank is still sort of leaking when it's full. It wasn't the seal on the fuel pump. It's got to be a fuel line, sneaky. Or, yeah, compressor stalling a jet engine forward one. Yeah, similar. Actually, I think there's a company that's working on a cryo-based weapon. There's a company called Zorg Industries that's working on a prototype rifle that's called the CF1 or something. And it's an integrated system that's designed to basically be like an assault weapon with like a rocket launcher, a flamethrower, a net launcher, and a cryo gun. Yeah, I think somebody's working on that. Slat, handy adjustable, good for riders and lefties. Word on firepower, titanium burst of 3 to 3,000. With the new replay, another Zorg invention, it's even easier. Fire and Ripley sends all the following shots to the same location. Finish the job off, all the Zorg oldies with goldies. Rocket launcher, arrow launcher with flame and poison tip heads. Our famous net launcher, the always efficient flamethrower. My favorite. And to finish the job off, the all-new Ice Cube system. 4 crates, delivered right on time. Now, my dear chat, do you have what I asked for? Yes. That's your voice. That's what you sound like. Does it have a bottle opener, though? Sure. That's you. That's what you sound like. Sounds like a weapon made by Hyperion. Another good reference, organic. Yeah. Could be Hyperion. Yep. Why does chat sound like Gollum? Because you're weird, Frilled. Obviously. What? That's not being mean. That's just self-evident. You're mean to me. So, anyway. Now, real chat, when they picked up ZF1, would have immediately asked about the little red button on the bottom of the gun. Get me the priest. Sorry. So, sorry, I get excited when this stuff happens. They are in fast fill with liquid hydrogen, and they have bled all 4 engines. All 4 engines are thermally conditioned. Once again, I'd like to make a note that they didn't bleed the engines during fast fill previously, but they are doing that now. That is more indicative of what they did during the SLS green run. They bled the engines while filling hydrogen when they put SLS on the test stand and did a full duration fire in Mississippi. They did that. During the first launch attempt, they didn't do that. They filled up the tanks with hydrogen and then tried to bleed the engines, which is very interesting. They reverted back to what works. Go figure. We're meme to you? Oh, all the time, Ezzy. You guys meme all the time. Turing, I don't know about the batteries. I haven't heard anything about it yet. How fast is the fast fill? They could drain an Olympic swimming pool in less than an hour, if that's what you're asking. That's impossible. I am Corbin Dallas. Sorry, sir. Boarding is finished. Wait. I need to talk to someone. I can't believe this. So if you want to learn about flow rates here, they brought up the UI again. The core stage hydrogen tank has 538,263 gallons capacity. And during normal fueling operations, they could probably get that in about 2 hours. So I'm sure, so about 2 hours for 538,000 gallons of liquid hydrogen. I'm sure you can extrapolate flow rate from that. Yeah, it's pretty high. Yeah, flow rate is, but that's a lot of hydrogen. Considering that they're just heating up the hydrogen tank on the pad, and that gas pressure inside of the hydrogen tank is what's flowing the fuel. They're flowing that quickly without a pump, which is just, all right. LOX tank is full, so the LOX tank should go into replenish mode here. I know, Creeper, yeah. Yeah. So, this is the SLS core stage tanking test. They're not launching today. This is only a test. This is a test of the emergency tanking system. Had this been an actual emergency, instructions would have followed. Anyway, this is a tanking test. NASA engineers needed to make sure that the hydrogen fuel line was working correctly. As you can tell from this UI, it absolutely is working just fine. It's working just fine right now, which is good, meaning they found a configuration for the vehicle that can fast flow liquid hydrogen. They've also completed a step for bleeding the rocket engines, which was what caused Launch Attempt 1's scrub. The engines are fully primed and ready to go. Now, once again, they're not launching today. No launches today. This is just a test to make sure that all of the fueling and plumbing systems work on the vehicle as intended, as designed, and they are working correctly, which is great. NASA is currently targeting, they have September 27th penciled in for a flight attempt. That is on Tuesday. They have that penciled in. There is backup dates. I believe the backup date is the 7th, but I'm not 100% sure on that one. But all of these dates are just penciled in. It's pending range approval. Long story short, there's an abort system built into the rocket that's battery powered, and it's attached to basically the ATC for Cape Canaveral, which is called the Range. The Range is operated by Space Force Delta 45, or the 45th Space Wing. Long story short, what that system entails is, in case the rocket for some reason goes off course and starts going towards populated areas, they can basically abort the system. They'll just self-destruct the rocket. They have to make sure that the self-destruct systems, what's called a flight termination system, is still, the continuity of that system is still good. NASA has to prove to the Range that it's good, because it's beyond its intended expiration date. Because this rocket should theoretically be at the bottom of the ocean right now. It already should have launched. NASA has to prove that those abort systems and the self-destruct systems, called the FTS, or flight termination system, they have to prove that those work. So they have the 27th penciled in, but that's pending Range approval. Basically, they're not going to let you fly if the abort system doesn't work. What time on Tuesday? It's during the day, Remo. Yeah, since, well, yeah. Oxygen is quite a bit hotter than hydrogen, isn't it? It's funny because it's all relative. I wouldn't go like swimming in liquid oxygen. That would probably end poorly. $11:37 a.m. Eastern time. There you go. Blue Origin did a full test. Yeah, the thing is, Vin, the FAA grounded New Shepard. Not allowed to fly people until they figure out what's going on. That's, yeah, that kind of sucks, but it is what it is. Couldn't they just keep those batteries on a charger or something? I mean, I can pick up a USB charging cable for $7. Mike, the battery's about 200 feet up there. If you can get to it, sure. Yeah. It's about 200 feet up there inside of the forward skirt of the core stage. That's 220 feet that way. How are you going to get to it? And yeah, that's right. That's the other thing. Core space is right. The FTS needs to be an isolated system. For multiple reasons. You don't want, like, the vehicle, for instance, to get struck by lightning and it trigger the FTS. That would be very bad. It has to be an isolated system. Everything is good. They're fast filling, Pasquale. And guys, I can't stress enough how important this actually is. Not only are they hydrogen fast filling, they have bled the engines. The engines are chilled, which was the reason why the first launch attempt didn't work. So not only have they fixed the reason why the second launch attempt didn't work, which was the hydrogen seal, they also have tested the fuel bleed system and made sure that that's worked correctly as well. The 2 reasons why they scrubbed are working. They fixed the 2 reasons why they scrubbed. That's big. That's big. Big. You love to see it. Yes, they are, LJ. Yeah, we're good. Are we continuing the Hastarplan today? Yeah, maybe after Rocket Lab. In about an hour, we have a Rocket Lab investor meeting and presentation is happening, JDG. And Rocket Lab is going to be presenting an update to their new rocket design. They're not fully reusable. They're partially reusable neutron rocket. And I'm keen to hear about that. Can't wait to see this launch getting going in the Starship orbital test. Mm-hmm. Are you still in the first season with Haas? We got 2 races left, I think, Sethron. So, Mike, long story short, even if they could, like, the batteries are there, and yeah, you could charge them, how are you going to get at them? They would have to get them back to the VAB, and that's why NASA needs to be able to prove it, because the range wants them to roll back to make sure the batteries are charged, because the VAB is the only way you can get a service gantry up there. Now, if it was up to me, get one of those telehandler things that SpaceX uses, get a guy up there and make sure those batteries are charged. Literally put the voltmeter to it to make sure it's good to go, you know? Continuity testing, 14 volts, all right, we're good. Or 12 volt, or whatever. It's probably... The FTS is probably aircraft derived, so it's probably a 24-volt system. If I had to guess, that's just a huge guess, and it's probably wrong. You could use a fire truck? Not tall enough, dude. Sounds like a design flaw. Design flaw. That's hilarious. Why is it a design flaw? The batteries are supposed to be there, so the vehicle's not supposed to be out on the pad this long. Because, you know, in an ideal scenario, it would have launched already. I hate the term design flaw. There's no such thing as a design flaw. All right? There's not a flaw in the design. A design flaw implies that you did everything right and something happens that you didn't anticipate. Well, guess what? If you didn't anticipate it enough, guess what? Your data analysis wasn't good enough. All right? There's no such thing as a design flaw. There's just things you haven't taken into account. And if you didn't take into account, well, that's pretty bad engineering. I hate that term because people use it as a catch-all. Oh, it's not doing what I want. Oh, design flaw. Sorry, what does a design flaw mean? It means that it's not doing what you want, basically, Alien. The vehicle isn't doing what you intended it to do. That's just a failure mode. That means you just found a way that it didn't work. There's no design flaw. Reconfigure it for it to do what you want it to do. Just run a line so you can plug it in on that pad. The Dunning-Kruger is real. It's still leaking, E1, but it's leaking at acceptable levels. They are in fast fill. Yeah. Once this thing gets up to here, the test will conclude and we're good to go. They did fix it, Zay. Yep, she's flowing. Yeah, I know what you meant. So the LOX tank is fully fueled right now. Fully filled, I should say. Hydrogen tank is getting there. They are in fast fill, and the leak rates are at acceptable levels. Once again, I can't stress this enough. Hydrogen always leaks. It just was leaking too much. It's the rate of leak. The observed rate of leak at the last time NASA updated us was 3% of all 3.5% of propellants being flowed into the vehicle. 4% is out of family. That's an unacceptable leak rate because they only have enough a lot of hydrogen. They only have enough hydrogen inside of the pad GSE, ground service equipment, basically the fuel tank at the pad. They only have enough for like 1 to 2 cycles, so they don't want to leak too much. You don't want to leak too much hydrogen. Now they won't have this problem in the future, but also you don't want to leak too much hydrogen because you could Hindenburg the launch vehicle. Yeah, it is hydrogen, gaseous hydrogen, which is what the Hindenburg used. That doesn't end well. You don't want to leak too much. Just curious, how does a hydrogen purge valve work? What? What do you mean, T-Man? There's a ladder, which is a 112-meter long ladder. What do you mean they won't have this problem in the future? Are they planning an expansion? Yes. Yes, they are. It's almost ready to go. So, T-Man, a hydrogen purge valve, how does it work? It's just a butterfly valve. Usually it's pneumatically actuated because there's a thing about electricity and hydrogen, that combined with oxygen makes fuel, air, and spark. And so they usually use a pneumatic helium actuated valve. It's just a valve that opens and closes like it's called a butterfly valve. Most valves are like that. Fully fueled H2. Yep, is the endpoint. Yes, that's correct. All right, they're still in fast fill here, guys, which is good. If someone pushes a button somewhere and the valve opens, that would be a manual actuation of the valve, manually induced actuation, A4. You ideally would want the computer to do it for you because the computer is sequencing a series of events to make sure the vehicle fills up correctly, but SLS does have a manual redundant fill button backup from what I understand. Most of the systems on board have a manual backup so you can troubleshoot problems like this. I trust you, Chris. A Bronto Skylift F112. Neat. That's cool. Chris, so for all the people that have all the unique and fun solutions for changing or checking the continuity on the flight termination system batteries, I have a question for you. Did SLS designers, the people that made this thing, the engineering, all the engineering and analysis and quantification to make sure, that the vehicle is engineered correctly and making sure data matches test, did anybody there intend for somebody to use a cherry picker to go up into SLS to change batteries? Was that intended? Probably shouldn't do that during your baseline test configuration. There's no doubt that you could send a guy up there with a ladder. That's not the hard part. Remember, this is a beta test. Now, unless you're taking into account a guy climbing up there every single time, maybe the guy goes up there and he trips. Maybe he trips and he bends a wire or something, and he crimps a wire or dents a pipe or something. That's not good for baseline testing data, is it? See what I'm talking about? This is not SpaceX. NASA does not test the way that SpaceX does. So SpaceX is just send a guy up there with a ladder and change the damn battery. But if you're trying to get good baseline test data from the vehicle, doing something like that is putting the vehicle into a potential failure mode. Nobody's intended to be up there changing batteries in this stage of the launch campaign. That's not intended function. That can screw with your baseline test data. Remember, they're trying to get a good baseline for this. Basically, understand exactly what the vehicle's doing and then compare all other flights to this first flight to learn things. But this has to be a good bench test. Introducing variables into your bench test like that is something that you really don't want to do unless you absolutely have to. So when I say, the batteries are up there, that was kind of misleading on my part. It's not just as simple as sending a guy up there and changing the batteries. Yeah, of course they could do that. But, yeah, once again, what if that guy trips? What if he trips and bends a wire? What if he trips and breaks something? What if he stands on the foam up there in the forward skirt and cracks it? Foam cracks on vehicles that this vehicle is derived from haven't ended well in the past. You could be introducing a failure mode. You're not supposed to have anybody up there. You're going to need to get the service gantries. And if you want the service gantries to do the job right, that means you have to roll back to the VAB. But NASA doesn't want to do that either for the same exact reason, ironically. Rolling the vehicle back to the pad rolling SLS back and forth from the pad was never supposed to do that. An ideal SLS launch would be building SLS in the VAB, rolling it out to the pad, putting it down, fill it up with fuel, put people on it, send it, right? That's the ideal scenario. How far is this thing from that? Now, don't get me wrong. They've taken that into account with this core stage. They've taken that into account that this core stage was going to be proverbially put through the ringer. This core stage was assembled in Louisiana. It was tested in Mississippi. It went back to Louisiana. They refurbished it. Then they sent it to the Cape, and then they stacked it on the Cape, and it's done multiple tanking tests down at the Cape, including the one you see right now. This core stage is overbuilt comparatively to the other stages because it was designed to do that. It was designed to be used a lot because it's the test mule, right? Now, it was only intended to be tested so much. Basically, after doing all that stuff that I just said, NASA and Boeing have basically tried to get this thing to be in as close of a configuration as possible to what an SLS core would look like being assembled in Louisiana, shipped to the Cape, stacked on the VAB, and put out on the pad. They're trying to emulate that data analysis, what the vehicle would look like in that scenario. They're trying to emulate that as much as possible. And rolling back to the VAB too many times with this core, even though it's overbuilt, could give you out-of-family data analysis, or an out-of-family baseline analysis, which means that it could still work, but it's not going to tell you exactly what you tried to figure out how the vehicle would be if you launched it, if you just put it on the pad and launched it, right? This is already obviously way away from that. If they roll back to the VAB again, it could put the vehicle into a mode that doesn't match their original data analysis.
You're looking at a live picture of the
and that's not going to give you good data. That's junk data. That's useless.
39B.
That's why they don't want to roll back.
Communications, we have an update now.
Simultaneously, they don't want to send a guy up there with a cherry picker.
Where to go from here. As you can see on your screen, we've been tracking the progress of tanking the core stage of the SLS rocket. It has two tanks, a liquid oxygen and a liquid hydrogen tank. They have completed tanking the liquid oxygen side, as you can see. It's at 100%, and they are currently in replenish. Over in the liquid hydrogen side, it's been a little bit of a bumpy road this morning. Currently at 67% full, but they've been managing a leak at an 8-inch quick disconnect line that feeds right there into the rocket. In between two plates that disconnect when T0 arrives and the rocket lifts off, those umbilicals pull away, and there's a cavity in there where that connection point is. That is where the leak was detected around this 8-inch QD line, which also had a leak and was repaired after a scrub attempt on September 3rd. The team discussing with the launch director the plan to go forward from here, and here's where they settled. They want to gradually increase the storage tank pressure, which will increase the pressure on this quick disconnect as well. It also increases the flow, getting it hopefully to the fast fill flow that would be nominal for a launch attempt.
It's
That's
an
the ultimate
isolated
goal.
system on purpose.
She has signed off. Charlie Blackwell Thompson, launch director here, has signed off on a plan to slowly step up and increase the storage tank pressure, which will increase the flow through that line right there. And as that flow increases, they want to keep track, I should say, of the leak at that QD interface. Right now, it has been tracking well with increases and decreases in pressure. They have been able to manage it quite well. It reached a maximum of 3.5% when they did the kickstart bleed, which raised the pressure on the tank as they vented liquid hydrogen through the engines to pre-chill them for what would be a startup of those engines. This is something that they're testing today and a test objective with this cryogenic demonstration. They flowed that through there, and then they ended the kickstart bleed, and now they're on a vented bleed. The conversation about whether to go forward after they reach replenish on the hydrogen side came to an agreement between the launch director and her launch team to go ahead and stop at replenish and then discuss whether they want to take the next step, which would be to move forward with a pre-press test. This is yet another test objective for the demonstration today. And that's the pressurization of the tank to get a high flow bleed going, which puts it in the condition to start up. They're going to pause at that point once they reach replenish and decide whether or not to move forward. But right now they want to see how this leak tracks with an increase in pressure at the storage tank. So that's where we're at right now. Launch team is in agreement. They want, launch director wants the liquid hydrogen team to keep a close eye on this leak, as they have been. And if it gets to a point where it goes over 4% for more than 5 minutes, the team has been advised to stop flowing.
They're in fast fill. They just did what Daryl's saying. Look at how quick that number is going up.
So again, to summarize, the liquid hydrogen team is gradually increasing pressure on the fill rate going into the liquid hydrogen tank, which is currently at 70%. They are tracking now the leak rate as well. And the plan is to keep going as long as that leak holds at a steady rate all the way up to replenish, which is at the 99%, 100% mark. Once they've got it completely full, and then
see how fast
the fill rate goes
gradually
into
getting
a
quicker.
mode
The
where
ticks are
it
coming
only
in faster.
replaces the amount of hydrogen that is lost from the natural boil-off of propellant inside the tank. As it vents out, they will only replace what is lost. That is the definition of the replenish. So get it up to 100%, and then get it into replenish, and then have further discussions about where to go next. We started this cryogenic operation at 7:30 a.m. Eastern Time this morning with a go for cryogenic tanking. The liquid oxygen side proceeded nominally, which in engineering speak is as good as you can expect it. Not so again on the hydrogen side. They encountered a leak. They stop flowed, warmed it up, reinitiated flow, and then noticed that they're able to manage a leak on where they believe the quick disconnect of an 8-inch fill line goes into the seal at the fill plate right there on the rocket. And that's our update for now. This is Artemis Launch Control.
Rocket right there. Oh my goodness, that just looks, dude. That looks aesthetic as hell, man. That's amazing. Oh wow, that's a great picture. Also, photobomb in the background. So what they're doing now, guys, is they are in a fast fill. but they're in a fast fill with the lower tank pressures. What do I mean tank pressure? I mean the fuel tank that's sitting over there off the left side of the screen that holds the hydrogen before they put it into the rocket. They changed the tank pressure to get the hydrogen seal on the fill-up point, the tail surface mast umbilical carrier plate. They lowered the tank pressure to get that to seal correctly.
One more quick note I want to add. The launch team is currently on hold for the loading of the upper stage. Again, preparations to load the upper stage of the rocket, the interim cryogenic propulsion stage, which is above the line where you see the top of the booster there, and there's a good shot of it. The ICPS where the inner tank shrinks down, the upper stage of the rocket, which will give that big push to the moon.
Yeah, T-Man, I know.
The plan today is to tank that, but at the moment, that is on hold.
So, they're in fast fill, but they're in a fast fill with the ground service equipment, or GSE hydrogen tank, at a lower pressure. So, this was because it's at a lower pressure, the fast fill, the flow rate of the fast fill is not as high. What they're going to try to do now, just for the sake of continuity, for testing, is they're going to try to bring that pressure up so they can get back to the flow rates that were originally planned for fast filling. They want to do that, and they want to see if that causes the leak to happen again. If it causes too much hydrogen to leak. The reason why they're doing that is they're basically troubleshooting. They're basically trying to figure out what's causing that hydrogen leak. Is it too much pressure? Is it tank pressure? Did they not get the pressures right? Is it not exact? Is it the seal? Is it the design of the seal? Who knows? I don't think it's the design of the seal because it's working just fine right now. I think it's more correlative with pressures, that reads pretty consistently for hydrogen. Hydrogen does do that. Even if you get the pressure off by a couple of PSI, it's going to leak. That's the difference between it leaking too much and it not leaking at all. Yeah, really annoying. It is rocket science. That's right. Astral, I'll tell you, if they repress, if they heat up the hydrogen GSE tank, if they heat it up and it doesn't leak, oh, we are golden, man. We are golden. They'll adjust the GLS to take the different pressures into account for slow fill, and oh man, that means we're good to go. If this last test works how they think it's going to work, if the result is what they're expecting, I would be very, very inclined to say that 27th is going to at least be a launch attempt. What's the big gray object? What do you mean, hammer smashing? This truss structure to the side, that's called a launch umbilical tower, or LUT for short.
Discovery.
Amongst other things, it has an elevator so people can get up into the top of the rocket where the capsule is up at the top. What that thing carries is fire suppression systems. It carries heat, venting, and air conditioning. So it carries all the HVAC systems for the rocket because you got to keep the rocket cool. It baking out there in the Florida sun is not good for it. That's what those white pipes are. That's HVAC ducting. And this big gray thing right there is the elevator shaft. But the launch umbilical tower is in a building. It's basically a skyscraper in skeleton form. The reason why is because when the rocket goes off, there's going to be a lot of gases that are expanding really, really fast and really, really hot right here. You don't want a flat surface because it could literally the rocket could blow the launch umbilical tower off of the pad. You do not want to know how they figured that one out. Not with a rocket this big, but it definitely does happen. So it's basically a hollowed out skyscraper. And that one right there is about 350 feet tall. Actually, it's more than that. It's probably closer to 400 feet tall. That's a 40-story building for everybody else. I know, I've walked on that thing. I've been at the top level. It's high. Yeah, it's way up there. I kind of actually do want to know that. Well, Teflon back in the day when they're launching Redstone rockets and stuff, they kept stuff near it and it kept blowing it over. That's how they know. Redstone rockets, bumper rockets, snark rockets. Yeah, they learned real quick that a lot of gases are being expanded really, really quickly at the back of a rocket engine causes really crazy pressure shifts. That's why launch pads don't have a lot of things around them. And the things that are around them are either armored up to be able to withstand that blast or allow the blast to go right through it like the launch umbilical tower. Hey, Dak, what's going on? Tanking is going very well. Yes. GLS, ground launch sequencer, Clayton. More interesting question is why the tower is not cylindrical. Because the space frame system was probably cheaper. Is that what you were referring to, Hammer, when you said what's the big gray object? Did I answer that okay? The launch umbilical tower also has the fuel lines for the upper stage. That's also important. What's the GLS again? Ground Launch Sequencer. It's the computer that controls the sequencing of events pretty much up until it hands over to the auto sequencer. The auto sequencer is the flight computer on SLS. The ground launch sequencer is the computers that control the pad. GLS hands over to the auto sequencer pretty much right before launch. We go for auto sequencer start. Onboard computers have primary control of all critical functions. You've heard that before if you've watched shuttle launches. That big gray thing. Oh, this thing. That's the tail service mast umbilical. That thing, this big gray thing is called a tail service mast, or a TSM for short. The tail service mast is the housing for the tail service mast umbilical. That's this thing right here. The tail service mast umbilical is attached to the tail service mast carrier umbilical plate, which is that white thing right there. See that thing right there? What does all this do? It's the fuel lines. Yeah, it's the fuel lines. See, they're flowing fuel. They stop flowing liquid oxygen, but they're in replenish, so it's trickling liquid oxygen in. But they are flowing hydrogen in fast fill right now. The hydrogen and the oxygen that they are flowing is flowing through. Well, you kind of can't see them here, but up on top of this plate right there, there's a huge pipe, and that's where the hydrogen is going. It's the fuel lines, because you got to remember, it's not just fuel. Oxidizer as well. Why? Well, why oxidizer as well? Why don't they just use the air? Well, there's no air in space, so you have to bring the oxygen with you. And it's easier to bring it as a liquid. It's more stable as a liquid. Well, not more stable. You could get it you can get more oxygen into a smaller area when it's in liquid form. That's not even really true either. It's just liquid oxygen is probably easier to handle. Yeah, Aldezert. Well, they're not trickling hydrogen. Hydrogen is in fast fill. Oxygen is not. But yeah, so the tail service mast right here. The tail service mast is a shield. Here. I can sit here and I can explain what it does all day, all right? Or I could just show you this. Watch. So, tail service mast umbilical, tail service mast carrier umbilical plate. Okay, watch. I could sit here and be like, oh, is this what it is? Just watch this. It's a housing for it to get it away from the rocket, because when the rocket launches, it gets really hot. It gets a little hot in this area here. You don't want this complicated umbilical thing near this when it goes off. So that thing is basically a system of pulleys and counterweights and pivots to get that umbilical away from the rocket as quick as possible. Less cool than the shuttle one, but not bad. Yeah, the shuttle ones were kind of a linear movement instead of a rotational movement. The shuttle ones just pulled back, right? It's the same design. It's just with a pivoting thing instead of a pullback. Oh, neat, Forge. Hey, B-Money. How's the house treating you these days? Getting all settled in? I'm working on it. Who asked me to see the last public? What's up, dude? I know you don't like TikTok, but I saw this for City's vanilla parking lots and thought you would be interested. Oh, okay. Interesting. Yeah, okay. Last test they scrubbed because it was leaking too much. Now they're trying to get it so it doesn't leak at all. No. They're trying to get the leak rate at an acceptable level, Badger, and it is at acceptable levels right now. Hydrogen is always going to leak. But I thought it was the degree to which it leaked. Yes, you thought right. It's not. They're not trying to not get it leak at all. They're trying to put it into a fast fill configuration that's more that's more in line with what they originally wanted it to do. Basically, they're trying to figure if dropping the pressure seated the seal correctly, and they can flow hydrogen at the fast fill rate, which looks like that's what's going on. It is filling up pretty dang fast. They're basically testing to see if dropping the tank pressure is what seated that seal correctly, or if the flow rate is the reason why it's not leaking. Does that make sense? What are the two lines coming from the external tank to the SRBs? Those are struts that hold the external tank in place. It holds the SRBs to the external tank. Yeah, they're struts that hold. Burb. Yeah, public, I got you. Yeah, no, that's not a bad idea. I didn't even realize there was a city's TikTok. That's weird. And if I remember correctly, they do have lights inside of the TSM. The shuttle ones, yeah, they probably have something similar to in this one as well. The SpaceX chill down the RP1 when loading it. To an extent, Hinks, yeah. Yeah, I mean, Hinks, you got to remember the liquid oxygen line on Falcon 9 goes through the RP1 tank, so it is chilled a little bit. Yeah, absolutely. You don't want to chill down the RP1 too much, Hinks, because then, yeah, see, this is oil. Well, not oil. This is petroleum stuff. So heating up oil tends to make it thinner, and cooling oil tends to make it like sludge. And the reason why I say oil is because RP1 is not that far off. It is a petroleum. It's the same thing. Same thing happens with gasoline. Same thing happens with diesel fuel, RP1 kerosene. It gets sludgy if you cool it. You don't want to cool it down too much because then you'll gum up the fuel system. Rocket Lab stream starts in 17 minutes. Yep. Yeah, Mycon. Yeah. Hydrogen is really cold, dude. There's a reason why this is hard to do. How do you get a seal to seal correctly when it's 400 degrees below freezing, or well, 450 degrees below freezing for Fahrenheit? It's minus 271 C for hydrogen. And minus 193 C for oxygen. Yeah, how do you get it to not be brittle? How do you get it to seal correctly? It's difficult, man. But they got it. They got it working, which is excellent. And they chilled the engines, which is even better. Yeah, A4D, isn't that crazy? Give the seal more fur, obviously. No, different seal. Different seal. That's biology. Yeah, okay. Yeah, Astral. Unbelievable. New crack. Interesting, Forge, yeah. Yeah, fellas, don't whisper me links, please. Please don't do that. Please, I beg you, don't do that. Don't circumvent the link terms, that stuff that I have in chat. I wonder what the squares are on the access covers. The checkerboards that you see, Blark Twitch, on there are for instrumentation. Basically, when they film the vehicle launching, so when camera 8 sees SLS go off the pad, what they can do is they can use video to use 3D located points or located points on the film to see the correlation between the SRB and the core stage kind of moving around. That's why all these checkerboards are here. They're there to make sure that the vehicle, like if the SRBs are like wobbling around, because interesting thing that happens here. So check this out. I know that seems like kind of hard to understand. Look at this picture. This was from one of the wet dress rehearsals. Now look at the checkerboard. See what I'm talking about? You can see how the vehicle's moving around by measuring the distances between these points. And from there, you can see what the dynamics that are being introduced to the vehicle. You can see how it's flying, basically.
Eastern time here at the Kennedy Space Center in Florida. The pretty nice
they have a ton of cameras on this thing.
We are currently
to be absolutely sure. You got to know. You got to understand what you made. It's very important.
Hour 6, I should say. It was 5.5 hours into the cryogenic demonstration test for Artemis 1.
What did they do to make it move like that? Filled it up. SLS is only structurally sound when it's fully fueled. Yeah.
Objectives today were to.
So when they fueled it with hydrogen, it contracted, and then it actually became rigid and moved the struts into position.
Oxygen,
yeah, cool, huh?
Hydrogen. The ones inside that core stage, though, the bottom part of it, are massive.
It's
largest
the propellants,
in the world,
man. The whole thing gets really cold when you introduce hydrogen to it. It's minus 400 degrees.
Started
yeah,
at
of course it
7:30
contracts.
a.m. this morning with liquid oxygen. That currently is 100% full. And over on the core stage liquid hydrogen side,
they're made out of metal,
95%
metal and ceramic. Oh, man, we're almost there. We're almost there. Come on.
That we track with our real-time graphics.
Cairo, it's working.
We encountered an issue.
I may have jinxed
right
myself.
Around 10 a.m. this morning with the liquid hydrogen loading. There was a leak detected.
Right after
and that resulted in a stop flow.
Oh, no.
Of the loading on the liquid hydrogen side. It was a pretty significant leak at the time. Engineers then talked it over, went to their pre-planned procedure with a small twist, and that was to lower the pressure on the storage vessel for the liquid hydrogen and then ease back into it after they allowed the quick disconnect line,
That's
which
correct, BD.
is right through there.
Pending range approval,
those
targeting
umbilicals,
27.
those umbilicals feed the fuel lines right into the rocket. That's where the leak was detected. It went to 7% concentration of hydrogen, and that created a stop flow. They allowed that line to warm up after they purged it out, and then they reinitiated the fill. They resumed the fill into the rocket, and at that point, ever since then, and engineers don't exactly know why, but it has been a manageable leak, reaching only a maximum percentage of 3.4% as they raised the pressure back up to resume fill. And that's where we stand. Engineers are wanting to understand more about how this seal
hydrogen always
is
leaks,
acting.
Hammer. Above 4% of total hydrogen being flowed in. If they lose
pressure.
4%, if they lose more than 4% of it, that's an unacceptable leak
and
rate.
So far, ever since that they resumed fill, they haven't had a.
They were showing gallon in Fahrenheit.
The leak is still there, but they are.
Salty. The vehicle is engineered in metric. Most things in the U.S. are engineered in metric. The thing is that NASA has to be transparent about what they do to U.S. taxpayers. And what system do U.S. taxpayers understand the most? Look, you could sit here, you could be like, oh, as a European, I don't understand the metric. The metric's better. Yeah, I've heard all that before. But yeah, you got to remember, this isn't about you. It's about getting people involved with space. And if we get those people involved in space by showing them units of measurement that they understand, they'll learn that metric is the better system. All right? And metric is better for engineering. I mean, personally, I don't care. I don't care what it is. You can sit there and say that metric is better all you want. And you'd probably be right. But 12.7 millimeters is always going to be a half inch. It does. I don't care what you think. I don't care what you say. It's always going to be that. So whatever. It really comes down to the application. And the material science is finite. Measuring system, it doesn't matter with the engineering if you really want my honest opinion. And I know some people, that think that, oh, I got you, EJ. What about that one mission where they didn't use the same measuring system? Well, yeah, that's a project management problem if you really want to know. Yeah, that's a project management problem. Measuring system has nothing to do with it, despite what you want to think. That doesn't mean nothing. I don't care about the measuring system. It's about what works, okay? And that might sometimes feet and inches and fractions might be a better way to do it. There might be a better way to quantify it because stress and tolerance and stuff is kind of agnostic to measuring system. But you guys don't want to hear that because, well, our system is easier. I get it. I get it. Thanks for that. It's in gallons. Deal with it. Yep, they're tanking right now. They're almost full. Vol, they're almost full. Yeah, Mickey, that's actually a good point. I didn't really consider that. Mm-hmm. What happens after this test? They'll detank the vehicle and they'll start getting ready for a launch campaign pending range approval on the 27th. It might be worth it to back up a few minutes.
And this, okay. The next milestone beyond replenish would be to pre-press the tank.
I knew this already, Moto. He already mentioned that.
And this would bring the tank to flight pressures.
So do I, Sparks.
Increasing the pressure both inside the tank and on that QD where the leak is. And so engineers plan to talk about the data that they've gathered through the course of this tanking and to decide a path forward. But at the moment, the upper stage is currently on hold. The tanking of the upper stage currently on hold.
A lot, Platinum. Yeah.
And this is Artemis Launch Control.
Okay. Yeah, Moto, that isn't anything we didn't know.
Fast fill is complete, and they've gone into replenish, which
That's
this is a
really
mode
good
where
news, dudes.
The valves are only opened enough to fill what is lost.
No,
boil off.
It's tanked, Val. They had a leak, but they implemented a fix, and it worked.
Liquid hydrogen.
They got the seat to seal.
Interesting
She's
data
full
to
fuel.
pass along.
Literally, like right, she just came in, they just filled it.
That during the fast fill operation, where the storage tank was at full pressure for loading the liquid hydrogen, the leak rate was less than 0.5%.
Very good. Very good. Very good.
Right around 0.5% leak rate, which is very manageable for the team here.
That's for tank pressurized fast fill. That's really good. That's good news. That means that seal is working exactly as we want.
Leaving a lot of folks scratching their heads on this one. But they're going to have some conversations on this particular seal and how it's been behaving up until this point, and discuss
yes, LJ.
Discuss a path forward now that we are in replenish. This is Artemis Launch Control.
Anything under 4% is good. 7% is what they had when they tried to flow it this morning, Clayton. But that slow fill seems to have really seeded that seal in a way that it likes, and they got almost no leaks. Once again, now's the time to implement that fix. This is the time to change this. They replaced it, Journey. Yeah. Oh, hello? Hey, Bells? Are they going to do another full wet dress rehearsal, or will they stop at some point? They don't need to. They've proven that the systems have worked, oh boy. That seal was just one of the last, really was one of the last things, sealing the engine bleed. And from what I can understand from what Daryl is saying, the Clark Kent looking dude that keeps popping in and commentating, they're going to press the tank for flight to be absolutely sure that they're basically they tried one way and the seal didn't work. And then they tried another way and the seal worked. So now what they're doing is they're checking all the other ways, all the other procedures that they had that have to do with liquid hydrogen right now to make sure that their implemented change of dropping the GSE tank pressure during the second fill attempt caused that seal to work correctly. If they put the seal into a configuration where it worked, they want to make sure that what they changed is what made it work. So that's why they slow filled it, they got it to seal, and then they switched to low pressure fast fill, because the whole implemented test was using low pressure inside of the GSE fuel tank, the fuel tank that's on the pad, not on the rocket. So they did low pressure fast fill, and then they switched to high pressure fast fill, and the fill rate never got above 0.5%. The leak rate never got above 0.5%. 4% is out of family. That's no good. It never went above 0.5. That's what Daryl just said. So what NASA's doing now is they put it in replenish mode and they're monitoring the leak rate now. And then they're just going to go through all the other things that they have to do with liquid hydrogen to get the vehicle to launch to make sure that that implemented fix of dropping the tank pressure to get the seal to seat correctly is not going to screw up anything else. It's smart. It's good engineering. It's good beta testing, to be honest with you. 0.5% means they still lost 4,000 gallons of hydrogen. Physics do be like that, human. Didn't this happen last time? The seal worked during a test, and when it came to launch, then it had a problem, so technically it could happen again? No, Superbot, not technically at all. It won't happen again because they didn't do the exact same thing that they did before. They've changed the sequences. They've changed the procedures to make sure, to mitigate that based off of what they learned. NASA isn't insane. They're not going to do the same thing over and over again, hoping that it's going to change. They've implemented different flow. I'm blanking on the word. Procedures. They implemented different flow procedures to try and see if the seal would work this time, and it didn't work. And then they changed another thing, and then it did work. Now they're cross-checking all the other procedures, all the other procedures that have to do with hydrogen, bleeding the engines, pressing the tank for flight, slow fill, fast fill, replenish mode. They're checking to make sure that seal doesn't come unseated and making sure that their implemented change is what fixed it. That's why Daryl keeps saying that they're a little confused, because I don't think NASA was expecting that to work. But even at this point, even with NASA, you're going to learn something new every day. Now you got to prove that that's what's going on, and you got to understand that. That's the hard part, man. That's when they always say, oh, we're going to review the data. That's what that means.
Welcome back to the Kennedy Space Center for those watching on NASA's public television channel. We're at the Kennedy Space Center.
Except they already did a test fire. Next step is sending the thing, dude.
In the Artemis 1 cryogenic demonstration test for tanking.
Oh, that's cool. Too bad about a Fanatec DD2, Tessa.
Preparations are being made to tank the upper stage of the rocket.
So say we can only fill the thing so many times. Does it have to be fully filled as it filled? They only fill it 20%.
Next steps now. Please stand by.
Why would you want to fill the rocket to 20%, goalie? Ken, what's going on? Are they going to detank after this and go back to the VAB, or is a launch attempt in the coming days? Detank, no rollback. Rollback chem is going to put the vehicle, could potentially put the vehicle in a bad baseline configuration to get good data. Basically, guys, Chem, listen up. I know you probably know this, but let me explain. That first core stage is over-engineered. Why is it over-engineered? Well, because they built it in Louisiana. They built the thing a lot stronger than what it needed to be, like way stronger. The reason why they did that is because they knew this core stage was going to be manhandled. It was going to be tested, fired, tested to its limits. Green run, the first green run didn't work, so they tested it again, and then second green run worked, and then they sent it out to Kennedy Space Center. They built it. They picked the thing up sideways and stacked it on the mobile launcher, and then they stacked it up. They put it on the rockets, and then they rolled it out to the pad. They did a wet dress rehearsal. Then they rolled it out to the pad again and did a second set of wet dress rehearsals. And then they took it back. Then they rolled it out again for the launch attempts. Basically, after all that manhandling, the vehicle, because it's overbuilt, right? Because this first core stage is super strong, where it's at right now, with all the metal fatigue and everything, all the dynamics that the vehicle has been put through, theoretically, and I say theoretically because we haven't tested, we haven't qualified it yet, should match the configuration of an SLS from an ideal rocket launch, meaning built in Louisiana, shipped to Kennedy Space Center in Florida, stacked on the pad, roll out to the pad, fueled, and launched. This thing, after all of this, the wet dress rehearsals that it's done, should match the configuration because it's overbuilt, but since it's been manhandled so much, it should be in about the same configuration as the Artemis 2 core stage, which would just be shipped to Kennedy and then stacked on the pad and then launched, presumably, right? Rolling back to the VAB is not something that NASA wants to do. They don't want to do that because that fatigues the core stage because it's bouncing around on the damn crawler transporter. There's no suspension there. It's crawler transporter is solid axle, right? So it'd be bouncing around and you're introducing vibrations to the vehicle. The vibrations could change the vehicle and basically put it in a potential failure mode that NASA hasn't taken into account. Long story short, a regular SLS launch is not designed to roll back and forth from the pad so much. But since they overbuilt core stage 1, right? All that manhandling around, now in the configuration that it's on the pad, is more likely what you'd see from future SLS missions. NASA does stuff like this on purpose. They take this stuff into account. You have to. It's so freaking important. Because the vehicle that gets put through its paces, green run, is not going to act the same way that a vehicle that you just built, put it on the pad, sent it, one and done. Those vehicles aren't going to act the same. No way. They could be similar, but they're never going to, the telemetry will never be exact. Because the sequence of events leading to that launch is completely different. You're introducing much more dynamic conditions into core stage 1, which is why core stage 1 is overbuilt. That's really important to understand. That's a really big engineering principle to understand there. Penta, they had a leak this morning, but everything is going fine now. The next step here is to press the tanks for flight. So, yeah, guys, hopefully that makes sense. NASA does not want to roll this thing back because it'll screw with their baseline testing data. Because they did all this math and everything to make sure that this core stage could get manhandled, and by the time it's actually ready to go to launch, it'll be in a similar configuration to an SLS that has just been manufactured, rolled to the pad, and then launched. Right? Dude, you don't know how much math and how much data analysis you need to do to get to do that high fidelity of a simulation, and to have it be correlative up until this point is frankly absurd. It's correlative enough to know that NASA knows that rolling back to the pad could screw with your baseline test data. That's how intimately familiar they are with the dynamics of this vehicle. That's impressive. That is impressive. That's borderline predicting the future. Unbelievable. Can you imagine what it takes to be able to predict how the dynamic conditions a vehicle is going to go through by being test fired and then taken off the test stand and then refurbished and then moving to the pad and doing a wet dress rehearsal and rolling to the pad, etc., 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 etc. That's ridiculous. How that's so much number crunching. It's absurd. It's literally using math and engineering to predict the future. That's bananas. This is why even though NASA, hasn't launched anything in a little while, this is why they still frick, man. They still can get down. That's ridiculously good engineering, So that means that this data cannot be used in Artemis 2. No, Chief, that's literally the opposite of what I said. If they roll back again, it could potentially screw with the baseline testing setup. Long story short, they took into account Core Stage 1's testing regime. And right now, it's in a configuration that would be similar to Artemis 2. And that will give them a good baseline test. Remember, this test is about continuity of systems. It's a beta test for the vehicle. And if you put this vehicle into a configuration, so you sit around on the pad screwing with it, right, and hitting all the buttons and doing all this other stuff, right, and you're not going to do that every launch, right? But this one was designed to be able to be manhandled like that and have it basically be a test mule. It's overbuilt for that purpose.
Go at throttle up.
They did the same thing with the space shuttle, guys. Columbia was always heavier than Discovery, Atlantis, and Endeavour. Or Challenger, Discovery, Atlantis, and Endeavour. Columbia was always heavier because they had to overbuild it because they weren't sure if it was going to work the first time because they knew it would have to be tested a lot. And based off of that good baseline data that Columbia got from STS 1, 2, 3, and 4, they were able to build a much lighter, much more efficient orbiter. And that's Challenger. And then all subsequent designs for space shuttles, Discovery, Atlantis, and Endeavour, are based off of Challenger. They have more in common with Challenger than they do with Columbia. Enterprise and Columbia are like Shuttle 1.0. Challenger, Discovery, Atlantis, and Endeavour are Shuttle 1.1. That make any sense? They're doing the same thing with this. That's SLS Core Stage 1.0. Core Stage 2 is like Core Stage 1.1. And it'll just get better from here. The more they launch, the bigger that data set gets, the better. Enterprise is like 0.9. Technically, 0.9 is Challenger. Technically, Snickers. But yes, I understand what you're saying. You're absolutely right. So Artemis 2 will be brought to the pad and then set to this configuration. Chief, set to this configuration doesn't. It's more like Core Stage 1 is overbuilt, so after all the testing that it's been done, it right now it's more in a configuration that you'd see from Artemis 2. Remember, they're trying to baseline. That's so important. They're trying to baseline it. You can't baseline it with a rocket where you did all this stuff to it that you didn't take into account, right? So if I have a Formula 1 car, right? If I have a Formula 1 car and I want to do good testing, but I drive that Formula 1 car on a rally track, is that good testing? Why? Because, well, Formula 1 cars aren't really designed to drive in dirt, now are they? You want to make sure you test as you fly, right? So you would want to test it on a Formula 1 track, ideally, right? But you have to do the testing somehow, and maybe at some point you need to make sure that it can perform well in dirt. You would take that into account, right? But your configuration should match the race conditions that you see on the track. NASA is, with all that testing with that core stage, they overbuilt it. They took into account that they were gonna drive it on dirt, basically. I mean, rocks, if you want to be technical, but they took that into account, and after all the testing, it much more matches the metal fatigue and flight configurations that Artemis 2 would find by just being built and then rolled to the pad and then launched. That's so important to get a baseline data set. It's so important. Yeah, it didn't really work too well, did it, Tessa? How's testing going? The rocket is fully tanked, Thrawn. The next thing they're going to do is a hydrogen tank press for flight. They're going to press for flight to make sure that their implemented fix is working correctly throughout all procedures that have to do with liquid hydrogen. They've already bled the engines. Engine bleed was good. Honestly, this thing is primed and ready to go. If they started up the ground launch sequencer, they could launch, but they're not going to do that. The range would get a little pissed off if they did that. It's looking dark on the NSF stream. Yeah. Yeah, clouds do come in. But yeah, does that make sense about configurations? Cam, I know you got it, right? So bigger upper stage is already taken into consideration. Correct. Yep. Oh, yeah. Chief, they spent 10 years crunching these numbers. Let me put it to you like this. It better frickin' be. It better be. If they haven't taken into account at this point, we're screwed. Am I right? Am I right? We're screwed. No, yeah, of course they took it into account. They took into account that SLS is scalable. You can give it a bigger upper stage. You can give it better SRBs. That was all taken into account in their initial data analysis. This is why this stuff takes so freaking long. You know? Could they test the actual quick disconnect operation? Deadscum, there's no point in testing the quick disconnect operation. They already did that. They already did that right here. They did it inside of the VAB a couple of months ago. If you really want to know, watch. They know that that works. Click. Yeah, they already know that works. No need to test it. It's already been tested. If it got hit by lightning, would it explode? No. No, it wouldn't. There are these big honking lightning towers that are way taller than the launch vehicle. Those are there to make sure that that doesn't happen. There's 3 big lightning towers that are like 600 feet tall, or about the size of like a 60-story building, to make sure that that thing never gets hit by lightning. Yeah, because I'll be honest with you, Colma, I don't know what would happen if lightning hit SLS, but I can assure you nothing good would happen. Why? Well, even if lightning strikes it and it doesn't seemingly do anything on the outside, who knows what that thing fried on the inside? You're introducing a bad configuration. You're introducing what's called a failure mode. A failure mode is when you're unsure if the vehicle is going to work or not. That's really important. I don't know. Striking lightning? If lightning hit the vehicle, is that going to mess with it? I don't know. We haven't tested for that. So it's an unknown. You're increasing risk of failure doing that. Dude, if lightning hit the vehicle right now, I can guarantee you the best case scenario would be rolling back to the pad and completely disassembling every component on the rocket to make sure that nothing got damaged. Worst case scenarios, yeah, I don't know, it could blow up. Who knows? Don't know. Didn't Apollo mission get hit by lightning in flight? Apollo 12 did. That's why we have what's called the surface electric field rule. Yeah, surface electric field rule. Basically, they don't want to launch the rocket in a scenario where the rocket could become a lightning rod. They don't want to induce the lightning. It's the surface electric field rule with weather constraints for launching. Apollo 12 lifted off, and about 10 seconds after it lifted off, lightning hit the top of the launch escape system, and believe it or not, it arced down the plume. The rocket plume was conductive, and it arced down the plume and grounded out on the pad and momentarily shorted out all the systems on Apollo 12. While the thing was flying into space, I might add. Yeah. Yeah. Basically, the inside of the Apollo command service module, the control panels of the command service module turned into a laser light show. Yeah, literally like that. If you listen to the footage, the astronauts are like, we got a problem here. What just happened? I don't know. And what happened after that is the ECOM in mission control, the electrical systems manager, a guy by the name of John Aaron, had seen this pattern before, believe it or not, in the simulator, and told them to switch to the auxiliary batteries, and it worked. And then Apollo 12 went up into space and landed on the moon, and then came home. Let me see, Thomas. Oh, very nice.
Stand by.
Yeah, well, Jonas, the flux capacitor didn't activate because Apollo 12 didn't travel through time. So, no, I don't think it got hit with 1.21 gigawatts. So that's why the weather, the space meteorologists, or the meteorologists that are in charge of monitoring whether you should or shouldn't launch, right?
Okay, we're getting some good news from the
have the surface
liquid
electric
hydrogen
field
team
rule
in regards to the leak that they were looking at early on in this operation and loading the core stage. And that is the leak reversed its trend where previously when pressure increased, the leak increased. But now they are seeing a trend for this particular seal that when pressure increases, the leak decreases. This is, as engineers say, the way that it's designed and intended to work so that it conforms to the area that is sealing, that quick disconnect connection point for the liquid hydrogen line. And so now both tanks in the core stage are in replenish and are stable. Next up is loading the upper stage of the rocket. And right now, teams are conditioning the areas around the engine to prepare them for loading liquid oxygen and hydrogen. And the team's discussing
they'll use this configuration creeper with the low GSE tank pressure, and it will work again. If it doesn't, I'm going to be a little confused.
One of the main test objectives,
physics doesn't lie. Physics don't change.
Do a pre-press test on the liquid hydrogen tank in the core stage after they get the upper stage into replenish. And this will put a fair amount of pressure on that connection right there that you see there, which is the umbilicals. They contain the LH2 8-inch line that we've been talking about, but is now sealing pretty well. The pre-press test is a test where they pressurize the core stage tank by closing the vent, which prevents the boil-off gas from escaping. And then more pressure is added with helium to get to the tank to flight pressure for engine start. This is an important moment to reach. You have to have those engines conditioned at the right temperature in order to start them up, those RS-25 engines, which are just below this point right here. And then once they get it to that point, there's a control loop that cyclically pressurizes the tank, opening the vent valve, which then controls the temperature around those engines, saturating those engines with liquid hydrogen so that they are at the right temperature to start them up and launch. Of course, today is a test. It's a cryogenic demonstration test.
This isn't a wet dress rehearsal. There's no countdown. This is a tanking
test. Leak has been repaired from the previous launch grub.
But they have
to go through some test objectives which haven't been met in previous launch attempts or wet dress rehearsals.
They have fixed
so the team is
all the issues that they encountered in the wet dress rehearsals and the launch attempts.
Once this pre-press test is completed, they won't have to do it again.
Until launch.
Once validated, the launch team will be able to adjust the pressure during the high-flow liquid hydrogen engine bleed inside of terminal count. That's the final 10 minutes of count. And that's when it's critical to have those RS-25 engines that you see right there at the bottom.
Yeah, Mike, I noticed that.
Four of them.
If they don't think it's a problem, I don't think it's a problem. I don't know why it's different.
So the situation taking a very positive turn here today as the launch team is pushing forward with loading the upper stage and moving to the next milestone, which is the pre-press test.
The camera number under? This is camera E8.
Those RS-25 engines that you're looking at right there, they are known as staged combustion cycle engines. They burn liquid hydrogen and liquid oxygen propellants at a very high pressure.
Look at you, Darryl.
At full throttle, the 4 engines will give SLS about 2 million of its 8.8 million pounds of maximum thrust. Those SLS engines start in a staggered fashion. First engine 1, then engine 3, then engine 4, and then engine 2.
Sequenced ignition.
And they start up approximately 6 seconds before booster ignition. And during ascent, those engines can gimbal or pivoted to direct the thrust and steer the rocket. To learn more about the Artemis 1 mission and the SLS, and go to our website at nasa.gov/Artemis. Again, the website is nasa.gov/Artemis.
Yeah, Joe, me too, man.
This is Artemis Launch Control.
All right. All right, guys. The Rocket Lab thing is going on, but I kind of want to stick with SLS. I don't know. What do you want to do? Rocket Lab hasn't started yet. SLS muted in the corner. Well, the problem is if it's muted, you can't tell what's going on by the pictures, drummer. You know what I'm saying? Why not launch it like right now? Because you don't have permission. Yeah, LJ, I think we'll do that. I think I'll move SLS over to my second screen here. And we'll unmute over there. And then we'll see what's going on with the with that Rocket Lab thing. The neutron. Okay. Nope, that's Launchpad. Rocket Lab has an Investor Day presentation where they're going to talk about their new rocket that they're working on. Okay. I don't see the stream. It's green, Micon. Yeah. You got it, Core? Thank you. Stream is all about the leaks. Nope. You could get 1,000 leaks every day, chat. Make sure this is one of them. Brother, I have the entire presentation in PDF if you want to. Yeah, that would be nice, Forge, but I honestly don't like having the Investor Day presentation spoiled for me, if you really want my honest opinion. I can't why it either. It's going to be pretty cool. How much time has passed from the actual start of this mission to actual liftoff on the 27th? Well, liftoff on the 27th is the start of the mission, Valiant. Thanks for ruining the surprise. Yeah, Forge, I mean, I don't know. Like, I'd prefer for them to tell me. Oh, okay. Unless SLS leaks really bad, we won't see it, so might as well watch Rocket Lab. Nothing really to watch on SLS. I want the audio, JDG, so I have the audio cut in. If Daryl starts talking, we're going to hear it. Oh, I mean from the actual start. Oh, SLS basically came around and was finalized and, you know, like, basically when they said we're going to build this in 2014. And Valiant, I know what people are going to say. Oh, 2014. 2014 to 2022. 8 years? Oh, wow, it takes that long? Yeah. Yeah. I mean, that's what happens when you don't give NASA the money it needs to make the rocket that it wants to make. If you give them more money, they'd get it done faster. And people say, oh, I read on an article somewhere that SLS it's too expensive because some bonehead on the internet said that. Yep. Sure. Of course it is. If you look at like the development of like Saturn V, the development of the space shuttle, N1, Buran, Energia, anything like that, that 8 years reads pretty dang right for a super heavy launch vehicle. agnostic of country or financial system or anything. Look at SpaceX with Starship. Starship came about really 2016 with BFR or ITS, and then it became BFR, and then it became Starship, and we're looking at an orbital flight test sometime late 2022, 2016 to 2022. That tracks. It's about right. SpaceX does things a little bit faster than everybody else. And SpaceX ain't going to tell you how much they spent on Starship, but I assure you it's probably up there in terms of expense with SLS. Yeah, way up there. Yeah, Raptor development, long lead propulsion development started in 2015, which is basically on par with SLS in terms of track. So, yeah, I mean, it has taken a long time, Valiant, but it's in terms of cost and everything else, I'll say that that's pretty on par comparatively to past designs and price tags. Actually, believe it or not, SLS is way cheaper. It was always going to be way cheaper than like a Saturn V, for instance. You know why? It uses the Saturn V's pads and integration building, right? Uses the integration building. When the Apollo program started, where Complex 39 was literally a swamp. So Saturn V was always going to be more expensive. SLS uses the VAB, and it uses Michoud, and it uses Stennis, it uses the test stands, all the infrastructure that was built for the Saturn V. It's always going to be cheaper because that infrastructure didn't need to be built this time around. Right? Interesting to think about. So even though SLS carries that, it seemingly carries this ridiculously high price tag, that tracks. It tracks with how expensive it is to send somebody to the moon. Now, how do we fix that problem? Flying more is the answer to that. Fixing the problem. Flying more will fix that problem. Because you built all this stuff out, you built all these things that you need to do to make SLS good, build more of them. We spent billions of dollars, building launch pads and, retooling factories and building more rocket engines. Let's actually use all of that, please, for a change, and not do what we did during the Apollo program, which is build out a multi-billion-dollar lunar exploration program and then use none of it. See what I'm saying? SLS tracks, dude. Tracks and timeline and funding. It's pretty spot on, actually. I know people don't like hearing that, but sorry. I wish they would have continued the shuttle program. Stopping space exploration was a huge mistake. Now, Valiant, I will 130% agree with you on that one. Absolutely. Stopping the shuttle program and canceling Constellation at the same time was, for NASA's human exploration, probably on par with one of the dumbest things NASA has had to do. Yeah. That's right up there with canceling the Apollo program. Yeah, it's... Oh, believe me. Yeah, I agree with you. They should have kept flying the shuttle until Dragon was good to go. But, we couldn't do that. Couldn't do that, could we? Mike, you feel like SLS is moving backwards. Back to the Saturn V days. I can't imagine traveling in that Orion capsule to Mars unless they develop something in space that's waiting to dock with more room for the astronauts to venture around. Mike, that's exactly what they're doing. You're not flying with Orion all the way to Mars. No. Yeah, no. They're going to make transfer vehicles. Nuclear-powered transfer vehicles, if you really want to know. And before you say, EJ, how do you know that? EJ, come on, man. How could you possibly know? How could you possibly know what NASA's going to do? Well, one, they don't exactly make it a secret. Two, I know who they're paying to make that happen. It's not necessarily Lockheed, but also Lockheed wouldn't be putting out tweets about nuclear-powered stages if they weren't sure that they could make money off of them. And I don't think the military needs nuclear-powered stages. That doesn't really read too well for the kind of things that the Department of Defense wants. Also, that's definitely Mars, so this is definitely NASA stuff. And look, interesting thing, Lockheed made the Orion capsule. The thing that a lot of people don't know about the Orion capsule is that the Orion capsule has future-proofed systems designed into it to be able to attach itself to other components and be able to control those components from the capsule. It has a modular software and hardware design built into it because it's designed to attached to a larger transfer vehicle, right? It's designed to go further. That was built in from the start. That's capability that Orion has basically right now. Now, on top of being able to just dock, right? Like, think about it like this. Dragon can dock to the ISS. Can Dragon control what the ISS does from the flight deck of Dragon? No, it absolutely can't. Dragon can't turn the ISS to solar panels. That's a totally different system. The only thing that Dragon does is pressurize, and then it has an electrical connection to keep the systems on Dragon powered while they shut the batteries down on the capsule. I mean, it's a little more complicated than that. There are other things. Long story short, Dragon can't control what the ISS is doing. It can't control the ISS's thrusters, for instance. Orion has that capability built in from the start. Look at this picture that Lockheed has. The Orion capsule can become the bridge of a much bigger transfer vehicle. And that is built-in capability right from the start. Pretty crazy, right? So you're absolutely right. Orion cannot go... We're not going to go in Orion all the way to Mars. No, we're not doing that. What we are going to do is get an Orion up there with a nuclear-powered transfer stage, and Orion linked to a HAB module that goes with it, most likely. And Orion can control this entire spacecraft from the bridge of the capsule. Pretty crazy, right? What's that thing on the top right? That's the Mars Ascent and Descent Vehicle, MADV for short. Lockheed is proposing it as a way. It's a Mars SSTO, basically. Yeah. We going to Mars in the Ares 1 rocket? No. Does that make sense, Mike? Crazy for sure. Interesting. Long story short, dude, they've thought about this, because you're absolutely right. We ain't going to Mars in a damn capsule. Orion's life support systems with 4 people aboard last 21 days. It takes 2 months on a good day. If the wind is blowing in the right direction, it takes 2 months. Depends on the energy of the transfer. Depends on how big of a rocket you make. But yeah, they have plans, dude. Lockheed wouldn't be going and dangling this around here if they didn't think they could make money off of it. You know what I'm saying? This is basically a tweet that, you know, hey, look, NASA. No crap. Oh, word. Hi, Lucky. Sweet, I never noticed that. That's pretty cool.
Just gave the go for
they're dangling this NASA saying, look what you could do with the Orion capsule, right? Am I right?
Liquid hydrogen. Again, they just gave the go to load the upper stage with liquid hydrogen and liquid oxygen. This comes just after completion of the purge sequence. They purge out any contaminants from
I never noticed that, guys.
Engine. That's the
straight
engine
up.
Of the ICPS, the upper
That's
stage
pretty neat.
Towards the top of the
I'm
rocket.
saying some right stuff for them to do that. Jeez.
For pushing Orion into its destination, the translunar injection towards the moon.
Supercraft. That's an idea I can get behind. Wait, did we open up for nuclear reactors in space again? Yeah, it's part of the 2017 Transitional NASA Authorization Act, new bits. They reactivated the NERVA program in 2017, 2018. The U.S. Department of Energy is working with several companies to redevelop. I say redevelop because we had the capability and we said, man, never mind. We don't need to use this in the 60s. That's good. To redevelop the capability to use nuclear thermal propulsion. Yeah, and nuclear reactors for power generation. Yeah, that potentially opens up the possibility of having a nuclear reactor at whatever moon base we make. That would be useful. That'd be kind of neat. I kind of want that. Okay, Forge, that's cool. About damn time. Yeah, no, I'm dead on with you, dude. I'm dead on with you, man. About damn time. It's been 50 years. Damn it. And I've only been here for half of that. you know, for half of that 50-year wait, actually a little more than half, but you get the idea. Some people have been here for 2/3 of that wait. Some people have been here. Some people have watched the stream were around and remember the Apollo program. Remember people landing on the moon. You imagine what they feel like. Don't forget, DARPA has a nuclear thermal propulsion program. Yep. You dang whippersnapper. Dang whippersnappers. But yeah, guys, trust me. NASA has some righteous stuff planned. Like, we're picking up where if everything goes right, we're going to pick up right where the Apollo program left off in December of 1972. We're going to pick up right where they left off. And man, I really hope we get there. If I recall correctly, original nerve was stopped because of nuclear test ban treaties. That and they defunded NASA at the same time, Hellfish. It's more defunding NASA, but also that, yeah.
The LH2 main propulsion system chill down is in work. The LH2 main propulsion system
yeah,
in the
I hate
upper
it, Nina.
stage
Don't worry.
is now in work.
Okay, they're tanking hydrogen in the upper stage for SLS. Still waiting on that Rocket Lab presentation here. Have you seen the Rocket Lab updates? I'm waiting on them. I know there's a PDF floating around, dude, but yeah, I'm waiting. But how about the Van Allen belts, Asimalock? What about them? They could just go around them. That's what they did during the Apollo program. Rocket Lab just terminated the stream link. No live. What is that? Our sincerest apologies, folks. We've run into technical difficulties with the webcast and will not be going live for Investor Day. We'll run a live Twitter thread and share a recording of today's events on our website later in the day. All right, Forge, link me the PDF now. All right, I will bring SLS back up onto the center screen then, because we're watching a tanking test, baby. Tanking test, baby. But yeah, hopefully that helps you guys kind of see what NASA has planned with the architecture. And once again, if I get a little rowdy when I'm talking about this stuff. I don't know if you've noticed. I just want to be clear that that's just me. Like, we gotta do this, you know. That's just me being a little passionate about it. You're gonna have to excuse me if I get a little intense, you know what I mean? Flash the crazy eyes from time to time, dude, you know. But yeah, for the newer viewers, yeah, dude, I'm really into this. This is kind of my thing, you know. Been waiting a long time for this, man. Please go to the moon, please. Full PDF updated. All right, I will bring Artemis back up over there, and we will do this here. Mute that for the time being. I have it unmuted on the other computer, so you guys will hear it. All right, let's see what this presentation is about. Now, comparing to Starship, are they docking to something, then heading to Mars? Love the passion. Yeah, that's the idea. They're going to build a transfer vehicle in low Earth orbit, Mike, and then send something to Mars. All right, the Investor Day update. Peter Beck. Once again, I do have SLS up here. I will put that picture in picture here, actually. That's probably a good way to do it. There we go. Put that over there. Okay. They unfortunately aren't streaming it. What we said we would do: satellite manufacture, components, flight testing, launch sites, ground stations, launch services, on-orbit operations. Yeah, the space economy is expanding. Okay, I got it. World-class team. Small launch vehicle. Electron. Okay. Yeah, Electron's really mopping the floor with small sat launches, huh? Oh! Ho, ho. Ho, ho. Ho, 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 ho. Damn, that's messed up. That's freaking cold, man. Wow. Wow. They haven't even launched their rockets yet, man. All right, stop. Okay, damn. The leader in small sat launches. Advertised versus demonstrated lift capacity. Oh my goodness. The savagery. The savagery. Oh. 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 What are you doing? Stop it. Rapidly increased launch cadence. Rocket Lab has demonstrated the fastest turnaround between successful launches, 15 days. Astra is 115, and Virgin Orbit is 64. What? Why? Why? Rocket Lab chose violence today. Jeez. Emotional damage. Okay. Unrivaled launch infrastructure. Launch Complex 2. Look it. Dude, that thing is looking pretty legit. It burns out. Stop. He's already dead. They have gone full Blue Origin level of PR shade. Indeed, drummer. Oh my goodness.
Discovery, go at throttle up.
Yikes. Electron is shipped to LC2. Oh, there you go. All right, that's good. We still have audio over here, right? Yeah, okay, we do. Electron remains the go-to dedicated launcher. Here, I'm just gonna go full screen here. Send the urns. They got cremated. List of burn units. Launch Complex 2 has growing demand. So that's the launch site in Wallops Island, Virginia. It's next to Pad 0A at the Mid-Atlantic Regional Spaceport. See, there's 2 launch pads right there, right next to each other. Trusted launch provider of choice. Strong launch manifests. Yep. Electron has plenty of missions, including stuff for NASA. They've already launched. They launched technically the first Artemis mission, the Capstone mission, which is a lunar payload services mission. They're working on reusability via helicopter recovered Rutherford engine hot fire. That should be a video, but it's not embedded. All right. Strong negotiating power. Prestige worldwide. Investors? Maybe you! We've seen it. We've seen it. They basically have test-fired engines that have flown into space and that were recovered via helicopter. Or not via helicopter, via ocean, which is good. Everything that goes to space should have a Rocket Lab logo on it. That's their strategy, okay? Prestige, worldwide. Now leading spacecraft manufacturer. Suborbital, Jim, but yeah. Vertical integration acquisition strategy. Yep.
You're looking live at the Space Launch System rocket here at the Kennedy Space Center in Florida at Launch Complex 39B. Atop
go over here
is the Orion spacecraft. We are currently in the midst of the Artemis 1 cryogenic demonstration test. And so far, so good. We've got the first stage completely tanked and in replenish. It's in a stable mode. That was a good operation and some good engineering that we observed as they tanked this rocket.
Yeah.
Liquid hydrogen was tanked completely without any issue. The liquid hydrogen showed a leak, but then that leak managed to get to a point where engineers were able to manage it a lot better. It's reduced now. It's reversed its trend of increasing when pressure increases. And so now that leak is something that they have behind them at the moment. And so now they're proceeding on with the chilling down of the main propulsion systems in the upper stage. And we just got a note that the liquid oxygen is now in fast fill for the interim cryogenic propulsion stage. That's the upper stage of the rocket that you see right there.
Oh baby, this is very good news, guys. They got it.
Venting that you see is the liquid oxygen that vents out from the top of the tank there from the core stage. That's normal. With liquid oxygen in replenish, the boiling of the tank below must vent off the super cold gaseous oxygen, and so that's what's happening there. And as soon as that super chilled gaseous oxygen reaches the atmosphere, it condenses the water vapor in the air, and that's how you have that that plume there. So the plan is, once the upper stage is tanked and in replenish mode, the launch team wants to proceed on with an important milestone called the pre-press test. Stand by.
Yeah, Zero. I mean, the upper stage isn't full of fuel, but yeah, sure. You have a simple explanation for what replenish mode means. The propellants are boiling local. They boil off because they're really cold, stored at a really high pressure. So the propellants boil. And they don't want to overpressurize the tank, so they have to have a vent line. Now the hydrogen has the scavenging vent line that leads to a purge flame that's over there. The oxygen can just leak out, well, not leak, it could just vent out of a designated vent valve up there at the top. See it up there at the top of the core stage? Replenish is basically taking into account the boil of the propellants, and they're just topping off the propellants to make sure that the tanks stay full. That's all. If you just left SLS there, what would happen is the propellants would boil inside of the tank, and if the vent lines weren't open, they would overpress the tanks, and then, yeah, you don't want that. It makes sense. Oh, yeah, okay. How cold is liquid oxygen? Minus 293 Fahrenheit. I think. Yeah. About 100, minus 190 C.
A quick update from the launch team. The team reporting that they lost boot containment on the ICPS LH2 QD boot. That's the interim cryogenic propulsion stage, the upper stage. Quick disconnect that feeds the liquid hydrogen into the upper stage vehicle. This is something they've seen before. They went straight to their pre-plan. They're working that now.
Observed behavior, guys. No problem.
Not going to discuss this on the anomaly net. It's something that they expected, they've seen before, and they've got a pre-plan that they're going to work to get containment. Again, lost boot containment, which is the air that's contained inside the boot, where that hydrogen quick disconnect goes into the ICPS.
I'll show you guys a picture.
And they're
Give me
working
a second.
that.
So, here's a picture of SLS, right? So the leaks.
Otherwise, as the upper stage loading continues, the plan is once the upper stage is in replenish mode, they're going to proceed forward with a pre-press test of the core stage. The pre-press test is pressurizing the tank by closing the vent on the liquid hydrogen side to prevent the boil-off gas from escaping. And then they're going to get the engines into a high flow bleed. And that high flow bleed is important because it's triggered inside of terminal count when it's critical for the RS-25 engines to be the right temperature for launch. So that pre-press test is still ahead of the team, something they're looking forward to. It's a big milestone here and one of the main test objectives of the day.
So there's a rubber boot that goes over where the umbilical attaches right there.
The SLS rocket will launch an uncrewed Orion spacecraft from Launch Complex 39B.
It just came off.
If this test is successful,
that happens. It froze. It froze and contracted, and it popped off.
Launch Complex 39B,
it's observed
of course,
behavior.
is
It doesn't
NASA's
matter.
modernized spaceport at Kennedy.
Because they understand it. That's why it doesn't matter. I mean, it matters, but they understood the behavior, so that's the most important thing.
Once this rocket does launch, the Orion spacecraft will be sent into orbit around the Earth. It will deploy its solar arrays, and then the upper stage that we're fueling right now, the interim cryogenic propulsion stage, will give the Orion spacecraft at the top of the rocket the big push called a translunar injection needed to leave Earth's orbit and travel towards the moon.
Oh, that's going to be pretty
The stats
cool,
on the ICPS, on the LH2 side, it carries 10,000 pounds of liquid hydrogen. On the liquid oxygen, it's 53,000 pounds.
There's a tank in here.
Much smaller tanks than the core stage.
So once
If
again,
you'd like to learn more about
would you like to know more?
The ICPS and the Artemis mission, go to our website at nasa.gov/Artemis.
Or you could come to EJ Stream and learn a lot more about it.
/Artemis. This is Artemis Launch Control.
I'm doing my part. So you see this line right here, the one that has the rings on it? That's the hydrogen fill line for the ice. No, that might be the vent line. The fill line is this one right here, one with the gold foil on it. See that? That's the ICPS fill line. It goes into the bottom of the hydrogen tank. Hydrogen tank goes from here, the ICPS forward skirt, to the ICPS LVSA adapter, which is this thing, the cone-shaped thing. The liquid oxygen tank on an ICPS is actually hanging from the bottom. And when I say hanging, I mean it's not touching this orange thing. It's hanging from the from the ICPS adapter plate. It's just a bunch of struts that connect it to the hydrogen tank. It and the RL-10B2 engine are hanging inside of this. And they're hanging from that ring right there. That's why the liquid oxygen fill line is going in to the launch vehicle staging adapter, and that's attached to a line which is attached to the lock tank, which is right here.
And liquid oxygen on the upper stage of the Space Launch System rocket. Again, we are currently in fast fill for both tanks in the upper stage of the rocket. Good looking shot right there, looking down on the rocket.
What Chris said, Brandy,
is connected to the Orion spacecraft right there at the top of the rocket. And the propellant that's flowing through the umbilical lines right now is flowing at fast fill.
Okay, so the boot came off, but they're still in fast fill, which is good news. I'm going to go back to looking at the Rocket Lab presentation. Rocket Lab has a new satellite production facility with gantry cranes. Nice. It's going good, RJ. Yeah, fast fill on the second stage. They got the hydrogen to work on the first stage. First stage is fully topped off. They're trying to work on the second stage now. I want to see Neutron. Yeah, okay. Rocket Lab spacecraft delivered the first mission of NASA's Artemis program to return humans on the moon. That's the capstone mission. Rocket Lab is a complete mission solution. Yeah, this is not anything we didn't know. Yep. Yep, phasing burns. Yep, and then I was gonna say this is a bielliptical transfer. It's not really a bielliptical transfer. It's a 1, 2, 3, 4, 5, 6, 7, 8, 9, nine-fold elliptical transfer utilizing the Oberth effect to achieve translunar injection off of a low TWR, high delta V upper stage. When is the tanking expected? Right now, Cientic. They've been tanking it since 7 this morning. That thing says wallops in December. You think you'll be coming down? I'm going to try to. Yep. That Rocket Lab head looks like something out of mission mode. Yeah. Rocket Lab's presentation, their streaming setup broke, Aqualux. Yeah. True story. We're looking at an investor PDF that came out, and we will see a recording of the presentation later. High complexity missions, satellite constellations. Basically, Rocket Lab is trying to set themselves up as the end-all be-all. You want to put a flashlight up into space. They have everything to basically get that flashlight up into space, power it, and keep it working for a long period of time, which is pretty smart. It's a one-stop shop with rockets.
Discovery, go at throttle up.
They didn't hire Das to do the webcast. That's why it failed. Syrian, 90-month resub, dude. Can you believe that? Okay. So, once again, fellas, if you're coming into the stream in the top right, up here, I have SLS. But I'm looking at a Rocket Lab PDF about updating for basically what they're doing. They were going to stream this, but the streaming setup broke. Hey, look, a decoupler. Yeah, there's a decoupler right there. If you wondered what they look like in real life, like you've seen decouplers in Kerbal, it's just a ring. That's what they look like in real life. Been a hot minute since I did that. Yeah. Do phasing orbits work well in Kerbal? Yeah, of course. Sure they do, GUI. Guys, did you know that they did helicopter on Mars? Yeah, Aqualex, one-stop shop. Yeah, it's pretty smart. And they're actually doing it too, which is cool. See, they're doing everything. GNC, electrical control, power generation, decouplers, rocket engines, rocket launch, rocket pads. Here we go. New rocket development. This is what I wanted to see. Mega Constellation launcher. It's happening. Real hardware is in manufacture for the Neutron rocket. That's a chicken. Or turkey. Now I'm hungry. Dang it, Peter Beck. That's Astra. The goose is cooked. Oh no! Don't say that. Neutron is coming to life. That's a guy with a stick. Yeah, I was supposed to get food 2 hours ago. He did not want to eat a hat again. Yeah, that's probably right. The first Neutron... Holy crap. Look at that, guys. A toroidal carbon fiber tank. Whoa. That's a big donut. I'm calling Duncan. We need to get that up here, guy. We're building it. We're experts at 3D printing rocket engines, and we know how to scale. Full-scale parts coming through our production lines using in-house 3D printing machines. I want it. I want that in my shop. I want it. It's a laser sinter aluminum 3D printer. I want it. Please give me the... Oh, look at that turbo pump housing. I want it. 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 It's... Looks like a CBH, not a full tank. Yeah, maybe. A design led by market demand. Neutron, 15 tons in expendable, 13 tons in reusable, 8 tons to return, 8-ton payload capacity to return the pad. It's 42 meters tall, or about 140 feet, about the equivalent of a 14-story building. 5 meter fairing diameter. Ooh. 16.4 foot fairing diameter. It can go to low Earth orbit, medium Earth orbit, geostationary orbit, or interplanetary. First stage and fairing are reusable. It's using a methyl LOX engine, LOX and methane. 9 engines in the first stage, 1 single engine in the second stage, carbon composite. Yeah, I know, Alex, right? Confirms downrange landing. Yep. Yeah, see, a lot of people say, like, oh, why doesn't Falcon 9 just open and close the fairings and then reuse it? Well, Rocket Lab's doing that. Captive fairing. Fairing remains attached to the first stage, opening to deploy the second stage and payload within. It enables rapid relaunching, eliminates the high cost of expending or capturing and reusing fairings. They just pissing in everybody's cornflakes today. Intergalactic, land of jelly, intergalactic. Those are the lyrics, right? Intergalactic, planetary, intergalactic. The noise gate doesn't pick up on the beatboxing. They did wake up and chose violence. Man, somebody really lit a fire on under their tail, man. Jeez. Iterated design. From 4 fairing panels to 2 reduces the amount of angle the fairing must open and enables more robust fairing panels. Does history repeat itself or what? That's okay. First stage major design complete. Oh my god. I miss the Beastie Boys. Yeah, me too. It does. Oh no. No, it absolutely does. Funny, funny how it's easy to do odd-shaped composite tanks nowadays. It's almost like strange tank shapes shouldn't be an excuse to refuse revisiting innovative launch techniques anymore. Yeah, I know. Funny how that works. It's almost like 20 years ago they proved that worked. Why you gotta go remind me of that, man? What the Oh, okay. They added modified strakes on the side for cross range. Yep. No. Not a capsule announcement, but we're looking into it. Not a capsule announcement, but we're looking into it. Second stage major design is complete. Yep. Forward load reactor. They hang the second stage inside of this. So basically, neutron from about here up is totally hollow. And then the front fairings open and close, right? And the second stage just hangs inside of the first stage. It just hangs in there. And then when they release it and it just flies out the fairing with the payload attached to it. That's a load reactor. That's if you hang your second stage like that, it's called a load reactor. And a load reactor basically makes it so your second stage does not need to be structural because it's not holding up anything. It's being held up. The only thing that it's designed, the only structural loads that this thing needs to be put on it is the structural load induced from when this rocket engine fires and the payload compresses the tanks. Hanging the second stage allows you to save a ton of mass. I'm surprised not as many people do it. Rockets building robots. Robots. Yes, look at this fancy robot that is designed to weave like a spider. That's great. Thank you. Archimedes engine update. Breathing first fire this year. 9 of them in the first stage, minimum throttle 50%. Sea level thrust 165,000 pounds. 3.29 seconds specific impulse in the vacuum. Stage 2, Archimedes engine, 200,000 pounds of thrust. Min throttle 50, vacuum ISP 367. That's because of the expansion ratio, but yeah. The Archimedes engine, simplicity where it matters. Open cycle rocket engine. Okay, there's your gap, okay. And then oxidizer-rich closed cycle. Provides higher specific impulse than gas generator. Hey, we were talking about this earlier today. It's pretty good, Tesla. Yeah, it's not bad. Tessa, it very well might just be hanging in there. The second stage might just be held in by a pilot dowel, and that's about it. You know, if your engines are firing, they open the fairing, they hit main engine cutoff, you don't need a separator. It'll just yeep right out. Yeah, well, Tim has worked with them before, hasn't he? Hello, Sean. Don't you dare dangle that in front of me. Don't you dare. Why would you show that? That's the J2X test stand. The J2X motor for the Constellation program that they canceled. That's the A3 test stand at Stennis. That still pisses me off. Keep reading. Secured engine test site. Oh, they're using it! Yes! Yes! Oh, that just made me very happy. Do you think it was them that bought the J2? You know what? Maybe. I don't know. Oh, my gosh. Oh, they're using the J2X test stand. So, guys, okay. The A3 test stand was built for the Constellation program to test J2 engines. J2 engines are second stage engines. Second stage engines are hard to test down here because, well, second stage engines are designed to work in the vacuum, and if you go outside, there is in fact no vacuum out there. So you need a specialized test stand to test upper stage engines, or you're going to test them without the nozzle. That is a vacuum test chamber rocket test stand. You can fire a rocket engine inside of a vacuum chamber. How do they do it? With science, okay? It was built for the Constellation program, and then they canceled it midway through construction, and the contractor actually ended up suing NASA for reneging on the contract, and then they built it anyway. It was completed in 2014, if you really want to know. About 3 years after they canceled the Constellation program, and it's been literally sitting there doing nothing. A state-of-the-art vacuum rocket engine upper stage vacuum testing chamber has been sitting there doing nothing since. Guess who's footing the maintenance bill? Yeah, another reason why canceling Constellation was an idiotic idea. They're waiting for you, EJ, in the A3 test chamber. Oh, we don't want a resonance cascade pig's egg. We are maintaining it, though, right? Yeah, of course. Where did SpaceX test their vacuum engines, then? They test them at McGregor Drummer, but they don't have a nozzle on them. Yeah, Aqualex, the rocket engine, exactly. The rocket engine maintains the vacuum because there's a venturi at the intake. Yep, and it pinches it off and makes low pressure around the rocket engine. Yep. The rocket engine creates the vacuum, A4. Yeah, pretty cool, huh? Secured engine testing site. Stennis A3 test stand to test the Archimedes engines. Oh my gosh, that's so cool. Oh my gosh. Dude, I thought this test stand was never going to do anything. Oh. Exclusive use of land with a 1 million square foot area for 10 years with an option for an additional 10 years. Access to capital investment incentive from the Mississippi Development Authority. Yep. The Neutron Factory. That's right next to the launch pad. The Wallops launch pads are right there. That's the entrance to Wallops Island. The press site is right there. Whoa. There was a farm there. I guess it ain't there no more. I guess they bought it. Isn't that the one that they spent $2 billion on to refurbish, then finished it after the J2X was canceled? They didn't refurbish it. It's a clean sheet design, Hellfish. Yeah. What in the absolute... I muted the mic, sorry, because I just cursed. But... RJ, it is my damn design. We theorized that that's my damn design. That's my damn design. You're freaking right. It's a mission mode pad. It's a drone ship. The drone ship moors right by the pad. And then this must have a bridge crane in it. They roll it all the way out here. They pick the rocket up, they bring it back, they set it on the pad, move the assembly building over it, integrate the payload, and send it. Also a land landing pad over there. Zoom, please. Okay. I don't understand. What do you want me to see? That's Minotaur's launch pad right there, by the way. So we know where... I can tell you exactly on Google Earth where this is getting made. It's very smart, eliminating the need for a port. So that's up here. We got to go up to Virginia. Hey, Maverick, I want to believe. Yeah, me too, man. Let's see, there's Chincoteague Island right there. There's Wallops. So the factory is right where that farm was. That's where the factory is. And then you can see the Minotaur launch pad there, which is south here. There's Antares. Electron is right there. And there's the Minotaur launch pad. See that? See the circle with the thing kind of looks like an omega almost? That's in the render. It's right there. So that means this pad is going right there. This whole thing is going to end up right there. Wow. That's pretty damn impressive. It still is a farm. They're raising rockets. Yep, Rocket Ranch. Yeah. They're working with the Space Force and Transcom. That's nothing we didn't know. Upcoming major milestones. They're up to pre-burner testing. Building out the factory. LC3. 1 and 2 test sites. Wow. This is till the end of next year. Hardware in the loop facility operational. Wow. They're going to get Neutron going sooner rather than later. Okay. That's the financial stuff. That's pretty good too. Wow.
Discovery, go at throttle up.
Booster 7 is released from the sticks. About a quarter way down the rocket and yawing open. Crash, 60-month resub. 5 years, you gotta be kidding. Where's the time gone? I don't know, man. I don't know. One was made by Hoki. They could use a cargo ship dock crane for getting stages in. Yep. Yeah, you could. That's what a bridge crane is, fellas. Yeah, that's what a bridge crane is supposed to do. That's where they got the idea. At least I'm pretty sure. It also could have been from oil rigs. Full release about the factory. Rocket Lab selects Virginia for the Neutron manufacturing site. 250 jobs to Wallops Island. Yeah, that factory is going to be down the street from the launch pads. Across the Causeway Bridge. So that's the press site right there. This is the press site for Wallops. And the factory is going literally on that plot of land. They bought a space right next to the gate for the Wallops Island launch facility. That's I know, Reagan.
Quick update on the cryo loading for the upper stage. We are still in fast fill for both LH2 and liquid oxygen. Again, we are in fast fill for both tanks in the upper stage of the Space Launch System.
Yep, see the vents on the ICPS?
We got about 20 minutes left, it looks like, for upper stage loading. And then the team will
presentation didn't happen. Their streaming system
starting the next milestone, which is the pre-press test of the core stage.
Assuming the EUS is going to use the same fuel as the ICPS, right? Yeah, of course. The Hydrolox. Yep. RJ, the hydrogen is the best for expendable upper stages. It could possibly be good for reusable upper stages too, but that has yet to be proven. If you're going to go with something that's reusable, methane is probably a little bit of a better idea just because it's a little bit more stable and it favors reusability, right? That doesn't mean you can't reuse hydrolox stages. You know what I'm saying? Any questions you want me to send along to my colleague who's there at Investor Day? I ended up not going into the city, but a coworker did. Actually, yeah, I do have a question. I don't have a question about the A3 test stand. That really is awesome that they're using X Constellation hardware. That's really cool. That makes me absurdly happy. My question, and I don't really have a question about the factory or anything. That's actually pretty cool. I know the pad is literally right there. You can see it. It's math related to science. Nice try, Katie. Yeah, the pad is literally over there. You can see it in this picture. I don't have any questions about that. I have a question about this. Does your integration building just pick the rocket up off of the drone ship? If so, how? How are you going to move this back to there? Open the fairing? That's pretty crazy, dude. That's pretty crazy that ends up looking exactly like a mission mode build. That looks like our bridge crane for mission mode. A crane that can extend. So they're gonna need a bridge crane or something. But yeah, it's ridiculous. Wait, I just got back. Is this a Wallops thing? Rocket Lab is using Wallops as the launch site for their new rocket called Neutron, dude. Yeah. They're building out insane architecture. They're building the factory right next to the Wallops gate. What about not having a costly barge? Yeah. We're most of the way to the reusable Hydrolox rocket, but we canceled the program. Yeah, I know. It's interesting. It's got to be a mobile bridge crane. How else are they going to get the rocket off? There has to be a crane that extends out here, like a shipping container crane or something. Somebody already suggested that, but yeah. How will the integration facility retrieve vessels from the drone ship? Yes. Yep. Acton, that's my question. Wallops is closer to you than the Cape? Yeah. Yeah. Less than halfway. Less than half the distance. So Wallops is right here, right where my mouse cursor is. And if we're plotting a straight line, I was going to use Boston, but I don't live there anymore. We're plotting a straight line. It's about 380 miles. I can get there if we time it right, so we go through New York and Philadelphia at night. I can get there in 6 6 hours, 6 to 7 hours, 8 if we hit traffic. Tessa, the Cape. Here, that doesn't really plot that correctly. Here, let's do something like this. Let's just make that kind of trace 95. It's 440 miles. I can get there about 7, 8 hours depending on traffic. Right? The Cape is, gotta go down 95. Cape's about 1,200 miles away. Yeah, it's about 1,200 miles away. And actually, that way would be slower. That takes about 20 hours. Yeah, it takes about 20. I know because I've made that drive before. I went to college in Orlando. The fastest I've ever done it is about 20 hours. And that's obeying all the traffic laws. $95 is about 75 miles west of where you put it in Virginia. Laugh out loud. Yeah, I know. That's what I just said. Yeah, I know. You weren't listening though. You could also take this way. There's that bridge that they made, JDG. That one right there. Remember that thing? You could take that way, but that way is slower. 95 goes over here, and then it goes through Richmond, and then goes down this way. It goes around the Outer Banks. I know where it goes. Booking a flight to see one of these launches. We don't launch such heavy stuff from Sweden. Yeah. I lived in Norfolk. It's all bridge and tunnels. You're a bridge and tunnel. Slower but nicer. Yeah, John, I appreciate that drive. This is a beautiful part of the country. Really, it is. Especially this kind of strip of land right here. Beautiful. It is. It's very pretty. This is where Das and I did plane spotting that one time. Easy to fly from Boston to Orlando. Hard to fly from Boston to Wallops, though. Yeah. I grew up over there just off 13 in southern Delaware. Hi. I'm in Delaware. Neat. Don't you go past... Isn't Dover over here? Dover Downs? The NASCAR... Yeah, the track's over here. Nope. Proposed general agreement of factory. Yeah, okay. Oh, okay, Creeper. Yeah, I got you. Let me finish this thought here. Yeah, there's the track. Cool. Yeah, last time I drove down to Wallops, I drove right past it and went, racetrack. Also, ooh. Hey. Hello, babe. So ending a stream a little early, one day drive to launch, stream, launch, return 2 days over at the truck is pretty feasible. Yeah, yes it is. You know what else is feasible? You shutting up. Got him. Right now they're in ICPS fast fill. We don't have any word back from them yet. That's some really awesome stuff from Rocket Lab though. That's yeah, I could see why you guys were hyped up about that. That's really, really cool. Yoigles, they did fast fill on the hydrogen tank and the steel worked. They're tanking the ICPS right now. Once again, this is the SLS tanking test. You're going to have to get a wiggle on with that shop upgrade so you can start working on the mobile streaming truck, dude. Next time you go through Dover, the AMC Museum? Air Mobility Command Museum. That is a very nice selection of stuff. Yeah, drummer, I'd love to. I thought you'd approve. Yeah, of course, John. Don't forget that thing that you linked. You want me to see this. Answer, no concrete indication on how they'll remove it, but the conceptual drawings seem to indicate a solution like that. Yeah, oh. All right, Acton. Cool. Oh, they're going to make a custom entrance into Wallops, huh? Let me see if there's any infrastructure over there. Yeah, they're going to have a Wallops Flight Facility, WFF. Yep, they're going to put a gate right here, and the gate's going to go that way. Everything worked with SLS so far. Yarg, they had a leak to start the day, and then they stopped, and then they changed the pressure inside of the GSE hydrogen tank, and they slow filled at a much lower pressure than what was originally planned, and then the seal worked as intended. Yep. They switched to slow fill. The thing didn't leak. I mean, it leaked a little bit during slow fill. That's supposed to happen, though. And then they initiated fast fill with the GSE tank at low pressure. The leak rate went down to 0.5. And then they repressurized the tank. And they did full high pressure, fast flow of hydrogen. 0.5% leak rate. Thing working as intended. Worked perfectly. They bled the engines while they were fast filling. Worked perfectly. Now they're tanking the ICPS, and the ICPS is in fast fill. And to conclude the test, they're going to do a full tank press for flight. Yep, to make sure that doesn't screw with the seals at all. They're basically doing all the procedures that are in the ground launch sequencer that have to do with hydrogen that could potentially affect that seal to make sure that it's working correctly. So yeah, we started the day with a little bit of a hiccup, but everything else has gone completely 100% according to plan since then. Yeah, it just has to seat correctly. Guys, the reason why I'm doing this is I'm stretching my back out just in case anybody's wondering. Yep. That feels good. I got a herniated disc in my back. Okay. Fun fact about Wallops area, there's restricted airspace on both sides of Route 13. The corridor you have to fly through is like 3 miles wide. One side is rocket launches, the other side is NAS, Patuxent Rivers Playground. Yep. Yeah, you're talking about like right here. Push out a fart pose. Sorry. Pax River is where they did a lot of dev work on the F-35. Really? Wouldn't have guessed, man. The last time I drove through there, it looked like the place was abandoned. It's interesting because Rocket Lab is building an electron facility over here. Appearances can be deceiving. Yeah, it must be really stealth, huh? Now, what do you got over here? P3, C-130 with no engines, and looks like a concrete company. Oh, there's the tracking station. And I know what that's used for. Pax River is a big installation. It's interesting considering they have two abandoned runways. And then they practice carrier landings from what I can tell. Yeah, Alex, yeah. When I drove through here, it didn't look like there was much going on. I have the Mustang. I had the Mustang down here, up in here. Yeah, didn't look like there was much happening. It looked like an abandoned base. It looked like it got bracked. But, yeah, clearly that's not the case. Clearly that's not what's going on. So, yeah, I guess I'll just shut the frick up, you know? That's what I'd do if I didn't know what I was talking about. I'd shut the frick up. Shut the frick up! Oh, also, that gas station is amazing, by the way. You're ever down in Wallops? That gas station's awesome. That one, right there. Yeah, there's like a huge supermarket in there. Also gas. That wasn't PAX, that was Wallops Base. That's Wallops Airfield, that's not PAX. Oh. Well, that makes a lot more sense. They're operating in stealth mode. Yep, go west over the bay. Yeah, see, this looks a lot less abandoned. Yeah, considering that that's there, and there's C-130s that actually have engines on them. Oh, look at that basin in there. Ooh. Oh, we do much at PAX, oh yeah? What's that doing there? You fell for the decoy. Ah, decoy my vans. It looks like a lot of electronic warfare from what I can tell here. Considering that, I'm pretty sure that was what is it, an EC-135? No. That's I think that's an EC-135. I think that's what it's called, but I could be wrong. Ah, yeah. Yeah. Good to be a nerd. I thought the EC ones always had a big disc on top. That's not an E6, guys. That's not a Sentry. That is an EC-135. Differences. Big difference. Namely the dish. The E6 is an airborne warning and control system, or an AWACS for short. That's not an AWACS. That's electronic situational awareness. Differences. Big difference. Yeah, E3 Sentry. E3, not E6. Sorry. My bad. But yeah, that's not the same. USN Takamo. Boomer talk. Yeah. Interdasting. Here, I'm going to bring SLS back up over here so people don't get confuzzled. Is there an E4B there? Nah. I don't think so. I haven't seen one. Couple of SH-60s right there. It looks like this was used for a lot of seaplane stuff. There's 2 seaplane basins right here. Oh, I bet you that golf course is really good. Ah, it's probably a good golf course. That looks like a really good track. What are we doing over here? If I recall correctly, it was a seaplane base. Yep. Yeah, that's what it looks like. Yeah, see, this is a lot less abandoned than the other one. Yeah, see, they're even building new stuff. I worked at that northern basin. Oh, no crap, Gil. That's cool, man. Another EC-135. What the heck are you boys up to in there? You know what? I don't want to know. Never mind. F-14, A-6, F-18s, more F-18s, and then another A-6. What the heck's an A-6? What are you doing with A-6s? You know what? I probably don't want to know. It's probably above my pay grade. Sorry, I keep asking questions. Probably shouldn't be doing that. A4, T-38 maybe. OH-6. Oh yeah. No, this place is toe up, man. They do, yeah, this is definitely active. There's a lot, they're doing a lot of work in there. If it's a military base, shouldn't it be hidden? What can you possibly discern from there just being a bunch of planes on a runway? Yeah, from what you guys tell, from what I'm seeing here, it looks like there's a lot of stuff that happens at this facility. Yeah, considering the EC-135s flying around, just doing whatever. Wow, that's a big facility. Holy crap, man. Yeah, it goes all the way over here. And then all the way over there. That's a big mother. Base use and activity levels, how important it is. Yeah, sure. This image date is from 2013. The imagery date is from 2013, Gameable. I'm pretty sure that's entirely on purpose. Did you ever see the Li-2 on Big Diomede? I don't know what that means, Eptoxin. It's also not far from the Naval Surface Warfare Center Annex. Yeah. 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 How have I never gone and looked at that thing? Down here. Hey, beautiful. How are you doing? Chat, there's 2 of them. Chat, there's 2 of them. There's 2 of them. Twins, Basil. Twins. An entire cheerleading squad. Nice. And if there are 2, there's surely more. No, the other ones are stealth, obviously. Test stands. Cool. Very nice. Oh. Oh. There's a lot of pickup trucks in there. There's even boats! What is this place? What is this magical place? I can't... That's an Air Force base, whatever it is. Those are all Air Force planes. Just thought you could use some sats to find car junkyards and search them. That would actually be a really cool idea, Newt, but yeah. Neat, I can see my house almost. The LI2. Oh, interesting. Cool. Did you see the Twitter thread about the NASA van up for auction? Yeah, I went to an RV parts seller, which just pisses me off, but it's alright. NASA is on that base you were looking at. That's pretty neat. We haven't really had an update with SLS in a little while. I wonder, could you tell what type of base it is? Army, Navy, Air Force, Marines, just by looking at the parking lot? I wonder if there's any statistical difference in preferred card types by branch. Yarg, what tends to happen with service members that make a lot of money that are very young is that they, no matter what branch, you usually see a lot of fast cars because, you know, when you're 19, 20, 21, you have more, and, you know, you're getting paid, you know. Yeah, you tend to have more money than brains. Dodge Charger, Challenger, Mustang, Camaros, yep. Or lifted pickup trucks, yeah. They buy high-interest V6 Mustangs, yep. Lots of poor financial decisions with 20+% interest. Yep, F-250s everywhere. U.S. Air Force bases have golf courses. Yeah, that's cool. Yeah, I mean, guys, yeah, every military base, at least in the U.S., is like a small town. There's supermarkets there. There's a golf course. There's a high school for kid, you know, elementary school, middle school, high school for, you know, service members, kids and stuff. There's like an officers club. There's all kinds of stuff, dude. It's actually really cool. I mean, I wouldn't know. I'm just a civilian, but I've been on bases before. There's all kinds of cool stuff. Many motorcycles, lifted jeeps. Yeah, turns out when you're 20 and make a ton of money by being a soldier, you
Discovery, go at throttle up.
You blow it on stupid stuff. The smart thing to do is when you're in, save cash. That's what everybody tells me. You save cash. You save as much as you possibly can, so when you get out, you can use your GI Bill to go to school and then buy a house. And then, you know, get a nice job, and then you have a house and a nice job, and then you make lots of money, and then you can blow it on stupid stuff. Ton of money, just don't have any bills. Yeah, but there's also that. Yeah, ton of cash. That really depends on pay grade now, doesn't it? Looks nice. It's not a ton of money. It's just a lot more money than most of those folks had before they signed up. Yeah, that's the better way to put that. Speaking of other things.
Top of the hour, 3
Oh.
p.m. Eastern Time. As you look
Top
at
of the
rocket-
hour,
3 p.m.
Ah,
Eastern Time. As you look at the top of the rocket
ah,
complex 39B. We're currently in the midst of a test to demonstrate the cryogenic loading of the world's most powerful rocket, the Space Launch System, the moon rocket that you see right there. Currently, you can see we are venting off liquid oxygen at the top of the rocket, venting both the core stage, which is fully tanked, and we're venting off the upper stage. If we go back to that upper stage shot, just want to point something out. You can see the venting from this wide shot, but as you look there, you see the two small plumes at the top. That's the vent for the liquid oxygen tank in the upper stage of the rocket. And currently, we've been loading liquid oxygen for about 54 minutes into the upper stage, and we're about half full. So a little less than an hour left to complete the final load in that. The upper stage LOX is a 53,000 pound tank, much smaller, but the flow that goes into the line is also not as fast as it is for the core stage. And then, of course, you see the plume in the lower, just below those upper plumes. That is the core stage liquid oxygen venting now. Just super cold gas condensing water in the atmosphere. That warm Florida air, which we're about 77% humidity. So lots to see there. And then you see the two small ones at the top venting out. Those are for the ICPS, the upper stage. Everything nominal and looking good there. In fact, there's a close-up shot of it. It's a great shot by our team here at NASA TV. And you can see the propellant lines that go into the ICPS. Those umbilicals pull away, of course, once we lift off the rocket. Today is a test, though, and a test only, going down to
the completion
Collins,
of a pre-press test on the core stage. They'll scavenge as much as they can, but a lot of it does boil off. But they can scavenge most of it. More than 2/3, I can say confidently.
Liquid hydrogen upper stage. That's about
just
a half
NASA's
hour
YouTube
left.
channel, Aqualux.
So we're looking good there. Everything proceeding nominally there so far for the upper stage. Just to recap on the lower stage, had a really smooth loading of the liquid oxygen tank on the core stage, but then on the liquid hydrogen, ran into a leak, had a stop flow. But then the engineering team warmed that line up.
For the most part,
in an attempt to reseal, reseat the hydrogen line that goes in and connects to a seal that's right against the flight plate there. They were able to get it,
turbo,
to get that leak to substantially reduce. And as they increased pressure, got it to the point where the leak started coming down, which is what they want to see.
Yep.
They've been managing that, and it's been all good from there. Tanked the entire.
They purge it out of a Bunsen burner.
Core stage, and now both of those tanks are in replenish. Got a little ice there at the bottom of the two nozzles that we can see. Actually, we can see three nozzles, 3 of the 4 nozzles of the RS-25 engines. A little ice formation, not a problem, say the engineers. That's all normal. While we're looking at the engines, just want to make a note, those engines, as part of the Boeing core stage, engines are designed by Aerojet Rocketdyne. And those engines have a history going back to the space shuttle program.
Oh, I don't want to hear this.
And just to name them off as you see them there, all the way to the left is engine 3, which has the 4-digit identifier 2058. Engine 3 was involved in 6 flights during the space shuttle program, and all 6 of them were flights to the International Space Station. Behind engine number 3 is engine number 4 with the 2060 4-digit identifier. Right, and 2060 was involved in 3 flights during the space shuttle program, including the last one, STS-135. Space Shuttle Atlantis, which launched from right here at the Kennedy Space Center in 2011. And then moving to the right in the foreground, that's engine number 2, 2056. It was involved in 4 space shuttle flights, including the Hubble Telescope Servicing Mission. Great mission that was. A lot of history there with that engine. And then last but not least, and not appearing in your picture, right behind engine number 2 is engine number 1, 2045. Engine number 1 was involved in 12 space shuttle flights, including John Glenn's flight, the late senator and astronaut. And it was also on
Can
the
I
final
punch the
space
person
shuttle
in the face
mission.
that decided to put that motor on there? Would anybody
Engine
frown
history
on
there.
me if I did that?
Thanks to the folks from Aerojet Rocketdyne for providing that information.
Like the other engines, I get, but the one that flew John Glenn, can
Weather turned
I
out to be good for today.
just
Really good
deliver
day.
one right to that
Tanking
guy's
had
suck
some
hole?
storms offshore, but those were of no consequence.
That guy doesn't
to
change his
loading
face, I'm gonna change
operation.
it
They
for
moved
him.
right past
Don't
that.
physical violence is wrong. Don't do that. But also,
You can see some clouds in the distance, even given some rain at this point, but launch weather officer is monitoring all of that. At this point, it's no impact.
the one that moved John Glenn, Sherry's,
green to
yeah,
proceed.
I would put that.
The next step is the pre-press test of the core stage liquid hydrogen tank.
Did John
That
Glenn
is the final test
only
of
fly
today's
once on the
tanking
shuttle? Only
mission.
once, Reagan, yeah. That was the second space
The
flight.
pre-press test will involve the pressurizing.
Yeah, that's right,
of the
Jim. I suppose
LH2 tank
there are
and-
2 other John Glenn engines, but I'm pretty sure those are set to be expended as well.
Bringing it up to flight levels.
We'll hire a boat and find them.
So what this pre-press does is it mimics what happens.
They ain't coming back, dude. The insertion orbit for the SLS core stage is 1,000 nautical miles by 20 nautical miles. They ain't coming back.
Pressurize that tank to flight levels and then do a high flow bleed check. This high flow bleed will flow liquid hydrogen through those engines at the bottom to get them in the proper thermal condition for launch. Get them at the right temperature before they start flowing.
Overall thoughts of SLS? I'm a fan.
Minus 423 degree Fahrenheit.
I'm a big fan of SLS. I want them to fly it more, not less.
Liquid oxygen.
High flight cadence, no matter of an expendable or reusable vehicle, will lower costs. I want this to fly just as much as Starship. But I'll take 4 launches a year. That 4 launches a year would be good, but more would be a better stretch goal. We could ideally launch 12 of them a year if we're going to the moon.
Which will be a one-time
We should
test
do
only.
that, but we should do a lot of things.
There's a big moment that launch team is looking forward here to.
Why must NASA be forced to reuse everything they have? Well,
it runs about an hour.
Long story, gameable.
Of course, we'll be tracking all the milestones along the way.
Same launch cadence as Saturn V would be good. Saturn V launched at its peak about 4 times a year.
The SLS rocket and today's test so far. That's all for now. This is Artemis Launch Control.
Why don't we like Glenn? I like John Glenn. Wait a minute. I mean, the Bell probably survived somewhat, but the rest not so much. No. The nozzle on the RS-25's Yarg only really stay cool if both the streams just crashed. Not crashed, they buffered. They really only stay cool when they have hydrogen flowing through them. Without hydrogen flowing through them, they're subject to, like, 3000 C. Yeah, no, they're not coming back. And then high suborbital trajectory with 1,000 nautical mile insertion, and they're gonna hit the atmosphere going like 23,000 miles an hour, somewhere in there. Yeah, they're not coming back, dude. Check out the NSF close-up of the vent. Apatoxin, that's not the case. US with the J2X. Yeah. Guys, okay.
When this rocket is ready for launch, it will be the first in a series of
increasingly complicated missions to live and sustain on the moon, but yeah, they cut them off.
Increasingly complex missions. Artemis 1 will provide a foundation for human.
It's a little more complicated than that, Apatoxin.
Deep space exploration and demonstrate NASA's commitment.
I can explain. You're right, but it's important to understand why that happened. I'll explain it when William Shatner's done talking here.
And its capability. to extend human presence to the moon.
It's important to extend capability to the presence of the moon
and beyond.
And beyond.
To learn more about the Artemis 1 mission and the Space Launch System, go to our website, nasa.gov.
Don't tell me what to do. So Apatoxin, it's important to understand that the reason why, so Congress did mandate them to use shuttle-derived parts. Yeah. Is that designed by committee? Yes. Does that give you really crappy architecture? Oh yeah, absolutely. But, you know, I saw that and I didn't just say, well, screw Congress. No, because I like spaceflight so much, I decided to look more into it. The long story short of the matter is that the reason why they ended up mandating the reason why they ended up making mandated hardware, the reason why they put that into law is because somebody came along and tried to pull the plug on NASA's human spaceflight program entirely without congressional approval. And when they got word that they were going to try to just pull the rug out from NASA completely, cancel the space shuttle and get rid of Constellation, Congress said, the freaking hell you are. Hence the implemented, mandated by law components to build a launch vehicle. That was basically them trying to save NASA's human spaceflight program. You can say I'm wrong. You could say, yeah, that's not correct. That's exactly what happened. Turns out when, you know, you have an entire human spaceflight program and you say, no, we don't want to do that anymore. We're getting rid of the entire thing. It turns out the people that, you know, kind of run that whole entire thing get really annoyed. In this particular scenario, Congress is the one that gives NASA money. That's what happened, dude. If you think I'm crazy, go look it up. That's exactly what happened. They tried to pull the plug on the entirety of NASA's human spaceflight program, citing underperformance and untimeliness and high cost, basically. But the funny thing is that this, you know, they underfunded it. Congress actually ended up underfunding the Constellation program, and it go figure, they underfunded it, and it ended up not meeting deadlines. And then they use that as an excuse. They use that as fodder to kill it. And when Congress got word that that the executive branch was going to try and do that, they said, no, you're not doing that. Hence, we got a compromised design in the form of SLS. Now, don't get me wrong, SLS isn't a bad vehicle. It needs a better upper stage. But yeah, in this particular case, Apatoxin, and don't get me wrong, I want to dump on Congress just as much as the next guy. Who doesn't? Right? Who doesn't in this day and age? Could you guys like do something, please? But in this particular scenario, they actually argued for more spaceflight instead of less. And I 100% agree. I can't say that I wouldn't have done the same thing. That's entirely wrong. Being very diplomatic about this, all right? I'm just trying to explain what happened. Everybody says, oh, Congress is stupid for mandating SLS into law. It's designed by committee. Yeah, there's a really good reason why they did that. Because some dingleberry tried to come along and pull the plug on the entire thing. NASA's entire in-house human spaceflight exploration program. That's what they wanted to do. Turns out when you try to do that, the people that fund said project get a little pissed off. How's the tanking going? They are going to do a pre-press here. Tanking is going good, Bandit. The core stage is tanked. The ICPS is getting fast filled right now. They will move to a pre-press test here to move the ICPS and the core stage up to flight pressure here. just to make sure that the seal doesn't croak when they go to flight pressure, verifying all hydrogen filling and draining procedures that they would encounter during a launch. Yo, have a good day. Thanks, Monty. That sounds like they had to catch what they could in their hands or else it all hit the ground. Hence, Ares 1 literally on top of Ares 5 right there. Yes, that's exactly what happened. They scrambled to try to save the program, to try to save Constellation as much as they could. Because at the end of the day, the executive branch has the power to pull the plug on a program if they really want to. It doesn't matter what Congress... It doesn't really matter what Congress wants. Which is kind of annoying, but... it can happen. That's what happened with Apollo. They just said... Nixon just up and said, nah, we're not doing this anymore. Nope. Oh, you want funding for NASA? Good. Build a new rocket. That one's too expensive. Which is also there's hope. So STS-95 flew with 2043, 2045, and 2058. 45 is for Artemis 1, 48 is for Artemis 3, and 43 will not fly. There will be a Glenn engine left. Good. Except when they are underfunding it to the extreme, what exactly is NASA supposed to do? In order for NASA to really function correctly, Hellfish, Congress, the President, and NASA all really need to agree on everything. And fortunately, right now, that's what's going on. And even more fortunately, which you wouldn't really guess, is that that was pretty much the case for the last presidential term as well. Yeah, interesting how that works. What do I do for a living, Suicide Moose? I teach people about spaceflight right here on Twitch. That's my job. Cool, well, thanks. Yeah, dude. You want to learn about rockets? I got you. I do STEM outreach. I'm a STEM streamer here on Twitch. You know, I play STEM games. We play all kinds of stuff, from like Formula 1 racing games, we teach people about car physics and aerodynamics and stuff like that, to covering rocket launches. NASA actually gave me permission to do it. I don't know how many... I'm on their good graces for whatever reason. Go figure. No, they're cool. And they know what I do here, and they support me, which is actually pretty cool. Not financially or anything. Can you please judge the part I engineered? Yep. Did you play KSP back in the day? Yeah, Suicide Moose. I haven't been playing it a lot lately because I just moved. So I kind of been busy doing other things. So we kind of been playing other games for a little while right now. But yeah, KSP is by far and away the game that I've streamed the most. You know how much longer the test will be running? Just curious of the Haster plan. JDG, I gotta take a break, man. I gotta take a break soon. I want to get to the end of the SLS test, then I think, then it birds. Then I think I'm gonna probably take a quick break, and then we'll come back and Haster plan. You know what I'm saying? I'm sitting here for 8 hours. I only stopped to take a pee-pee for a second. Oh, my back's starting to get me. You know what? You know what? You know what I can do? You know what you can do? I can stand up. I never even thought of that. I don't need to sit down. I can just stand up here. Yeah, I can just stand up and talk. I don't know why I never really, yeah, I can just sit here. Standing desk? Nah. Big room with a green screen, baby. Weather EJ is back. Yep, you can tell that you got a lot of clouds right in this area here. And then this area here, there's not a lot of clouds. So what does that mean? There might be some clouds in the sky a little bit later in your day. Now, for your commute home, looks like we got a little bit of Hydrolox rocket testing here to accompany you for your commute home, but expect a little bit of traffic because a lot of other people are trying to do the same thing right now. That's my forecast. That's my evening forecast for the day. Back to you, chat. Now to EJ for your weather on the 8th. Did you skip leg day? EJ is better than Yannick Garcia. Yo. The rocket seems to be leaking some clouds. That's condensation, Sharis, from the cryogenic propellants that they're using. They're venting liquid oxygen overboard because the propellants on board are really, really cold at really, really high pressure. So they tend to boil. You don't want to pop the tanks, the fuel tanks, like a balloon, so they have to give them a little bit of a vent. They also have to keep topping off the tanks. That's really important. You got to keep topping off the tanks, or what NASA calls putting them into replenish mode. And you also need the vent lines to work. Now, the vent line's at the top to vent out the gaseous oxygen. Now, when the gaseous oxygen hits the atmosphere, it causes condensation, hence those vapor clouds. Basically, SLS is ripping a fat vape in your face right now. EJ for scale. My Rocket Lab Nauta capsule looks amazing. I agree. It's pretty cool. Does that make sense, Sharis? Now, keep in mind, this rocket uses liquid hydrogen and liquid oxygen. They are not venting liquid hydrogen. You don't want to vent liquid hydrogen, because if you vent liquid hydrogen, that's a good way to Hindenburg yourself, if you catch my drift. A gaseous hydrogen is a hazardous gas. On top of being a greenhouse gas and being very bad for the environment, it also really likes to blow up. And if you don't give it a place to explode, it's going to find a place to explode. Now, the hydrogen systems go through a recirculation system that goes back down out of the pad, and it goes to what basically amounts to a gigantic Bunsen burner. That's about, it's over there. It's that way. It amounts to basically a gigantic Bunsen burner. It's called a purge flame, and that's where the gaseous hydrogen that's boiling off ends up. Why does the orange surface look so half done? I don't know. But it's probably because they had to reapply the foam in different areas. The different colors, the discoloration on the foam basically means that it hasn't been sitting out in the sun for long periods of time. So the discoloration is most likely because they needed to scrape some of the foam off and reapply it in certain areas during the last rollback. Unmute? Oh, he's muted. Thank you. How big is your screen with chat? It's a 24-inch screen, Nemetco? The green screen here is gigantic, but the monitor that I'm using, I don't know if you guys use inches to measure monitors, do you? I'm muted? I'm not muted at all. Could you recondense hydrogen? Yeah, sure, T-Man. But gaseous hydrogen is easier to just get rid of. But yeah, you could recondense it. Yeah, it's a 24-inch monitor. I can see it from over here. I'm about, I don't know, 2.5 meters away from the screen. I can see it just fine. I mean, you muted Daryl. I didn't, though. LH2 tank on the upper stage is now in replenish. Cool. That's good. That's good news. They should go for a tank press now. Big fun or great eyes. I was surprised that you can go so far. I have 20/20 vision, Nemetko. Yeah. It's probably worse now. Last time I checked, it was 20/20. But yeah, I can see a good distance away. I can read chat perfectly from here. Once again, I'd say about 2 meters away. About 6 feet, 7 feet, somewhere in there. Have you considered a standing desk? No, I haven't. Why would I have a standing desk when I can literally do what I'm doing right here, right now? Read this. Eggs meters work for you. Yeah, Nemetko, I'd say 2.5 meters away from the monitor right now. I can read this just fine. I mean, it's a little blurry, but I can still see what you're saying. How many fingers am I holding up? I don't know, you tell me. Get green tights so you can float around. I'm not going to indulge in your fantasies, RB. That's a little strange. Because sitting desks were invented by the government to make us weak and easier to control. The government. You guys are crazy. A whole green spandex. Come on. All right. Yeah, I'm going to stop doing this if you guys keep doing what you're doing. The government. I'm texting people about how weird you are, Chad. True story. No, Bandit. The second stage is in replenish mode. Now they're going to go for...
okay, folks, a little early on this, but we just got the go from the launch director given to the liquid hydrogen team to proceed with the pre-press test.
Okay.
Again, the launch director, Charlie Blackwell Thompson, giving the go to proceed with the liquid hydrogen pre-press test.
That's very strange.
This pre-press test will pressurize the liquid hydrogen tank to flight levels.
On, man, damn.
They're going to close off the vent line, terminate the replenish, and then start a engine bleed with high flow that saturates the engines at the bottom of the rocket to super cold temperatures that will be ready to
when they
receive a
take
flow
gophers and they put them in a tank and they press them
of
into
liquid
battle.
hydrogen and liquid oxygen through those engines for startup.
Fighting gophers.
This is an important moment, an important test for the team.
They're even quilted for comfort. Nice. Go further back for scale? I can't go much further back than this, dude. The screen is in the way.
So the LHY team will start a control loop that cyclically pressurizes the tank.
Yep, there we go.
They'll open the vent valve.
You know, Sun
Which
Temple
will help control the temperature.
Dude, I would stand about as close as possible to the rocket before it like causes physical damage.
Validate that pressure control.
If I could live stream, I'd do it from like a mile away. Like you'd have to wear earplugs. Like I'd go Jim Cantori on that. I'd be like, "In here, the rocket's about to launch."
This pre-press test.
I would do that. Oh, I'd absolutely.
Is critical for terminal count.
There it goes, fly, baby, fly! And then I'd get like the flag out and just be. You guys ever seen that gif of that guy that's in like the gale force winds?
Minutes and 40 seconds is when
yeah, I'd do that.
The high flow bleed will start for a launch countdown. It'll run about 4.5 minutes. It'll get the engines to exactly.
Yeah, it would be freaking sweet.
The right temperature for launch.
I'd do that. Yeah, absolutely. If they'd let me, I'd do it.
Launch team to this point haven't been able to validate this procedure
you're
yet.
not wrong. We want to hear the rocket, not you. Don't worry, you wouldn't be able to hear me if we were that close.
This is Artemis Launch Control.
Well, Ace, just remember, if you're going to die, you're going to die with your boots on. If you're going to die, keep moving on. Die with your boots on. Oh, nice, Winterside. Yeah, there you go. Do what James Burke did. When you combine this cryogenic liquids in the thermos and then ignite them, you get that. Destination, the moon or Moscow. The planets or Peking. I would if they'd let me, Zyza.
And the core stage pre-press test has begun on the LH2 tank. The core stage pre-press test has begun.
Valiant, nice. Oh! Oh, yeah. Oh, yeah.
Discovery, go at throttle up.
Bow. Bow. No, Yarg, there's a crack in the TPS. You saw that. Yep. Yeah, it's definitely not supposed to be doing that. I'm serious. Yeah, but it's observed and they've deemed it not a problem.
As the pre-press test is happening, the liquid oxygen tank, just an update
How tall
on
is
that,
the rocket?
upper stage
320 feet
is
tall.
continuing to load.
A shade under 100 meters, and that's just the rocket, not the pad that it's on. Capsule's already fueled, Hillness. They've fueled the upper stage. It's ready to go. 917 is the camera number. This is a 900 series camera space dive, so it's a camera that's on the perimeter, or it's a camera that's not on the pad. These are cameras that are a little further away. and they have a 900 series designation. I noticed that 800 series designation cameras are all cameras on the pad or on the mobile launcher. 900 is stuff that's around the rocket, so stuff that's inside of the BDA. So this is a non-pad camera number 17. I think that's their naming convention, but that's a guess. I didn't know it was so tall. Yeah, see, me next to the rocket. Isn't that great? That's nice. You don't want to touch it. It's a little cold. Hey, Tree Hugger, what's going on? 34-month resub. Really puts it into perspective. Yep. Why am I standing? Because I've been sitting for 8 hours and my back is hurting. I know, Jason, right? Yeah. Wait, when did you start streaming? 7:30 or 7 o'clock this morning?
And welcome back to those watching NASA Television's public channel. We are live at the Kennedy Space Center in Florida for the final moments of a cryogenic demonstration test of the Space Launch System rocket. The final test, a pre-pressurization of the core stage liquid hydrogen tank. This is something that would happen in the final minutes of a countdown to get the engines ready to go.
Race, thanks for the raid.
The tank is pressurized.
Publicly traded companies
High flow
do be like
bleed
that,
is drawn through the 4 RS-25 engines.
Weather is fine. Nice and warm.
And then once the temperature is right,
look at that Chad
the
tier
engines are
rocket
lit.
right there.
6 seconds later, boosters ignite and the rocket lifts off. Today is just a test.
This is a test of the emergency
Of a
broadcast
procedure
system.
that happens in the final 4 minutes and 40 seconds of terminal count. All is going well so far.
No new bits. I'm late tired. Well, you have a nap. Then fire the missiles! This is nice. I can't click on it. The mouse is over there, T-Man. No fire the missiles. It's not launch window. Well, have a nap. Then when the launch window comes, you will fire the missiles!
LH2 core stage tank pressurization has begun. The replenish valve has closed. This is the one that replenishes liquid hydrogen as it boils off.
It flows the replenishment
just
valve.
Replaces what is lost.
For flight. Now keep
the
in
fill
mind,
and drain valve
test.
is now closed.
Yep.
This is the one that filled it to 100% or close to 100%. This is the 8-inch line right there. That's now closed.
This side.
And the vent valve.
It's called the end of the world.
Vent valve towards the top has closed, and so now the tank is pressurizing.
Russia's like, motherfucker!
Watching
and then England's like,
telemetry and
Tom,
data closely.
Hello.
As are we.
Thanks, DJ. I appreciate it. But they'll be dead soon. Freaking kangaroos. The flare stack should have been ignited a long time ago, Forge. We just don't really have a camera picture of it. They've already bled the engines, Deadbringer. They've bled them down, but pressing for flight is going to high pressure bleed the engines. So this is a really big test. This pressurization stuff. They basically topped off the tanks, and then they closed the replenish lines, and the tanks are pressing for flight. You should see these valves start to actually go down a little bit. Alaska can come to the end! Moving around to get the blood flow back into my feet. Yeah, Zim. Fortunately, this is a test, dude. It has to be like this. Is this similar to a spin prime? No. Why are we dancing? Because I want to. I can dance if I want to. I can leave my chat behind. Because your chat don't dance, and if they don't dance, well, they're no friend of mine.
Cryo team is monitoring the leak at the QD. It went above its 4% hydrogen concentration threshold.
QD started to leak.
But the team does have a contingency plan to allow that to happen for no more than 5 minutes. The tank continues to pressurize, and it is stable. The leak is stable.
It's just a tanking 4%. Test. It's not a. There's no count.
Zealox just came in with a report that they have finished fast fill. That's the liquid oxygen in the upper stage. They are in replenish now.
Okay. S F A F F T T E E. I spelled it wrong. Safe dance. September 27th is the tentative launch window. My only regret is having bonitis. My bonitis! I was too busy being an 80s man. I forgot to cure it. Sorry. That's a good show. Let me tell you how good of a show it is. Yes, I'm familiar with this life form. It is an R2-D2 shoved into a beer koozie with some crutches. It looks like it has crutches on this side. Well, I have to cut those off to make sure that it's working correctly. Thanks, Sun Temple. Bonana is the cure for bonitis. Yep. Yes, look, it cannot be sitting on these crutches the entire time. No, I don't think so. Look at me, EJ. Homeowner. Yeah, Alan Prod, it's crazy. Yeah, me too, New Bits. I'm sorry. You call that an ink defense? What? I didn't get a lot of sleep last night, can you tell? What about Zoidberg, indeed? Oh, Snibbles, you got an all-rush mixtape? It's Friday night. I got no date. A 2-liter bottle of Shasta in my all-rush mixtape.
Update on the pre-press test. The engineering or the launch team has achieved the pressure they were looking for.
Ching!
In the engines, the RS-25 engines through the high flow engine bleed. They've got it to the proper delta P they were looking for.
Not, RB?
It's a tight range, but they've got it in spec.
We are calibrated and
Big
in
accomplishment
spec.
there.
Thank you very much. Very good. Actually, really good. The only real problem that we had was that the hydrogen seal didn't seat on the first attempt. Everything else has been A-OK
monitoring
since.
the test. The test is now complete.
Oh.
The test is now complete.
Oh. Good job, guys. Hell of a job. Seriously. Good work.
Again, there was a leak that was in the 4% range. This is from the quick disconnect, 8-inch QD right there at that location, but it was stable throughout the test.
Yep. I would
which
love
is a good sign. Stand by.
Oh, hang on. He'll come back at us with an update. But yes, that ensures that all the fueling systems on SLS are working correctly. Now we just got to get those range termination batteries figured out.
Now with the test complete, the liquid hydrogen team is preparing to get back into loading the core stage. Part of this pre-press test is they closed off the fill and drain, which is basically the fuel line that puts liquid hydrogen right there at that location. Now they're going to reopen that valve.
4% is a lot higher than the 0.5 mentioned earlier.
Back
anything above 4 yard is no good, but 4 is at the upper level of what they're expecting for a hydrogen gas leak rate. 4% is just fine. If it goes above that, though, then we got problems. It was 0.5 during fast fill with tank pressure behind it, which is good. That's really good. That means the seal sealed correctly, and now it should seal correctly again here. If they can move SLS out of flight pressure back to replenishment mode here, guys, we're golden. This thing will launch. Not today. Soon. When will then be now? Soon. What happened to then? You missed it. When? Just now. We're at now. Block. How many times are the tanks ready to be filled? Is that an issue anymore? 22 times, Pacey. It was never an issue to begin with. It was falsely reported by somebody who has no idea what they're talking about. Unverified news. Good times. Yeah, they can hit 22 tanks on core stage 1. They're at like 14 or 15. We're nowhere near the limit. Nowhere, not even close. And even 22, they could probably go after. They could probably go more than 22 times. 22 is what their engineering analysis is up to. They can be conclusive that you could do this 22 times and it really wouldn't be an issue. After 22 times, that's when you start rolling the dice. I don't know what's going to happen after that. We haven't crunched the numbers for it.
With the pre-press test complete,
yes, Aqualets. It seems to have been remedied.
Now wanting to get the upper stage into replenish.
It feels an awful lot like they're just trying to justify it being okay to push the percentage allowed higher because they don't want to have to take it back and really fix it. Yeah, fortunately, Yarg, that, the engineering and data doesn't really care about what you feel. Yeah. If the engineering and the data and the telemetry is verifiable and it proves that it's working within family, it doesn't matter what you think. It's not what you know, man. It's what you can prove. Yeah, I understand what you're trying to say, but it's working. The thing's working just fine. And another important Yarg. Okay, so another thing This is what you wanted. This is what you want to hear. Another important thing to understand is the reason why they even worry about that CAS gas fill rate is not necessarily because of making too much of a leak. There's a catch can. There's a catch can. It's not a problem. They can scavenge the leak and it'll hit a purge flame. Honestly, it's commodity amounts. What does that mean? Commodity amounts? What is that? What are you talking about? I don't understand. So, SLS is bigger. The SLS core stage is bigger than the space shuttle's external tank, right? Way bigger. They can only get 2 tanks worth out of this thing before they start boiling off too much hydrogen. That's why that leak rate exists in the first place, dude. Turns out that they're expanding the commodities at 39B to be able to accommodate for more recycling attempts for SLS. Tank ain't ready. They literally wouldn't be able to recycle. They wouldn't be able to get, it's actually not even 2. They wouldn't even be able to get another launch attempt if the leak rate went any higher than that. They boiled off about 4,000 gallons. I mean, that was rough napkin math from chat. They boiled out about 4,000 gallons of hydrogen from that thing. Now, don't get me wrong, that's not a lot, but there's not enough facilities here yet in place to be able to accommodate for leaking hydrogen that much. True story. You know what NASA's been doing as a backup plan? Well, they could have used that hydrogen tank, but the meme lord has that one. As a backup plan, they went to the only other cryogenic facility on the Cape, and they're storing LH2 inside of Slick 37B's hydrogen tank and replenishing the tank at 39B with Slick 37B's hydrogen. That is, yeah, I know. Jank. That's the jankiness you're looking for, isn't it? No, not at all. I mean, don't get me wrong, LJ. It is hazardous. You don't want to leak too much hazardous gas because you don't know what happened. You don't know what's going to happen. It might work right, might not work right. But they did say that in the press conference that the 4% leak rate is based off of commodity usage. Yeah, because the second hydrogen tank is not ready to go. True story.
And we are back in replenish on the core stage. Core stage liquid hydrogen is now back.
Oh, yeah. No problem, dude.
The team working now on the upper stage that you see there.
I don't know if that would change it, Aqualex. Often test as you fly.
Dialed in.
But yeah, theoretically, I suppose.
There's a loop that adds propellant, and it's gone over the amount. And so they're just trying to get that calibrated so that it settles the LH2 tank at exactly 100%. They're currently working that right now.
Okay. Look at that burb. Wonder what kind of burb that is. Hawk, maybe? Falcon? There's another falcon. There's another falcon that's kind of over there a little ways. Vulture? I'd have to ask WD-40. He's the burb guy. No, Xanath, don't you dare. It is not that. Shh. Have I ever told you about the bird wars? Huh, I don't envy you. Update on Ship 24. They have put a piece of stainless over the payload bay door so there won't be any satellites on board as they cannot deploy them. Interesting. Everything is working fine, Slacker. They press the tanks for flight, and they depress them from flight, and now they will put them back in replenish. This test should be concluding very soon. Yeah, they put a case over the Starlink dispenser. So it looks like they're going for a straight orbital flight test. Forge. Interesting. More or less A10, yeah. The only thing that rocket is missing is a beautiful shuttle. Agreed. Yeah, maybe, Jim. Yeah. Yeah. Okay, interesting. They covered up the Starship cover. So we're waiting for an update here. Every test has gone pretty well, except for a little bit of a hiccup this morning, but everything seems to be okay here. Oh, Vegas, we're all in the same boat there. What are all the other launch pads used for? Are they just in-use pads at this point? They're used for different rockets, Ryle, like Atlas, Falcon, Delta, Vulcan soon, Minotaur. But a lot of them, yeah, I mean, there's Terran 1 that's going to find its way on there, New Glenn in the future. But a lot of them are AIP, which does kind of suck. They're abandoned in place. They were made for missile testing, for testing ICBMs in the 60s. But a lot of them are abandoned in place, but a lot of them are also being used again. Dude, after when the space shuttle started flying, it basically killed all other rocket research and development in the U.S. except for ICBMs. It really did. So much so that they had to pick up and introduce a new generation of expendable launch vehicles in the 80s when they decided they didn't want to use the shuttle to launch National Reconnaissance Office payloads. Which that gives us the likes of Titan 4, Delta 2, Atlas 3, Atlas 5.
I need to correct some
Delta
information
3,
about
Delta
the
4.
hydrogen leak that was observed during the pre-press test. That was on the 4-inch QD for the engine bleed line. Again, that was for the engine bleed. It was a stable, but different leak, not on the 8-inch fill and drain. 8-inch fill and drain was isolated. It wasn't in play. But that leak was observed in the 4-inch QD quick disconnect on the engine bleed.
Interesting. Hey, Mammon, what's going on? I never realized KSC was so large. KSC is not incredibly big, Ryle. The vast majority of the pads are on Cape Canaveral Space Force Station. So at Cape Canaveral Space Force Base, which is basically everything south of Pad 39A, on the Merritt Island. Well, it's not Merritt. I'll just show you. It's easier that way. So all this stuff down here, all these pads, Cape Canaveral Space Force Station. Technically, if you really want to be technical, Kennedy Space Center's property line, so where it stops being Space Force and it starts being NASA, is right around here. And then it goes down the Banana River. So, and then it basically goes over right around here. So anything from, I'll just draw a line. Nope. Just you know what? That didn't work right. So basically anything around here. Give or take, this is very rough. That's Kennedy Space Center, for the most part. Cape Canaveral Space Force Station is this. It also shares space with the Merritt Island Wildlife Refuge, because rocket launch pads are actually... Wildlife sanctuaries are great around rocket launch pads because you don't want anything near this. So basically, yeah, Kennedy Space Center and Cape Canaveral Space Force Station being here basically preserved a ton of wildlife area around here, which is actually pretty cool. That's pretty smart. I was gonna share this earlier, but I guess it's a good time. Yeah, there's a lot of pads though, huh? What is this? This is from IAC. Interstellar probe seeking to go out as far as 500 AU, well beyond the heliosphere. Depends on the incredible C3 capabilities of SLS. Is that a... That's an SLS Block 1B with a Centaur as a fourth stage and a Star 48 as a fifth stage. Yo, that would be awesome. And with a Jupiter gravity assist, that thing's gonna go real fast. Voyager 1, nah. Voyager 1 is slow compared to that. Five stage sounds like a KSB objective. Yep. That's what this rocket can offer if we just decided to put a little bit more money into it and get it a better upper stage and some better fairings. SLS is a great launch vehicle. I'll say that, yeah, people can say I'm crazy. You can say I'm crazy, but that thing is awesome. It's really good. It just needs a better upper stage. This version of it sucks. All this version is basically designed to do is just put an Orion capsule near the moon. Not even around the moon, just near it. Oh, well, you can get around the moon, but in a very high orbit. That's all that's designed to do. You give it a bigger upper stage, you could do all that and then more. You know, you could do all that. You could go around the moon with a space station module attached to the Orion. So you could do more deep space habitation. Please give this a bigger upper stage, please. Sounds like you need 4 SRBs. Yarg, I'm not disagreeing with you. Why is the upper so small? Because some dingleberry decided to use an off-the-shelf component in the form of a Delta 4 stage to save on launch costs. Hence the name ICPS, Interim Cryogenic Propulsion Stage. Everything is going fine, Jim. Your thoughts on which rocket fuel is better for engine restart during re-entry? Depends on what you're doing, Chief. No, Booty, she ain't taking off today. 27th, so next Tuesday. I'll see you next Tuesday. Or will I? Oh, yeah. All right, cool. Thank you for getting the joke, jeez. Yeah, Valiant, that's right. Oh, she takes off for your birthday? Man, that'd be cool. They still need to unlock the US node in the tech tree, just cheesing the science points for it on space high above the moon. You know what, LJ? I don't know what's worse. The fact that that actually makes sense, or the fact that I actually understand why that makes sense. It's too real, man. Yeah, let's develop 2 upper stages for this rocket to reduce launch costs. Yeah, I know. Yeah, that's funny. Geez, when you say it like that, it sounds kind of... It sounds kind of dumb. No, Ordon, I haven't heard anything since we talked about it last. Booster 7 is rolling, rolling, rolling. Or is it rolling, 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 rolling? Which one is it? Which one is it, Havix? This is important. I'm not sure, Aquino. The latter? Okay. Keep them doggies rolling, rawhide. It's called the Space Launch System, but how does one launch space? With science, rename. Bloody peasant. Uncultured swine. Does Booster 8 have any engines mounted? I don't think so. Oop. What was that about fuel costs? They're inconsequential compared to the total cost of the launch vehicle. I don't know how much it costs to fuel it, but I know it's a lot of money for you and me, Cuban, but I don't think it's a lot of money in general. There's space inside of the rocket. See? Science. The world tries its best to ignore Fred Durst and his catchy poo-poo. What you gonna do now? Back up, back up. What are these lyrics? Oh, cool, Forge. Sweet. Booster 7 is rolling Star. Yeah, I know. Oh yeah, Slacker? Hell yeah. I put your left foot in, I put your left foot out. Put your left foot in, and then you shake it all about. Do the hokey pokey pokey pokey. Come on, do the hokey pokey pokey pokey. What? What are those lyrics? They don't make any sense. That'd be a great cover.
Discovery, go at throttle up.
What was that? Don't worry about it. Don't worry. You didn't see nothing. Oh yeah, Jim? There you go. Nice. Don't get DMCA'd. Yeah, that's right. Nah, I changed the lyrics, didn't you hear? Didn't you hear it? I changed the lyrics. The stream you hit the play and the pause button, didn't you? You hit the play and the pause. Who did? Who did? Don't lie. Don't lie. Who did? Somebody did. Nah, you moved. No, I did. The vaping rocket betrayed you. Oh, yeah. Oh, yeah. I was finally like peace and quiet, my vans. Alright, it's been a second since we got an update from Derol. Derol, please help.
Okay, the cryo team just updated the NASA test director on the results of the pre-press test. Currently, we are back into nominal auto-replenish for the core stage liquid hydrogen tank. That's good news. Engineers report that the pre-press test went very well. They were able to dial in the bleed position on those engines. The pre-press control, in fact, got them dialed in pretty quickly. You may remember I mentioned this test was scheduled to take about an hour, and it took far less than that, less than 15 minutes.
Good.
Engineers say that that pre-press control got them dialed in pretty quickly, and they were
that guy's drinking Mountain Dew.
Raise and lower the pressure within
the ALD
the
was
range,
drinking Mountain
within
Dew.
the desired range.
You
just
saw
to
it here.
Get a feel for
what a gamer.
Its limits and how it moves within that range.
Better be a Baja
so it went
Blast,
really
yeah,
well.
Right? That's what we call.
They've got that part dialed in.
A pro gamer move. Right, LJ.
The liquid hydrogen team also addressed the increase in concentrations of hydrogen detected during the pre-press. This is the leak. So they reported it got up to a little over 5% in the cavity. This is likely the 4-inch bleed QD. This is the line that carries the liquid hydrogen out of the engines after they've run through the engines and super chilled them. They saw it go a little over 5% during max pressure on the bleed system. But as the flow continued, they reported that the leak rate lowered on its own through no input on their side.
Yeah, that probably should be documented. You probably should figure out why it did that.
Which is what this was testing. It would have been a violation and stopped the count, but for the ground rules that were set for today, they were within those.
I don't think
the
so,
launch
Reagan.
team's looking forward to getting back that data and taking a close look at it.
Your bones do weaken in space, though, so maybe, who knows?
Currently still dialing in the LH2 load on the upper stage. Still working that replenish in the upper stage, but the hydrogen team reporting that they're almost done with that. And so we're looking to get confirmation of that. Once we do, we've asked Charlie Blackwell Thompson, the launch director for the Artemis program, to come in and give us a report, and then we'll close out the show. She's currently talking to the launch team, as you can see there, next to her assistant launch director, Jeremy Graber.
Mountain Dew, man.
We'll look forward
to
talking
that's
to
definitely a Mountain Dew. You can see it right there.
For now, this is Artemis Launch Control.
Huh. Silly NASA with their dual curve displays. I have tri-curve displays. Silly Nazar. Yeah, they got them ultra wides though. Mine aren't ultra wides. Cries in single flat display. Oh, that actually reminds me, chat. I'm actually getting another monitor mount so I can actually switch to a 6 monitor setup. Yeah. Why? Remember when I used to have the VR headset on and I couldn't see chat because I needed more monitor real estate space on my streaming, on the gaming computer? I have the space now. So yeah, we're gonna do. It might end up being 5, depending. Might end up being a 5 monitor setup. But we could do a 6 monitor setup. But why? Yeah, it's so I can have the VR headset on and I can superimpose chat over the VR headset. I need another monitor plugged into my gaming computer to do that. So I bought more monitor mounts. So yeah. Well, so kind of like mission control behind me. Yeah, it's gonna end up kind of looking like that, huh? Do you have a picture of your setup? Yes I do. Yes I do. I think I do. Thomas, do you have a link of the picture that I linked in general chat in Discord a long time ago of the setup? I know you seem like the kind of guy that would keep that around. Take a new one real quick. I have a Thomas. Yep, there it is. Yep, that's the setup. That's where I'm sitting right now. Yep. Man, that room looks so clean. Yeah, I was thinking another mount right there, or try to mount to that, and then put 2 monitors here, or put another 3, but we got to worry about the lights. That's kind of an issue. So the other thing that I could do is that I don't necessarily need this screen real estate right in front of me is mounted over here and have 2 monitors over there. Those aren't monitors that I'll generally be using too much, so. What chair is that? An IKEA Marcus. How big is each monitor? The ones that I have are, the ones that I would be adding are 24s. These are 24 curved, though. I'm using 24 curves. Is that a BF3 mouse pad? Yep. I won it at PAX East for winning a BF3 tournament in, like, 2011 or 2012. I still have it. Still use it. Mouse pad is older than some viewers. I see PCs are wasting a lot of desk space. I don't like putting them on the floor, Astro. Yeah, I don't like putting my PCs on the floor. Not for me. You recently went with the vertical stack and you love it. Yeah. Well, you don't need to do all that to do virtualize your monitors and VR. Yeah.
Discovery, go at throttle up.
Yeah, you do. We couldn't do that, and I'm sure, S, that you have your own special way of figuring that out. Yeah, no, I couldn't get chat to superimpose on it. I would need the extra real estate, so I want more monitors. That seemed to be the easiest way to do that. So I have monitors left over from when I revised my setup from to the 3 curved screen, from the 3 flat screens to the 3 curved screen setup. I have 3 extra monitors left over that I haven't been using. They've been just sitting there doing nothing. So I figure I'll buy another monitor mount and then 6 monitors because frick you. Yeah. That's what your boy's gonna do. It might end up being 2. I think I might just do 2 because the lights and stuff, the lights can get in the way. Do you have a second video card to drive them? What? Yeah, Chris, you got 7. Yeah, there you go. Yeah, that's the other thing I could do. I could race 3 screens and then just have the setups up there. We could only do that. What are you using under your PC? A desk, actually. Yeah. 1 video card can only drive 4 outputs max. What? Oh. This one is tied to the gaming computer. These 2 on the flanks are tied to the streaming computer. 1 monitor is driving the gaming PC. Sorry, I didn't make that clear. This one is dual monitor. That one is just a single monitor. Putting more monitors up here because I could have all the streaming monitors up here and then plug 3 of these into the gaming PC. So I could have chat up here and OBS and the music and everything and Discord up there and then use 3 monitors for the gaming PC. Understand? That makes sense? How do you use them both? Synergy is the program that I use. Synergy connects the mouse into the LAN so I can have 1 mouse and keyboard that control everything. Very useful. Yes, no, the screen real estate thing will fix that problem. I'm not worried about it. Yeah, Synergy is great, Squirrely. Yeah, it doesn't play nice with some games when they're in windowed. But other than that, I don't have any problems with it. It's great. Yeah, does that make more sense? That works, yeah, just making sure. Yeah, I got you. I promote synergy like a boss.
Discovery, go at throttle up.
Chris gifted us up to Aces 10, and he also gifted us up to Cantabs a second ago. Thanks, Chris. Appreciate it. I just came back from school. What is SLS up to? Actually, all tanking tests are concluded. All tests objectives have been
Discovery, go at throttle up.
Have been basically run, and everything is working fine. Nuclear, yeah. We're just waiting on a kind of a final confirmation from NASA. Yeah. Chris, give this up to Squirrely. Thank you.
Discovery,
And
go
Bull
at throttle
Tank.
up.
Thank you. We got the next wave in rockets, and the next wave's on the beach. Yeah, guys, considering that monitor mounts are so inexpensive, and this is the reason why I chose to do this. Considering monitor mounts are so ridiculously inexpensive, I decided to just, and I already have the monitors, and I'm not using them, and I already have all the cables to hook them up. Might as well just free screen real estate. For real estate. It's free monitors for you, chat. Doesn't get better than this. Thanks, AJ. Now I have another program to buy. You're welcome. Intense, I would say that if they can get range approval, we are looking for a launch on the 27th. Yeah, I would not make plans on Tuesday. On Tuesday. Oh, I'll never fault anybody for having more monitors. It was just making sure you had the stuff to use them. Thanks, man. Yeah, I got you. Tuesday. Tim is stuck at Vandenberg. For Firefly? Yep. I get having multiple screens, but what does it have to do with VR? Yes, okay, to be 100% fair, I could put chat on this monitor, this is the center monitor. I could put chat on the center monitor, but it blocks my field of view. There are programs that you can get where you pop out chat on an alpha channel and it'll superimpose it over the VR headset, but you need another monitor. I need more space than just this. It doesn't play nice with that, for whatever reason. Long story short, we figured out that I needed more screen real estate. Did you see Tim's new streaming ban? Oh, Thailand, I love it, dude. Yeah, I talked to him about it back in the day. I've known about that for a good while, when he first bought it, dude. It's got a V10 in it, man, which is really sweet. The reason why I really want to get all that working, here, let me shut that off. The reason why I want to get all that working, fellas, is because of this. Here, let me show you. I need a VR headset to start working so we can use this. You know, I said I've been working in the shop in the mornings. I fabricated up some brackets to mount an actual car seat to that racing rig. That's a seat from a Supra. Yeah, that's a Toyota Supra seat. And I've been building this racing rig to work with VR. That's what I'm trying to do. Also, I don't know why it Coronas that like that, but it's kind of cool, so whatever. Yeah, that's what I've been doing. I've been getting everything organized and making brackets for that thing. The seat moves. Oh yeah, it's got adjustment. I got the adjusters working. It even reclines, Nuclear. I got it to recline correctly, and it can move back and forth. Yeah, yes, I could never get that working, but doesn't matter anymore with more screen real estate. Gabe Johnson, we're done here. So F1, we could do F1, Friday Night Racing, Beam. Yeah, turns out there's a mod for VR and Beam. We could do VR and use the racing rig for Beam, which would be kind of cool. Everything is going 100% correct, Alleviate. NASA's basically just concluding the test now, and we're going to hear some final thoughts from them. The F1, the racing game, Neon, yeah. City F1 Beam Racing Builders. Yep. Please sit in the rig for manager. But why? VM had an update recently. They remastered the COVID. Yep. All right, Newbits. Good night. Hey, though. Hey. Space news next or Hasta Blan? Considering I've been basically doing space news for about 9 hours straight, Alleviate, I think we'll go do Hasta Blan. You're going to get a new 4000 series video card. I had not planned on it, Yarg. I don't make money. Oh, maybe it's only for Oculus. No satisfactory? I thought that this test wouldn't take all day. I thought that this test wouldn't take all day. Maybe we can wind down with some chill update 6. That I said I would do that, and we can do Hasterbland tomorrow. What's Hasterbland? It's F1 Manager Week. Big news. Okay. How long until we see you do this? Oh, yeah. I don't know. Tip more money to the stream, Aqualex, then we'll do that. Please don't take that literally, because last time I did that, you actually did it. Don't do that. Maritime launch and Skyrora partnered to launch Skyrora XL from Spaceport Nova Scotia, bud. Oh, wow. That's great there. That's great there, buddy. Was it nice? It seems like a prettier motorsport manager. Wheat, there's actually a 3D render of the simulation, which is actually really cool. Like, you can actually watch the cars drive around and see their sector times and stuff. It's pretty good, man. It's pretty fun. I've been really enjoying it. Dude, you feel like a freaking rock star when you win a race. If you don't, you look like a bunch of wankers. And that should tell you what team I'm using. They're originally going to launch a Ukrainian rocket from there, but yeah, whatever. Yeah, midget, yeah. And I'm the one that says that it's not quick all the time. I don't know what that says about me, bro. Go to look like a bunch of fuck stars. Yep. So we're going to show the interview with Charlie. Eh? Huh? Yeah, maybe. Can you give me the TLDR and the Rocket Lab update? Yeah, I can do that. Here, let's just go down here. They released a PowerPoint. I'll link it in chat if you want to see it. They didn't actually stream it, Alleviate. They had problems with their streaming software, but we got it in PDF form. They talk about Capstone, complexity missions, vertical integration for the company, you know, how they're basically leading the way for small sat launching. And then this part. So, 2 big things from Rocket Lab. And in the meantime, what I'm going to do is unmute this, put that like that, go over here, do that, go like this, like that, and put that up there so we can see SLS. They basically spent a good part of the beginning of the investor meeting just dunking on Astra and everybody else. There's some pretty funny slides in here. Like slam dunking. Like, look. The leader in small sat launch, most reliable small launch vehicle with the highest number of launches. Successful orbital launches. 27. Virgin Orbit. 4. Astra.
Okay, we got an update now.
2. We got an update now.
From the liquid hydrogen team reporting that they were able to get their replenish loop dialed in, successfully making some adjustments to that, and they're happy with that. And so they're reporting a successful completion of that objective and all objectives for the test today. Launch Director Charlie Blackwell Thompson just completing a conversation on the loops with the launch team. And they report to her that they met all of the test objectives for today's
that's freaking huge
cryogenic demonstration test.
Yeah, baby! That's what I've been waiting for!
At that point, a go for cutoff was given. And that puts the ground launch sequencer
that is what it's all about.
Into a safing sequence.
Yes!
Which comes just before they begin detanking the vehicle, draining it of all of its super chilled propellants.
Right
all 4
place,
tanks in the upper stage, 2 tanks in the upper
spot.
stage, and the 2 tanks in the core stage.
Yes. Yes. Excellent. Excellent. That is such good news, man.
Good news there all the way around.
See? That's what Daryl's listening to me. Daryl.
Charlie Blackwell Thompson now.
Blink if you're being held hostage.
For their team. While we await a final closeout interview for our broadcast today. Stand by. This is Artemis Launch Control.
Dude, I would have Daryl if you wanted to. Creeper, I might actually, we might actually be able to make that happen. I know a guy who knows Daryl, believe it or not. Yeah. That guy's cool. All right. Well, we'll hold here, and let's do that and that. Und der. All right. So check this out, Alleviate. We'll get back over here. So they basically, Rocket Lab spends basically the first part of this dunking on Astra, Virgin Orbit, Firefly, and Relativity. Astra Rocket 4.0, they promised 300 missions and they've achieved nothing. Like, it's pretty messed up. That's pretty screwed up. Yeah, T-Man, they're good, dude, probably. Give me 1 second, dude. It's only one of me, man. So we go down here. This is where this gets really good. Oh, okay, DJ. Yeah, I'm sure he said that. See your last post, please. Orange Dragon up on the 27th. Ah, yeah, I wish, dude. You know I can't play that on stream, right? Hey. Got a drink and a sausage sandwich at the ready. No beans on toast? I'd eat beans on toast. I've decided. That sounds delicious now that I'm thinking about it. Wait, Alleviate, I got a question. This is important. If you put beans on toast, can you, like, butter the toast first? Can we do that? Sausage sandwiches are good. What kind of sausage is it? You can, Pacey? All right. And add grated cheese. Oh, sold. All right. Oh, that's a good shout. Yes, you can. Gone for a Cumberland sausage. Okay. All right. All right. All right. All right, I'm in. You sold me. Anyway, here. Get that sandwich ready. And make sure you don't take a bite because you'll spit it out here with what I'm about to show you. I'm not sure why that's there, but... So they're working on the first neutron tanks. These are the carbon fiber mandrels for the tank. Laser-sintered aluminum 3D printed motors for the next generation motors that they're building for Neutron. We got payload options here. A user guide to Neutron's potential launches in the future. 15 tons expendable, 13 tons in reusable configuration, and 8 tons RTLS, meaning offshore landings. How does that compare to a Falcon 9? Falcon 9 is 22.5 tons expendable. About, like, what is it, 15 tons reusable, and then RTLS is like 12 tons or something. No, you're eating. You don't need to Google it right now. They switched to a dual fairing design, so we got a hungry hippo type thing going on here. And before it was a quad fairing, right? They switched to a single fairing. Second stage is still using a load reactor, meaning they're hanging the second stage from the rim of the fairing up here. And the second stage and payload basically ride hanging inside of the fairing and an inner stage right here. It's not, I don't think you could really call it an inner stage, right? That's nothing we didn't know. It's just a more fleshed out render of it. I don't know what to make of that. I'll be honest with you. I want fairings that go like this, or like this, like this. And then also, yeah, actually, Bro Handy, it kind of did. Yep. Second stage major design is complete. Gotta go to Kansas next month. Oh, why are you showing me that soapbox? So check that out. They're making the mandrels for the stage, for the second stage right there. Or that's the weave on the mandrel for the second stage. See that? That's pretty neat. Archimedes engines have already been manufactured in prototypes. Look at that. That's the one with the 3D printed sintered aluminum turbine assembly, which is just, all right. We got some specs on the Archimedes engine. Rollback of Booster 7 is on the way. Can you post a link to the PDF? Absolutely. Absolutely. I'm here. The link's in chat. Click it. Click it. Get me back into the PDF. But wait, there's more. It's an oxidizer-rich closed cycle engine. So Methalox closed cycle oxidizer-rich, which is somewhat analogous to a BE4, believe it or not. But yeah, really good stuff. I hear you, sir. That's Sean. Sean! 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 Anyway. Alleviate, do you recognize that? So that engine is kind of like a Raptor being full flow. It's oxidizer rich, not full flow. That's Stennis. That's the A3 test stand. That's the J2X test stand. Rocket Lab has a 10-year lease on the A3 test stand to test their motors. They're actually putting that test stand to use for a change, which just, yep. Too bad he can't spell Sean correctly. Agreed. It's like people yeah, people that spell Sean that way, it's like, yeah, no good. Yeah, no, S-E-A-N. It has to be that way. So the J2X test stand, the former J2X test stand is actually getting used. Which, I'll be honest with you, that might be the reason why we saw that J2X hardware get liquidated, because Rocket Lab signed the lease for its test stand. That might be the reason. It's possible. All tests are completed, Kickning. We're waiting for a post tanking operations interview. All right. So Rocket Lab leased for 10 years the A3 test stand, which is a vacuum chamber test stand, which is really, really cool. I'm really happy that they did, because that test stand was built, and when the Constellation program got canceled, it was still under construction. The contractor had a big beef with NASA and ended up suing NASA and getting NASA to pay out on the contract, and then finished constructing the test stand. The A3 test stand was completed for the Constellation program in 2014, despite the Constellation program getting axed in 2011. Now you know one of the other reasons why I get annoyed when they canceled Constellation, why I got a little pissed off. Yeah. How do they make a vacuum stand work? Literally a carburetor at the top, goalie. There's a Venturi at the top of the stand, and when they fire the rocket engine, it sucks air through the Venturi and depressurizes the area around the rocket. The rocket shooting gases out the back, or out the bottom, actually creates a vacuum in itself. Yeah, great for testing. Rocket Lab is building a facility literally down the street from Wallops Island. That's Wallops Island over there. You could see the Antares HIF is right there. The horizontal integration facility for Antares is in the back of that picture. Antares' pad is over there by that water tower. And they're building a neutron factory right at the gates to Wallops Flight Facility, WFF for short. They bought up some farmland here in the furthest eastern parts of Virginia, and they've already started building their factory there. Oh, Buck, you like all this? You like all this? When you look at my mission mode pads, do you think they're realistic in any way, shape, or form? That's right, Thomas. Yeah, there you go. Considering all the effort you put into them, yes, kind of. How about now? That looks a lot like my KSP mission mode gantry crane integration building. How's the test going? All test objectives were met, Geeson. We're waiting on a presser from NASA. Rocket Lab is going to make a mobile service tower and integration building that can roll on rails out into the ocean and somehow pluck neutron rockets off of a drone ship to put them right back on the pad. So now you have to create a pad that is off the coast that you can move the rocket to the pad from land to sea. No, I'm not doing that. That's a drone ship, bro, Hendy, yeah. You know it's a drone ship because the landing pad is in the background over there.
Discovery, go at throttle up.
Yep. Yep. Yeah, Neutron is working with United States Transportation Command and the Space Force for development contracts, and they have a roadmap to the end of 2023. Neutron should be hardware in loop facility operational by 2023, so Neutron is going to be here next year, which is probably more realistically going to be 2024 because aerospace programs, but still, that is an absurdly fast timeline for building a medium-duty class launch vehicle. It also uses a mixed stool pedestal style pad, very similar to the mission mode pad that we made in Kerbal, which is kind of funny. Yeah. I told you your jaw would drop. It's pretty nuts, isn't it? Yeah, I know. It blew my mind when I first saw it. I'm like, ha! Okay. My sandwich was great. There were many times I just sat there staring and not eating. Yep, yep. I dig the concept. I'm with you on that one, Rocket Guy. Yep, yep. Everything dropped on your head today. T-Man, I'm not upset. More rockets, please. To be fair, it looks like they're announcing what they've been doing, not what they're going to do, so they probably have a head start on the timeline. Well, that was the whole premise of the PDF. We're doing what we say we're going to do, Aqualux. So, yeah, I'd agree with you on that. EJ consultation needs to send an invoice for that idea. Yeah, right. Peter Bix, a mad lad. Yep. So once again, we're waiting on NASA here for word on what's going on with the tanking test. I guess Peter thought the chopsticks were quaint. I don't know. I want Rocket Lab to succeed just as much as the next guy. I'm really greedy. I want all rockets to succeed. With that being said, A, Rocket Lab isn't kind of competing on the same market as SpaceX. And B, betting against Elon Musk has proven to be a losing endeavor in the past. Bruh. No, you. Roll! Roll! Yeah, that's right, Dad Groom. Yep. Yeah, you ain't 9. You ain't wrong. 95, boy, me Bob. You ain't 9. Neutron is your favorite prospective launch vehicle. Yep. This scream one-upsmanship between Rocket Lab and SpaceX. I mean, yes, but also... Serious question, do you think Starship will crush all the competition? No. No, not at all. Thanks, I always love NASA and spaceflight. I like the information you're giving out. I try, Scam. Yeah, I try, dude. All good. Do I think Starship will crush all competition? No, I don't think so. Induced demand. Yep. Yeah, that has a lot to do with it. Government doesn't want one launch vehicle to do everything. Alleviate. They made that mistake with Challenger, with the space shuttle. They don't want one vehicle to do everything. There will never be a sole single way to launch something into space. Starship won't clean up the market. That's why all these fanboys that go around and say, oh, Starships can drive down. Starship will make SLS obsolete. You have no clue what you're talking about. No clue. Like, not even the slightest. Your touch on reality is way off. What I'm trying to tell you, Alleviate, is that some of them don't think it be like it is, but it do. But I'd be crazy to think SpaceX won't retire Falcon 9. Oh, I'm Team Space. I know you are. I know. I'm just saying that in general. No, Falcon 9, well, I don't know when they'll retire it. We know Falcon 9 is at least on the books until 2028. But hopefully it gets retired because Starship is doing its job. I think it's going to be silly to see something like Starship dock to the Gateway station in lunar orbit when it's bigger than the station. Agreed. We're just going to have to bring one up there to make Gateway bigger. I know. Oh, excuse me. Oh, shucks. VIP stands for very irritating person. Build the gateway. Oh no, wait, please stop my vans. How unfortunate. Oh no! Anyway. Herb. Hey Daryl, can you give us another update, please? You've been doing great, buddy. But yeah, we could do with another update, you know, whenever you get the chance. Yeah, well, Alleviate. It's not my fault he doesn't understand what space is. Are we muted again? Daryl went home. Yeah, he gone. He gone, man. Yeah, Alleviate, it's not my fault your buddy doesn't understand the macroeconomics of spaceflight. That's fine. You know, it's okay. Somebody has to be wrong. That's how you know you're right. Say that to him. Your buddy will probably get more pissed off, but why are you arguing with him in the first place? He's wrong. Like, wrong. What do you want?
This is Artemis Launch Control at the completion of the Artemis 1 cryogenic demonstration test.
I'm wrong with Vance many times. So am I, dude.
With all of the test objectives met, we have Charlie Blackwell Thompson with us, the launch director.
Charlie!
Of the Artemis mission. Thanks for being here, Charlie. Charlie just wrapped up comments with her launch team after a long day of testing and a challenging day at times, but overall, a lot of success. I want to get your thoughts, Charlie, on how the test went in your mind.
Well, I think the test went really well. We went into this test, we wanted to learn, we wanted to evaluate the TSMU, the LH2 TSMU under cryogenic conditions, understanding that we had done both an 8-inch and a 4-inch seal removal and replacement out at the pad. And we got into our loading operations. We had a new loading procedure that we had in place. It was very purposeful in the way in which we went through the loading ops. We wanted to be, we called it kinder, gentler, where we really monitored the temperatures and the pressures across the interface. And once we got into what we call our fast fill operations, we did notice as the pressure came up that we did see a leak in the plate cavity at the 8-inch QD. We went through our pre-plan. We have utilized it a couple of times where we stop flow and we allow it to warm up, and then we reinitiate. When we reinitiated flow, we began to raise the pressures back up to get back into a fast fill configuration, and we were successful in that. So we did not see the same leak signature, which was wonderful. It allowed us to go through our loading profile all the way to core stage replenish. We also loaded the upper stage today as well, went through our kickstart bleed, went through our pre-press test. So all of the objectives that we set out to do, we were able to accomplish today.
Scary.
And it was impressive just to watch and take in and listen to the engineers as they work through those leaks. Again, just impressive work. I wonder what your thoughts are on these seals, which, as you mentioned, were replaced.
Shuttle docks with mirrors.
You're learning a lot. There's a lot of data yet to look at. What are your early thoughts about how they're behaving and what a path forward might be?
Well, I think you got to always take the data and go look at what it tells you. One of the pieces of data very encouraging to me was as we raised the pressure, we actually saw the leak go down. And,
on the 8-inch QD.
Yes.
Yep.
And so this is a pressure seal, pressure assisted seal. So that was very encouraging. And then, we saw the leak rate really taper off. So we'll go take all the data from this event, the early data, the data all the way through loading, through our pre-press tests. The engineers and the team will go take a close look at that and evaluate what we learned today. And then we'll certainly be applying that as we get ready for launch.
The big question is, as you just mentioned, getting ready for launch. What does that mean? And what are the chances for a launch here on the 27th?
Well, I think we'll take the data and we'll go see what it tells us. I am extremely encouraged by the test today, getting through all the objectives, and we're setting up in our scrub turnaround to begin replenishment ops in preparation for our launch day. Like I said, we'll go take a look at the data. I think I don't like to get ahead of the data. And so I'd like the team to have the opportunity to go look at it, to see if there are changes we need to make to our loading procedure, our timelines, or if we're good as is. But I'd like the team to have an opportunity to look at that before I speculate.
And last question on the team itself. As we encountered that first leak, you could kind of feel the room deflate just a little bit. And then as they worked it and got past it, there was a lifting, so to speak, of the room. Talk about kind of what you went through.
That is a relieved launch control team, man.
And what you saw your team and how they reacted.
Well, I'm really proud of the team. I think they reacted well. You're going to be disappointed when you see a leak, and I think that's normal. But what they did is they went and looked at what are our contingency procedures, what do we have in place, how do we work our way through it, and they went through those ops just as I would expect them to do, and we were successful in managing our way through it. And you're right, as we began to see that those contingency procedures were successful, certainly there was a lift within the room, but I couldn't be more proud of the team today and the work that they did.
And so now you march on and get that data, take a look at it, and see where it leads us. Charlie Blackwell Thompson, Launch Director for Artemis, appreciate you being here. Thanks for taking the time, and that'll wrap it up for us here at NASA TV and the Kennedy Space Center. Our our test coverage complete today. And stay tuned to all of our social media channels for more information.
It always leaks, Buck. They were talking about the leak flow rate levels.
About where we go from here, want to just say that in regards to the Artemis program, it is a new era of lunar exploration. NASA and its partners will lead humanity forward to the moon and prepare us for the next giant leap, the human exploration of Mars. If you'd like to learn more about Artemis 1, just go to our website, nasa.gov/Artemis-1. For all of us here at the Kennedy Space Center and NASA, I'm Daryl Nail. Have a great evening.
Well, that's good news. All systems are checked out on SLS. They fixed all the bugs, man. God, yeah. They said they don't want to get ahead of the data, but also at the same time, I think if the range says they're good to go, they're good to go. Yeah, that's awesome. Scary with the SDS 71 info bit for the 71-month resub. Shuttle docks with Mir, super historic mission with an all-star cast. Eileen Collins commanded that mission, if I'm remembering right. 5% leak rate would have triggered an abort now, right? No, they said that a 5% leak like that is not that big of a deal during fast fill operations, because it was a fast fill, it was a leak on the vent line. Not the fuel line. There's a 5% leak rate on the vent line, not fuel, which is apparently has a different set of criteria that I was not aware of. Yep. Good to go for wet dress rehearsal number 8. Finally done with work today. How are we looking? All test objectives achieved, Payne. Yeah. They dropped the pressure. They dropped the pressure inside of the hydrogen GSE tank. And lowering the pressure and initiating a slow fill with drop pressure inside of the tank seated the valve correctly. And then they switched to low GSE tank pressure fast fill. The leak rate went down to 0.5%. And then they repressed the GSE tank back up to where it should be. And the leak rate stayed consistent. They did encounter some leakage on the vent line at about 5%, and that seems to be okay. It didn't really bother them. It was only for a little bit, and it's when they were transitioning into fast fill, high pressure fast fill. Vehicle went into replenish mode just fine. Once they were in replenish, they pressed the tanks for flight, shuttle style, same thing, bled the engines. And then when they pressed the tanks, they did a high-pressure engine bleed. Worked perfectly. Then they tanked the ICPS. Initiated slow fill on ICPS. Fast fill. And then replenished with ICPS. And yeah. That's it, dude. Everything worked. Everything worked great. I would say my gut's telling me 27th is looking fine. It depends on what Delta 45 says. When does your flight get in? I'll be there to pick you up. 5%. It's the percentage of flow rate. Yeah, also LEL. Yes. Mm-hmm. Yes, that has something to do with it. Going on vacation, so I'll have to get y'all the Hasta Blan on VOD. Good luck finishing the season strong. Thanks, man. Thanks for all your help. Why fill so fast? Because he can. You don't want to sit there for a week trying to fuel the rocket with cryogenic propellants that like to boil off. That has a lot to do with it. But the thing is, you can't really flow hydrogen really too incredibly quickly or else it leaks. I think they know that now. But yeah. Yep. Everything is good, man. Everything is good. Really good news from SLS. Great news from Rocket Lab today. Yeah. Good, man. This is, dude, it's just fantastic. I'm so freaking proud of those NASA engineers. They owned up to the problem. They stayed accountable to the problem, and they fixed it. Took ownership of it. The SEAL shouldn't have been doing that. They took the thing apart on the pad, put the sucker back together, tested it, and fixed it. Damn, that feels good. What a victory. And we will be rewarded for that victory with a flight to the moon. Pending range approval, Nickade, but yeah. I would not make plans on Tuesday. Let me put it to you like that. I would not make plans on Tuesday. Moon, here we come. Moon Exploration Part 2. Mooner Boogaloo. That's so good, man. It's so good to hear. You have no idea. Palg? What's that, Thomas? I'll see you next Tuesday, Forlong. Wait, Thomas, I already have this up. What do... Flying the night before, camp at my house, go watch the launch. I'll send you home easy. If I'm going to do it, I'm going to drive down. Even with high gas prices, it'd still be better to drive down. Problem is, I kind of can't. I don't know really. Well, I want to cover it here, man. Don't get me wrong. I'm coming down to Artemis 2. You have my word on that one. I don't have any of the equipment ready for a driving stream. You know, collar my pants down. Want for me. I got Starlink ready to go. Yeah, but the Starlink gets jammed up whenever there's a launch, dude. It doesn't work. Ask Tim. 24/7 Cape coverage. Yep. Fleet Cam evolved. Space Coast live. Oh, okay. Oh, Thomas, I'm stupid. This is permanent coverage, isn't it? Oh, man. With upgraded SRBs, could the SLS core stage be sent to low Earth orbit and be used as a fuel depot or a wet workshop? Right, Flyer, if you put no payload up on top of that thing, you don't even need an upgraded SRB. The answer is absolutely yes, and it should be used for that. Yeah, it should be used for that, absolutely. Did I miss anything special? The tanking test, Moose, went off without a hitch. Everything is good. Vehicle's good. They're safing it now. NASA gonna review the data like they always do, but I would not be making plans during the day on Tuesday. I would not be making plans. Yeah, I would not be making plans because NASA has to review the data and we don't know for sure, but I'm pretty confident that that thing is going to go that way. Are you covering the possible Tuesday launch? Yes, I am.
Discovery, go at throttle up.
Natch, 18-month resub. Gracias, amigo. ¿Cómo estás? Oh, man, that's so cool. Will we know by noon tomorrow if they plan to go? It depends on how long it takes to assess the data, Aldezert. I'd say we'll have a word on it by Saturday, Friday at the latest. Is the NROL launch on the 24th the final Delta IV Heavy? No, it's the final Delta IV from Vandenberg. There's 2 more Delta IV Heavies, and both of them are going to launch from Slick 37B, Rocket Man, and after that, that's it. No more. The 27th Natch is a Tuesday. Yeah, it's a Tuesday. Anyway, all right, fellas. I am going to take a break. I've done 10 hours of streaming today. My bad, thanks. Don't worry about it. Martes. No jueves. Martes. All right. Can't remember when the FRR is planned for. Probably Saturday. Yeah, the FR. Yeah. Flight readiness. They might not even do it, Mappy. It really kind of depends. Mucho queso. Anyway, your pronunciation is on the spot. Gracias. Gracias. I love the 10-hour space news days. Yeah. Good night, Milhay. I got a tweet.